Johnny Walker po, kagabi. Good morning po, VPI. Lindon, Sir Lindon po.
Morning. Morning.
Good morning, Engineer Chris Fernandez. One of our technical speakers yesterday.
Morning, everyone. Morning.
Morning to all attendees and participants. So we'll just be waiting for the others to log in, no, before we formally start with Engineer Prime's presentation. So just a little more indulgence, and we'll be starting in a few minutes. So to our participants, good morning. Morning to everyone. To our panelists and to our attendees, welcome to our 20th Eastern and Central Visayas Regional Conference hosted by IIE Cebu Chapter. So this is sponsored by 3M, Panasonic, United Electrical Specialists, UES, Brills, Lozare Solar and Huawei, Phone Control Centrical Corporation, Nodal Electric Electrical Services, American Wires and Cables Company, Duraflex, Lauron Refrigeration and Air Conditioning System, our technical sector speakers, so this is a 4-day event with the last day of land tours tomorrow, September 19. So our keynote speakers, so one of our sponsors, Pubs Dutch, Long Eye Enterprises, Long Eye Pineapple Fabrication Corp, Prisma Electrical Controls Corporation, Panasonic, .3M, So once again, we'd like to remind our attendees to please do check out our event hub for our sponsors. So there's a link there in the chat box. So you can explore the event hub without even leaving the webinar format. So there's no issue about your attendance. You can just explore the event hub without leaving our Zoom webinar. So please do check out our event hub. So we'd like to welcome all our attendees from different chapters of IAE, especially here in Eastern and Central Visayas. So we have attendees from Cebu, 5 chapters here in Cebu, plus Cebu, Cebu North, Cebu South, and Mactan chapter. And we have Bohol chapter. We have Samar Leyte chapter, Isabelete chapter, Ormoc chapter, and Samar chapter, Negros Oriental chapter, and soon to be Calbayog chapter, Maasin chapter, and Biliran chapter. And last but not the least, Northern Cebu chapter. So these are the chapters that are planned to be formed within the year. So this is one of the advocacies of our regional governor, Iping Niyama. So let's watch out for those developments, and hopefully by the year ends, these chapters will now be formed to better serve our members. So thank you for that updates, Go Iping Yama, and good morning to everyone. So we now have in the Zoom please 125 or 150 or 140 attendees and counting. So we'll be starting in a few minutes now, and we'll be setting up the timer. So just sit back and relax, and in a few minutes we'll be starting our lecture of Engineer Primo Beltran. So we'd like to encourage everyone to please log in now. We'll be starting in a few minutes. So we have our blockbuster speaker, Engineer Primo Beltran, starting in a few minutes. So it would be very unlucky if we'll not be able to attend his lecture this morning. So we'll be talking about numerical relays, and we do hope you'll be with us in this whole day's lecture. So please log in now. So those who have been able to log in, please call your colleagues, your friends. Please log in now. We will now be having less than 3 minutes to start the lecture. Okay, so good morning, everyone. Good morning to our attendees of this 20th Eastern Central Visayas region. So with me here on site is our regional governor, Goviping Nilyama, and we'll be starting now with the first lecture. So please settle down, everyone. So our first technical resource speaker of the day is one of the blockbuster speakers we have in IIEE. So currently he's the principal and lead electrical engineer of Worley, Canada, and also the senior electrical engineer of Vetica, Canada. So he have various work experiences from other companies as senior field technical QA engineer and lead electrical engineers. And he has conducted several webinars in different chapters of IIEE. So he's been discussing about power systems, short circuit calculations, and electrical audits. And he's also one of the managers of Safe Plus International. It's a training academy recently being formed. And his specialization is in the electrical distribution system design, power system studies, power engineering, technical design team management, field technical and QA engineering, and his sub-specialization is on electrical heat tracing, cathodic protection, distribution impact studies, solar PV system design, pre-commissioning management, and project engineering. So without further ado, please help me welcome our first technical speaker of the day, none other than Engineer Primo Beltran, to talk about numerical protection relay basic application. So let's give him a round of applause. So take it away, Sir Prime. Sir Prime, are you ready?
Nakamute ka.
Nakamute po kayo, Sir Prime.
Oh, sorry, nakamute pala ako. I was talking to myself. Maliwanag po ba?
Yes, loud and clear po, Sir Prime.
Okay, before I start, I would like to thank Eastern and Central Visayas regional conference organizers, hosts, chapters, our regional governor, and of course to all the crews, fellowship band members, everyone who contributed to the efforts to make this occasion successful, and to our national IIE office and in the general membership. So this is just a short, limited time webinar. So I will try to provide as much as I can, given the time allotted to me. Okay. So let me share my screen now. Okay, so today's for the numerical relays basics. So ito po yung ating topic for today. So before we get to the evolution of these relays and stick with the numerical relays, let's start with protection zoning again. Medyo nag-e-echo ako dito. So is it okay sa inyo dyan? Let me put another speaker. Okay. Hello, Sir Brian. Is it clear? Hello.
Yes, it's clear na po, Sir Prime. Very clear.
Okay. Yeah, because I'm hearing some echo here, so I thought baka may problema. So okay. So when we say protection, so basically the relays are basically the sentinels, and they get their inputs from the instrument transformers. They on a preset program settings, they will pick up if a threshold is na exceed, and then uutusan nila yung circuit breaker na mag-trip. And basically, the arrangement of these relays or any relay is based on protection zoning. So kung meron po kayong power systems po dito, let's say you got these transformers here. Let's see if I can come up with a spotlight. Let's try this spotlight. So wala akong makita kasing anyway, I'll just use my cursor.
So basically, kung makikita nyo ito, meron tayong protection, meron tayong generator, meron tayong transformer, meron tayong switchgear, it's feeding another MCC downstream, meron po tayong transformer din po dito, it's feeding another switchgear, and so on and so forth. Basically, when we do protection, we always apply on an N-1, or in some special cases, may tinatawag tayong nag-fail yung dalawang tier. So in a basic relay arrangement, lagi nating sinasabi na we operate on a primary protection, and then there will be a backup to it. And that backup, pagdating sa sarili niyang zone, magiging primary naman siya sa zone na yon, and then meron na naman higher na mas mataas na backup na naman. So in this particular case, kung meron tayong motor dito, which is motor M1, okay, sa baba, so meron tayong tinatawag na motor zone. It's protected by a fuse, and probably there's going to be an overload, mechanical jam, and so may relay po tayo dito. And that relay is going to open a contactor. Okay, it's safe to open a contactor because hindi naman po short circuit yon. But that will be considered as the motor protection zone. So ang fuse will be the primary protection for the motor in terms of short circuit, yung F1 po dito. Okay, and then yung relay naman na siya magte-take care sa ground fault if it is resistance grounded, or it will take care of the overload, it will take care of mechanical jam, negative sequence, and anything that is an overcurrent but it's not considered a high value current or a fault current that is capable to be interrupted by the contactor, that relay is going to protect the motor by tripping the contactor. And then if the contactor or the relay fails for some reason, meron tayong tinatawag na backup. And that backup will be the breaker on the MCC, which is basically shown here as breaker number 8. So so meron tayong tinatawag na primary pagdating sa motor, meron tayong backup kapag nag-fail yung relay or nag-fail yung fuse doon sa circuit ng motor. And this backup will be this breaker. It will have a time coordination between the relay sa breaker na to. Yung relay po, external po yon. Nagsesense po siya through current transformers, and tinitrip po niya externally yung breaker. Okay? So may trip coil yung breaker, ititrip nung relay. So in this particular case, magkakaroon tayo ng tinatawag na backup. And then, pagdating naman sa backup na yan, pag meron tayong fault sa MCC, then that backup relay becomes the primary protection of the MCC bus. Bakit? Kasi yung fault location sa MCC, ang makakakita lang niyan, yung mataas na current na manggagaling sa utility, is yung relay dun sa breaker 8. Hindi na po makikita ng breaker, ng relay dito po sa motor. Kasi magbabackfeed lang yung motor, at ang value lang po ng backfeed na yon is just the starting current as an estimate. Okay? So magiging primary protection yung relay sa breaker 8 kapag ang fault nasa MCC, at kapag nag-fail naman po yung relay doon sa zone na yon, then ang magiging backup naman is yung breaker 6 sa taas. And so on and so forth. So merong hierarchy na tinatawag. Ang isang backup sa isang primary, maaring siya na rin yung primary doon sa protection within its zone. And then from there, meron na naman siyang backup sa taas. And yung backup na yon, kapag in this case, kung may relay tayo sa breaker 6, nagkaroon ka ng fault sa cable L1, then magiging primary protection naman ng cable yung relay sa 6, and then magiging backup naman siya yung relay na nasa breaker 3. And so on and so forth. Kaya may cascading effect. Kapag yung isang relay nag-fail, magkakascade siya sa taas. And the problem with cascading is that mas malaki yung maaring yung relay na yon, ang ititrip niyang breaker is mas maraming loads na maapektuhan. However, you cannot do anything about it because what you don't want is yung backup ng backup ang magtitrip. Then mas malaki yung outage, right? So in some cases, most protection engineers, kapag nasa mataas na voltahe na po, at kapag yun ang nag-trip, malaki site-wide ang magiging blackout, naglalagay sila ng redundancy sa relay. So merong A and B naman. So hindi na siya primary and backup. Within the primary protection itself, magkakaroon ng A and B. So that kapag nag-fail yung isang relay, then yun yung tinatawag na N-2. Okay, hindi na siya N-1. Kasi yung N-1 is kapag nag-fail yung primary, yung backup ang susunod. Pag sinabi mong N-2, redundant ka na. Meron ka ng redundancy sa relay. And the advantages of having two relays, A and B, looking on the same zone, acting as a primary protection, is that kung itetest ko yung isang relay, hindi ko kailangan i-shutdown yung feeder kasi active pa yung isang relay. So yun naman yung advantages nun. Of course, there is cost associated with it. And that's why you only apply redundancy on systems that are already critical or on systems that will have the tendency to black out your facility. Okay, so it depends on how much the reliability you require, because reliability always is directly proportional to cost. So there's economic factors. So enough with this zoning. Okay, so in this particular case, kapag meron tayong so in this particular case, meron tayong transformer, may primary breaker tayo, may secondary breaker. Of course, the protection zone of your switchgear, the primary protection will be the relay that is associated with your secondary breaker. The backup for a fault on the switchgear is the relay associated with the breaker on the primary. Okay? So, in terms of protecting the transformer, what is your primary relay? First, relays that are already that is already inherent to the transformer, which is basically yung mga tinatawag na pneumatic protection or non-electrical protection, like yung ating level gauge, yung ating pressure relay, meron tayong thermal relay, maaring winding or tap oil, meron tayong pressure relay, meron tayong Buchholz relay, meron din tayong tinatawag na sudden pressure. So those are inherent to the transformer. And that is the primary protection of the transformer. So ano yung backup protection ng transformer? That will be the relay on top, which is only sensing over current. So if we are looking at the transformer as a zone, then your primary protection is your paki-mute lang po yung mga mics. Thank you. So if we are looking at the transformer as a zone, your primary protection are the relays that are inherent to the transformer. And your backup is the overcurrent relay on the primary. Okay? But the overcurrent in the primary is only in terms of current. So may fault or overload in terms of current kasi current lang ang nasa-sense nung relay mo sa taas. When you are having a switchgear and nagkaroon kayo ng fault sa bus ng switchgear, that means yung primary natin protection is the relay associated with the breaker here that is basically an overcurrent looking at the switchgear. It's not being shown here because this zoning is only for the transformer. It was meant to show the transformer only. Pero in reality, meron pa tayong 51L. So itong 51L na to, ito yung primary protection ng switchgear mo. And yung backup niya is yung 5051H naman, which is, ibig sabihin, high tension or the primary. So pag nag-fail ito, yung primary ngayon ang magti-trip with a coordinated time and with a ratio of transformation doon sa equivalent fault doon sa primary kapag may fault ako sa secondary. Of course, kung may fault ka sa primary, ano yung primary protection mo? Yung 51H na. So, yung 5051H na nasa primary is going to be the backup for the 51L downstream for a fault on the switchgear. However, the 5051H will become the primary protection kapag may fault ka naman dun sa primary sa transformer. Or just at the secondary bago sa 51L. Bakit? Kasi blind spot ito. Hindi makikita ng 51L. Ang makakakita lang dyan yung 51H. Okay? So that's also the same on the same case on the ground fault. However, in this particular case, since naka-delta tayo, may hindi makikita ng primary yon kasi putol yung zero sequence connections natin, right? Anyway, that's another topic. But this is your primary protection and this is your backup for a fault on the switchgear. And this yellow line is your primary transformer protection, and the upstream breaker 52L, actually dapat 52L is, or 52.1 supposedly, is going to be the backup for your transformer protection. So this is how we interpret based on zoning. Kaya kung gumagawa tayo ng time current curves, I normally, as a practice, I go by the zoning. So gusto ko makita yung zone 1, isang TCC. Yung zone 2 ko, isang TCC. So yung zone 1 ko will show both primary and backup. And then yung backup na yung magiging primary siya ng kabilang zone, isang TCC na naman yon. In that way, it's easier for me to interpret the time current curves. And I'm assured that I am evaluating a primary and backup scenario. Okay. Now, when you do protection and relaying settings, you normally conduct different studies, and then they all feed into the relay coordination exercise. Maaring gumagamit kayo ng program, ETAP, or ginagawa nyo mano-mano. There is no difference between the two, except in ETAP you have more, you save time generating the curve kesa pinaplot ninyo ng mano-mano. But if you see here, for you to do a relay coordination, of course, you need to know what is your minimum short circuit. Of course, may motor starting ka because bakit kailangan mo ng motor starting? Kasi minsan, ayaw mo na mag-set ka ng relay and then nag-start yung motor, nag-trip yung relay mo. So kailangan i-allow mo yung motor na mag-start. And you allow the protection that is associated with that motor protection to trip first before na mag-trip yung feeder mo. So there's always that factor na kapag ini-start ko yung isang motor, assuming na tumatakbo lahat, dadagdag yung starting current na yon sa existing load current. And yun na magiging basis mo na iiwasan mo pag nag-set ka ng incomer breaker mo. Okay? So you got, of course, you need the single line diagram, yung relay information, yung instrument transformer information so that you can do your ratio transformation and all these things, yung information ng breaker. And in some cases, kailangan kung nag-arc flash kayo, kailangan din niyo yung information para sa yung ano yung requirement niyo sa arc flash. Kasi the relay coordination will also give you the clearing time, which is basically going to feed into your arc flash calculation, which is in a dumb way, it's an I squared T. Current squared T. Kasi energy ang arc flash. So there's always the T. And what is the T? That is your clearing time, which is basically your pickup time plus your breaker interrupting time. Okay? And of course, yung I is your fault current. And then once you do this, you create a protection coordination report. And based on that report, you create your relay settings. And then these settings will be incorporated or applied into your relay. So in the hierarchy of relays, nagkaroon tayo ng electromechanical relay, which is the first generation relay. Normally, this was in the 1900s to 1960s. Kaya kung nakakakita kayo ng mga relay na ganito, matagal na yung mga yan. Maaring na-stack lang sila and then na-i-apply. So nakakakita pa rin tayo, pero basically between 1900s to 1960s or 70s sila, prior to 1980s. And then from electromechanical, nagkaroon tayo ng solid state na tinatawag, which is basically electronic na. However, they are not fully digitalized. Kaya naging parang analog pa rin siya. However, you don't have any mechanical parts anymore. Yun ang pinagkaiba lang po. And then, of course, we got the good old-fashioned solid state relay, which is gumamit tayo ng mga transistors, integrated circuits, and all these things, right? And then, ito na yung present time, which was developed on somewhere in 1980s, and then na-develop na lang siya up to date hanggang ngayon. So, ito na yung tinatawag na numerical multifunctional digital relay. Bakit numerical digital? Parehas silang sila. Digital is something else. Being a numerical microprocessor is another thing. Because when we say numerically digital, ibig sabihin there is already the communication portfolio for it. Okay? There's already the logic for it. Okay? Parang sinabi natin na kung ano yung computer ninyo, nag-a-act na siya na ganun. Kung ano yung server nyo sa opisina, nag-a-act na siya na ganun. Of course, yung server natin sa opisina was built for some purpose, and ang pagiging computerized ng relay ngayon is built on another purpose. Okay? And that's why there's standards governing them. So makikita nyo, here's the somewhere between 1900 to 1963. Okay? So makakakita kayo dito ng itong dalawang to is GE. I think the one on the left side is a bit of a Westinghouse make or itong nasa gitna. If you see them looking at the disk, those are induction disk type. So umiikat po yung disk na yan. So kapag nagkaroon ng overcurrent, it creates an electromagnetism on the coils, and then it's going to make the torque or the electrical torque that will be generated will move the disk, and that disk will have the contact which is moving, and it will hit the stationary contact. So yung mga settings natin dyan is a set point on it's either kung ano yung gap ng dalawang contact or kung gaano kalakas yung electromagnet. Okay? However, if you look at them, they are very, very bulky and they are highly mechanical. So if you say mechanical, kailangan nyo ng maintenance. Okay? You have more point of failure back and you have inaccuracies. Okay? Kasi yung disk natin pwedeng mag-over travel. Kaya nadadagdag yan sa coordination kasi may error. Okay? So, what are the disadvantages? So these are the types. You can have a plunger type, which is basically attracting the contact through a plunger, or you will have the disk type, induction disk type, which is yan yung pinaka-popular. Yung plunger type, ginagamit yan sa mga mas maliliit na relay. Yung mga malalaking relay na pang high voltage, mostly na ginagamit yung induction. So disadvantages, low speed of operation, kasi nga mechanical siya. You can't help it. It ages. So ibig sabihin, since you have mechanical moving parts, it will age. And you have to maintain it frequently. So there's a operational cost associated with it. High probability of component failure due to moving parts. So kailangan mini-maintain lagi yan. And that's always an OPEX cost, operational expense. Okay, and of course, reliability issue. May significant na bouncing time kasi minsan yung contact kapag nag-hit yan, magbabounce pa yan. So magkakaroon ng konting arcing doon. And kailangan, yun ang nagkukos ng failure most of the time over time. Well, kung hindi naman nagtitrip yung system nyo, it may not be an issue, but you still have to maintain that frequently. Minsan tinitrip yan ng purposely para lang ma-exercise. Sabi nila, minsan tinutulak. Nakikita ko yung mentor ko nung nasa Napocor ako, tinutulak niya sa eraser ng lapis yung disk eh. O anong ginagawa niyo, sir? Ine-exercise ko yung contact para malaglag yung mga likabok. Sabi, talagang tinitrip yung breaker. Okay? So, ganun yung problema sa ganyan. So, over travel, it adds delay to your coordination time because you have to overcome that in your coordination. And of course, in the advent of arc flash, nagiging disadvantageous kasi imbes na ang CTI mo mapapaigsi mo, hindi mo mapaigsi dahil may over travel ka pa. Okay, may error. No metering and indication functionality. Nung unang panahon, yung mga mechanical relay na yan, flag lang. Kung waga may red lang na lalabas strip, wala na. Hindi mo alam kung aling phase. Well, alam mo kung ano ilang phase kasi isang relay, isang phase. 3 relay kailangan mo na ganun kalalaki. So, anong mangyayari pag ganon? It occupies more space. Okay? Yung coil ng mga to, since electromagnet siya na talagang electromechanical, then what will happen is it will give more burden sa CT mo. So, kung ang ginagamit mong electromechanical noon, kailangan mo ng C400 accuracy, which is 400 volts. Ang mangyayari ngayon, pag ginamit mo yung static or numerical, baka C200 lang okay na or C100 kasi napaliit mo yung burden ng relay mo. Hindi katulad yung mga solid state ngayon, milliamp na ang kailangan niya as a burden. Pero nung unang panon, baka in terms of amperes pa. Kaya ang laking burden yan pag idinagdag mo pa yung ohmic value ng 2-wire mo and then yung ohmic value ng CT mo. So, B is equal to IR. So, yung R mo, yung I, wala ka na magagawa doon. Yun yung fault current mo eh. Converted through the transformation ratio of 5 amp or 1 amp. Sa secondary ng CT, i-multiply mo yun sa R, So kapag nakakuha ka ng 380 volts plus times 2 siguro or 1.5, then baka 600 ang kailangan mo. Malaking city yon. Pero ang application mo ito lang. So ngayon, mas nakakatipid na ngayon. No input voltage isolation. So expose yung city mo, your input to that relay is exposed to the utility power. That means through a transformation, that means yung harmonics, yung transients, yung mga over voltage, pupunta lahat sa coil mo, and yun naman nagiging cause ng pagkasunog ng mga coil. Okay? Or minsan, nuisance tripping. Okay? So, dahil wala siyang voltage input isolation ng araw, exposed. Sensitive to vibration and temperature. Of course, it's a moving mechanical part. Yung coil mo is also subject to ambient as well. And vibration. Naalala ko nung nasa Juwaima kami sa Saudi Aramco, puro sila electromechanical, directional relay yun. Naka-normally close lahat dahil gas plant yon. Naka-normally close yung mga tie nila. Very critical. Sabi nung nag-escort sa aming Arabo noon, oh, ingat kayo sa mga to Huwag niyong bubuksan kasi sensitive sa vibration to. Alam niyo bang paglapat niya yung kamay niya doon sa pinto, for some reason umuga yung pinto, nag-trip. And before we know it, nagpuntahan na yung National Guard doon, nandun na yung fire brigade. So, these are the problems with electromechanical. They are very sensitive to vibration. And since they are moving parts, you don't want to vibrate. Okay? Now, less range of settings. So, tumatalbog yung mga settings nun. From 0.5, magiging 1 amp na agad. From 1 amp, magiging 2 amps. So, anong mangyayari pag ganyang kalalaki ang agwat niyo sa relay? Yung coordination ninyo sa pick-up settings, mas malalaki ang agwat. So, hindi nyo siya mapapalapit as much as possible doon sa protection ng equipment ninyo. So, halos lumalayo siya and then malapit pa siya doon sa damage curve. So mas maganda, so may limitation yung mga electromechanical. And like I said, ito phase A, phase B, phase C. Mantakin nyo, tatlo agad. Tatlong overcurrent lang yan. Tapos yung panghuli, yun yung ground fault. So ibig sabihin, nagkaroon kayo ng residual connection na pumunta doon sa ground fault relay. Okay? Physical size is bulky. So ito yung mga disadvantages. So dati, very limited po kayo, right? Makita nyo, dalawang relay yang nag-residual connect. Itong tatlo na to, ito yun, 1, 2, and 3. Kaya kung nakakita kayo ng symbol na 3 dyan, ibig sabihin tatlong separate devices yan. Yung isa lang. So makita nyo, 3 plus 1, 4. Kaya 1, 2, 3, 4. Yun po yung interpretation po niyan. Okay? Now, ito yung protection zone, backup zone. So we already touched that. And by the way, this handout, I already sent it to Engineer Brian, so he will, bahala na po silang mag-distribute. The second type of relay was considered as the solid state. So ito po yung medyo higher version na, and makikita nyo, gumamit na siya ng electronics, wala nang moving parts. Okay? So makita nyo, puro mga deep switches. So all in all, it resolved all the problems of an electromechanical relay. So finer settings and everything. Okay? However, ano yung limitations niya? Sensitive pa rin siya sa over voltage o voltage transient and harmonics. Sensitive pa rin siya sa ambient temperature, like most electronic equipment. Less robust due to electronic sensitivity, of course. So may probable na component failure dahil electronics siya. Limited multifunction element available. This is one key that is a limitation for the static relays. Limited lang yung protection elements nila and control elements. Not enough measuring data available. Wala pa akong nakitang static relay na in combination na nagme-measure ng data. Okay? Unless they are a static metering. Pero wala pa akong nakikitang naging combination of both. Purely analog pa rin. You still need to convert that to digital to communicate with it. Inherent control logic is fixed. Ibig sabihin, hindi nyo mamomodify yung logic niya. Nakaprogram na siyang ganon. Yung internal electronics niya, nakaprogram niya to do one thing. And all you need to do is set it and then it will give you the required output. Hindi nyo mababago yung logic. Okay? And Here's the numerical relays. Kung makikita nyo, isang malit na compartment, dalawang feeder, isang relay lang siya. Hindi katulad pag ginawa ko siyang electromechanical, baka itong compartment na to, inoccupy na ng yung isang feeder lang. Kaya magastos ang mga switchgear noon kasi isang switchgear feeder, isang section. Hindi katulad ngayon, dalawang section, isang section, dalawang feeder na. Kasi in the use of the numerical relays that is multifunction and programmable and digital, you are able to fit more feeders in one vertical section. Okay? And I'm not trying to advertise GE here. Nataon lang po na GE ang mga ginamit namin and sell. Okay? May iba kami Siemens. So, what is the advantages over the solid state? Of course, eliminating all the negativity of electrical mechanical relays, plus wide range of protection functionality. Ibig sabihin, sa isang relay, makakakuha na kayo ng directional relay, overcurrent relay, meron na kayong direct negative sequence relay, you can have everything. It depends kung anong type ng numerical relay ang bibilhin nyo. So, you're having some sort of pre-investment. Kasi, although kukunti lang yung kailangan nyo, kung parehas lang naman ang price between this and that, bumili na kayo ng isang package. Right? Mas mura na siya in a way. And it will give you the flexibility. Lalo na po kung meron kayong main time main, dinesign nyo siya na normally open, and later on gusto nyo i-convert to normally closed, di kailangan yung directional element, then that means yung relay na yon meron na siyang function. Ano pa ang isang maganda dito sa numerical relay? In one overcurrent, you can have 2 to 3 set points. Ibig sabihin, sa element na 51, pwede ako magkaroon ng 3 groups ng setting. So, isang setting para sa normal, isang setting siguro para sa arc flash mitigation. Para kung gumagamit kayo ng arc flash mitigation switch, para pag switch nyo yun for maintenance, magiging instantaneous lahat yung overcurrent relay nyo. Mawawala yung coordination. So, meron kayong set 1 and set 2. Pwede ring ma-program nyo yung set 1 para normal coordination, and ma-program nyo yung set 2 na pang-energize lang ng transformer. So kapag na-energize na yung transformer, automatically yung relay na program na nababalik siya sa set 1. So nag-set 2 kayo to allow energization, and then from there, automatically mag-switch siya sa normal protection. So kaya may set groups. So you have that kind of flexibility. Of course, you can internally program the logic. Parang PLC. Right? So, hindi katulad sa static, you are fixed on what an element can do in terms of logic. Yung kanyang in and out. And in between is the processing. So, pag nakuha niya to, nag-set ka, lumabas. In a numerical relay, you can program it like a PLC. So, how does that work? All the inputs that will come in, it will go through some kind of logic configuration na iproprogram ninyo. So, pwede kayong mag-program ng mga logic na OR gate, AND gate sa loob. Pwede kayong gumawa ng interlock sa loob. Pwede pa kayong gumawa ng output within the program itself. So, ang sinasabi lang natin noon, input here, output there, puro hardwired, right? Internally, you can create another output or input that is going to get diverted within the logic. So parang sinasabi ko, lahat ipapakita ko mamaya, right? So this is the case. You can do and program it like a PLC. And same thing with yung mga control buttons na, yung mga LED niya, you can do anything you want with it. And that's the good thing about numerical relays. You can, like I said, input parameters you can configure, including IOs. Ano yung IOs? Input, output. Expandable IO capability. So sabihin na lang natin, ito yung frame size ng numerical relay na yon. Ito lang yung kailangan ko ngayon kasi ito lang yung mga input-output ko na kailangan. Pero yung case niya, suitable na siyang maglagay ka pa ng cards. Ibig sabihin, pag gusto mo mag-expand pa ng marami pang input-output, pwede kang bumili ng card lang and then i-input mo lang and then i-program mo lang and that's it. Okay? Hindi katulad nung araw na kapag ito yung nabili mo at ito lang yung dami ng input-output niya, yon hanggang doon ka na lang. So anong ginagawa ng iba? Kasi limited sila doon. Naglalagay sila ng tinatawag na interposing relay to multiply the contacts. And the problem with interposing relays, dumadagdag sa delay yan ng tripping. Kasi cascaded eh. Na-energize to, energize yung call. Pagka-energize yung call, saka pala mag-energize yun. So magmumultiply lang ng contact. Secondly, hindi maganda yun sa arc flash kasi nadi-delay yung arcing, yung clearing time mo. In this way, you are able to expand the cards directly. Hindi na kayo nag-i-interposing relay. And those IOs can be programmed within the logic. Direct communication ready. So dati-dati may static relay kayo, electromechanical, kailangan nyo pa ng conversion from copper to digital, and then from digital to from analog to digital. So para nangyari, kakaroon kayo ng multiple conversions. Most of the numerical relays, you can communicate directly through fiber, through serial communication, which is basically your RS485, yung mga coax pa, and then your Cat6. In some special case, may Cat6. Pero kung walang Cat6 communication yung relay, you can have a media converter. So now you have direct connectivity. Like I said, the numerical relay is already acting like a computer, but the way it was designed is specific for the application, okay? Now, the relays can also talk to each other through serial communication or through, dati-dati yung mga relay, they talk to each other by copper connection and contacts here, contacts there. So, ang daming wiring. Ngayon, you just hook up a fiber between them and they can communicate and you can program them to talk to each other. So that means, how do you do that? Let's say may relay ako na kailangan kong, may differential relay ako kunwari, na yung relay ko na isa nandito, yung isang relay ko nasa taas. So they will talk to each other by fiber using the same CTs that is connected to each one of them. So you can configure them as a differential relay. Wala na yung mga pilot wiring and everything. You just run a fiber. Okay? So they, or within the switchgear, these two can communicate. Okay? Sorry, yun yung ice cream. Naririnig sa bahay. Grabe. Okay. Self-diagnostics. And this is one good thing about numerical relays. Kapag nagkaroon ng problema sa sarili niya, it can send an alarm. Pag merong software problem, it will send an alarm. It will kung nawalan siya ng power supply, it will send an alarm. So it has self-diagnostic capability. You can even run a self-diagnostics yourself. Like I said, it's a computer. It has a wider set of range of setting. Hindi na tumatalbog na 0.5, 1 amp, 2 amp, 3 amp, 5 amps. You can even have the finer intervals of 0.01 interval. So now pwede nyo niyang palapitin doon sa pinoprotektahan yung equipment. And it's easy to coordinate because now you're talking about decimal places. And that is good for coordination time interval kasi mas makakatulong sa inyo sa arc flash. Okay? Bakit ko ina-emphasize yung coordination time interval? Kasi kung mapaigsin nyo yun, inherent na yung protection nyo sa arc flash. Hindi na siya yung deliberately na ginagawa ninyong instantaneous during maintenance and then ibabalik nyo. No, you need permitting. That is still considered an administrative control. Hindi siya engineered control. Ang engineered control is kung inherent na yung protection. Wala na kayong ginagalaw. Nandun na siya. Okay? And you can do that by paigsahin nyo yung CTI kasi wala na kayong over travel. Right? So nawala na yung error na yon. So all you need to do now is get it, and you can fine-tune that because 0.01 lang ang interval ng setting. Okay? Wider adoption of protection curve. So, dati, pag bumili ka ng Westinghouse, IEEE lang yon or AIEEE. Okay? Hindi siya IEC. Kung nasa ibang lugar kayo, di baka IEC ang ginagamit, right? Ibang lugar naman kayo, maaring ANSI, IEEE. So, numerical relays, they already have a database in their own turf. That means, pwede nyo nang i-generate yung kahit na anong curve na gusto nyo. Meron na siyang built-in na selection. And in some cases, you can even customize your curve. So nangyayari po to sa mga motor na medyo, eto na yung damage curve mo, ito yung starting mo, ipit na ipit, hindi mo ma-fit kahit na anong curve, pwede mo nang i-customize. And that's the good thing about numerical relays. You can customize a curve to suit your protection, lalo na kung masyado nang malapit yung starting curve mo at saka yung damage curve or yung kanyang inrush sa transformer. Okay? And capability to remote access. So ma-access nyo siya remotely. Makakapag-communicate kayo remotely. Ma-set nyo siya remotely. Makakapag-gather kayo ng data remotely through communication interfaces. Improve accuracy, data storage and security. So ibig sabihin, computer siya, may storage capability siya sa mga data. And if you have that data, then you can use that for reliability assessments. Kung nag-trip, malalaman nyo kung anong time, kasi may clock siya, may time stamping, may synchronization clock yung mga relay. And since they are numerical, and if they are just within your vicinity, then pwede mong isync sa inyong computer clock. So iisa lang ang synchronization clock nila. Para pag nagkaroon ng tripping, makikita nyo yung coordination kasi iisa lang ang scale nila. Hindi katulad pag naka-GPS kayo, kailangan i-synchronize nyo on a global scale, right? And that is applicable kapag magkakalayo mga substation. Small power consumption. So ang city burden nyo maliit. So yung dating C800, baka pwede nyo nang gamitan ng C400. Compatibility with different digital communication protocols. So marami siyang wide range na pwede siyang makipag-usap. And modular siya. Construction, katulad ng sabi ko, lagay ka lang ng lagay ng card. High speed, of course, dahil wala ka ng over travel. And it has a very high pickup sensitivity. Time synchronization, fault recording, and metering and everything else. So it's like, mas maganda pa siya sa shampoo. Shampoo 3-in-1. Ito, all-in-one. Okay? Here's again, it's an GE F35. In a block diagram, in a dumb way, ito yung sinasabi kong input voltage isolation. So may mga opto input transformer siya dito. And this will feed in a lower level voltage through the processor. So meron ka ng filters and everything dito so that mapoprotektahan yung processor. It will also, this isolation in transformers will also allow you to make your relay immune to transients and over voltages. Okay, this is something that the static relay is also deficient on during the time. Okay, so makikita nyo sa processor, ipoprogram yung mga output. May mga inputs din tayo na isolated na pwedeng ilagay sa logic. You have your COM port, of course, your power supply, may display kayo, and your keypad. Yung keypad sa relay. Or you can hook it up with a computer, mag-program kayo, or i-program nyo and then i-upload nyo. So this is another way, one that I did, and makikita nyo may local breaker status kayo, pwede nyo ibalik as an input so that it goes to your internal logic. Yung mga current transformers ninyo and voltage transformer, analog. Other sensing devices like yung kanina, yung mga transformer protection relay ninyo na hindi electrical. Lahat na, dati-dati, lahat yung mga yon pupunta sa isang interposing relay and then pupunta sa breaker ninyo, iti-trip. Ngayon, hindi na ganon. You put everything into the relay because your relay is already the CPU. And then that relay will command the breaker. It will indicate kung saan galing yung trip because you have a contact coming here from your transformer, and then if you program that and define that, then sasabihin ng relay si ano ang nag-trigger in the OR gate. Okay? Same thing if you have a remote tripping. Okay? And in addition to that, you still got the communication. So meron kayong remote monitoring. Ito na yung fiber ninyo and everything. Ito, trip mo yung remote breaker through communication lines, right? External control inputs. So everything is, it's acting like a PLC. So now, imbes na ganyan, multifunction na. So marami kang relay, isa na lang. And this is how you represent one numerical relay. You just have to indicate kung ano yung mga functions dito na in-enable nyo. So wag nyong ipakita yung function na kung ano yung nasa package, hindi na nyo naman in-enable, huwag nyo ilagay kasi nakakalito yun. Isipin ng lahat na naka-active yun. No, they're not active. So in this case, this is a GE F35 relay. Kung hindi ko naman kailangan yung mga under voltage na to, over voltage and frequency, i-disable ko siya, huwag nyo siyang ipakita dito sa single line. Okay? Pwede nyong sabihin sa note kung anong relay yan, F35. Then everybody knows. And Kung ano lang yung enabled, yun lang ipakita nyo rito. Pero sa catalog, syempre, nakapakita lahat. So itong flex elements, ito yung tinatawag na logic. So sa ibang relay, iba naman ang tawag nila, right? Then mayroon kayong metering, configurable output contacts, configurable input contacts, or any input-output, you got your protection, your CTs. And ito yung mga multifunction natin. So you have everything here. Okay? So ito yung typical na F35 and makita nyo dito may mga inputs and the number of inputs will increase if you add more cards. So kung kailangan nyo ng marami, then i-specify nyo kung ilan yung nasa cataloging yun, kung ilan yung input-output nyo. Pero at the end of the day, they're gonna give you one frame size. And you have slots there to put more in the future. You got your fiber optic interface. So hindi nyo na kailangan ng media converter. Of course, this is multi-mode to begin with. And then you got your serial interface, your RS485. You have your current transformer. In this particular relay package, marami siyang multi-breaker kasi an F35 is a bay controller. Although, yung ginagamit namin din siya sa aming tinatawag na feeder na radial. Kasi wala namang price difference yan eh, right? So, hindi katulad nung araw, mahal. Ngayon, nagmura na. So, parang hindi na practical na bumili ka ng tigi-isa-isang function na lang. Bumili ka na lang ng isang function and then you have the flexibility. In this particular case, we're not using this. You can use this in a breaker and a half or a breaker and a third. Okay? So, meron tayong voltage transformer input. So, you can have the capability to meter. You will have the frequency and everything here because you already got voltage and current. You also have either a dry contact or a wet contact. So you have more flexibility here. So ito lang po yung itsura niya, yung F35 yan. So makikita nyo, mako-configure nyo po yung mga indications dito sa kahit na anong gusto nyo. So mapapalitan nyo yung mga label na yan, may sticker yan. And itong mga buttons na to, you can even program a lockout relay within the relay. You don't need a separate lockout relay anymore. You can reset it from here because you are able to program a contact, either it's self-reset or latched. Okay? And how do you program it? Well, you can just get your Enervista software, libre po yun sa GE, and then, and of course, kung Siemens, may libre din sila. Pag Mycom Areva ka naman, may Mycom Studio naman sila. Pag may cell, meron naman silang sarili. So, kanya-kanya yan. And ipoprogram lang ninyo, and then kung gusto nyo gumawa ng report, print nyo, or i-upload nyo na lang yung file dito sa relay, and then mapapabilis yung commissioning. So, imbes na pinagpipindot nyo dyan na manual, which is matagal, i-program nyo na dito, and then i-upload nyo, and then i-test nyo. Okay, using the commissioning manual ng relay. Or, ito, bihirang ginagawa na i-upload nila through cellphone and then pupunta sa modem na secure ang server and then through that central engineering computer, i-upload niya sa relay. Bihira lang po ginagamit ito dahil sa security reasons kasi pwedeng ma-hack. Okay? So, ganito po yung ginagawa namin. Of course, itong server na to is after na ma-upload nyo, ito na yung pinaka-DCS ninyo. Dito na monitor lahat yung relay. So kung gusto kong tignan kung nag-alarm siya, mag-a-appear dito sa computer. Ito na yung HMI ninyo remote. Okay? So ito yung typical na switchgear namin na ginawa. Itong yellow na to, ito yung fiber connection namin. Okay? Yung mga nasa likod, yan mga low voltage supply. Let's say yung 125 volts DC nyo, kung may mga intertrip kayo within the switchgear. Pero ito yung communication interface na namin between relays. So may hardwire kami na pumunta sa isang communication local HMI. Meron din kaming fiber na pumunta sa remote HMI. So this is a breaker like a main tie main. May feeder kami dito. Tapos may tie breaker kami na dalawa. Okay? So yung footprint na paigsi. So imagine niyo kung static ang ginawa nyo, you don't have the capability to communicate, then you still need more equipment or devices. Okay, so I'm not going through here due to time constraints. Of course, nandun pa rin yung mga test switches natin. Hindi mawawala yan. Nandun pa rin yung pistol grip na open and close natin. Okay? But if you look at it, lumiit na ang mga footprint. So ito, dalawang breaker, isang relay. Dalawang relay, ang compartment nila centralized. Okay? So this is an example. Let's say nagkaroon ng zoning and then isa-set ko yung relay. So makikita nyo dito, ito is just a printout, a small portion of the overall relay printout. Itong flex logic na to, ito yung tinatawag na naming logic, ladder logic nyo na pinoprogram. And then this will have an equivalent logic diagram. So habang pinoprogram yan, magkakaroon ng logic na output in the form of a Boolean graphics. Minsan may mga ibang relay, hindi na sila nagproprogram na ganito na mano-mano, kina-cut and paste na lang yung symbol ng Boolean. Pinagkakabit-kabit na lang at pag dinouble click na lalabas yung mga setting. Those are fancier ones, okay? This one sa relay, sa GE, meron din silang ganon. Pero may version din na mano-mano ninyong i-enter. Basta alam nyo lang basahin yung, but the whole thing is like a PLC programming na. So ito, makikita nyo, katulad nito, yung setting natin sa phase current, kunwari, ang pickup is 0.425 per unit. IEEE extreme inverse. Ang TD multiplier ko is 3.2. Actually, hindi time dial pa sinasabi, pero time multiplier setting na po yan. And every setting here, and this is related to that breaker F35. So 0.425, ito yung galing sa ETAP. Tapos itong information na to, ipoprogram namin sa protection. Kaya lang, yung relay, hindi lang naman protection na ipoprogram mo. Ipoprogram mo din yung control. Ipoprogram mo, i-configure mo yung mga output contacts. Ipoprogram mo rin yung mga input voltages mo. So marami kang ipoprogram. Itong TCC is just a small portion of the data you need to program a relay. Maliit lang po itong TCC na to, overcurrent lang to eh. So makikita nyo yung contact inputs, ipoprogram din nyo yan. And ito yung logic. So let's say ito ang pinakasimpleng logic lang na nakita ko sa mga settings na ginawa ko in the past. So gumawa ako ng trip bus para ikunin ko na lahat itong mga trip circuit, itong mga trip elements na to. So itong mga transformer na to, ito yung mga input contacts na galing sa transformer, pumunta sa relay as an input. So kinonfigure ko na siya, nilagyan ko na siya ng mga pangalan, and then ito naman yung mga inherent, yung internal phase over current and ground settings. And then logically, minerge ko sila as an OR gate. Of course, meron akong blocking. Kapag naka-off, syempre, i-block ko yan, naka-off eh. Right? So, you can skin a cat in so many ways. Depende sa client. Minsan yung client, ayaw niya yung blocking scheme. Gusto niya, ganito gusto ko. Ganito yung culture namin, ganun ang culture namin. Then we adapt to that culture. Okay? Hindi namin ini-impose yung one size fits all. Kaya nga, it's an art, right? So, once you get this trip, then I will call this trip bus 1, kunwari, in this application lang. And then gumawa din ako ng iba na naman, ito yung trip bus 3, ito naman yung gagamitin kong pang-alarm. Kasi may PTP failure ako, may communication failure, blah, blah, blah. Ito naman yung hard protection na magti-trip sa breaker. Ito naman yung mag-a-alarm dahil para sa self-diagnostic and remote monitoring. Kaya makikita nyo, may trip coil failure, meron akong self-test, meron akong trouble and everything. Okay? Meron akong trip bus, pumunta sa common alarm. Itong virtual output 5 is output within the Boolean logic. So hindi ito yung output na pumunta sa contact naka-hardwire. No. Makaka-create ka ng virtual input saka virtual output para malaro-laro mo yung Boolean sa loob. Okay? And ganito rin dito para sa trip breaker block. So kung may lockout ako within the logic na nag-operate, iba-block ko yung breaker na mag-close hanggat di nila rin-reset yan. And I called this output as a virtual output 6. So inherently, prinogram ko na yung lockout sa loob. Hindi ko na kailangan ng electromechanical lockout. Okay? Same thing with the oscillography trigger. So ito yung para sa monitoring naman. Okay? Kunwari, nag-operate yung breaker ko, in-on ko or in-off ko. So walang protection dyan. In-operate ko lang. So magti-trigger siya ng control, maglalag siya ng history, mag-stamp siya ng time and date kung kailan ko clinose yun. And all these things are needed, o kunwari, nag-trip ako, magre-record yan So ibig sabihin, for my data collection and for investigation, pag may nangyari, ma-evaluate ko yung time. Makakagawa ako ng tinatawag na forensics and analytics. Same thing when you are closing the breaker, you may have different requirements. May mga naka-ungate ka dito na kunwari, mga interlocks mo, yung mga block closing mo, tapos naka-OR ka, so you can do anything with it, right? Yung push button mo, yung mga indication mo, kailan ko i-reset ito? Lockout ko. Kailangan masatisfy ko itong mga requirements na to. So you can actually build as much as you can. So sa isang main tie main, medyo complicated kasi may mga interlocking schemes ako from breaker A, breaker B at saka yung dalawang tie breakers ko. Sa yung C60 relay ko, yan ang nagko-control sa auto transfer scheme ko. And it also acts as the primary overcurrent protection for the switchgear. So kung makikita nyo dito, ito ginawa ko lang to, ini-sketch ko to nung time na yon para lang maging guide ko kung iseset ko yung relay, ito yung mga dapat kong i-consider na mga interlocking schemes. Okay, you need to do a plan. Hindi yung basta ka na lang magseset. Nakakuha ka ng TCC, yun na yun. No, it's not the end of it. You need to look at your switchgear. Kaya yung single line, kailangan detalyado yung protection and control. Kasi pag sinabi mo sa manufacturer yan, i-provide nila lahat ng contacts na kailangan mo. Okay? And based on the schematics, i-prepare nila lahat yung mga spare contacts na kailangan mo or spare coils. So that pag prinogram mo ito based on the logic na gusto mo, available yung mga contacts or available yung mga coils doon sa switchgear. Okay? Pag sinabi ko, lahat ng monitoring ng breaker ko, hardwire sa relay ko, sa particular feeder na yan. In addition pa, doon sa hardwire ko, papunta sa relay, para may communication, may soft communication monitoring ako, meron pa akong hardwire communication. Okay? So you need to do a plan. May planning stage yan. Hindi yung on the spot ka na lang nagagawa ng kung ano. No, you have to plan for it. And then when you plan, you integrate that into the design kung binibili nyo yung equipment. So you specify the right number of contacts. You specify to the vendor what logic you need. Pwede nilang gawin yon para sa'yo, para mabawasan yung trabaho nyo. Because now, kung gagawin nila yon, they can test it in the factory functionally. Okay? So ibigay mo lang yung, anong tawag mo doon? Cause and effect logic mo. Ito yung gusto kong mangyari. Pag ganito ang status, ganito ang gusto kong output. Ganon. Ikaw magseset nun. And everybody has their own way of doing things, right? So in this particular case, makikita nyo yung fiber communication ko or yung serial ko. Ito yung blue. It can be serial. Naka-interface siya sa isang communication cabinet ko. And then yung mga hardwire ko, naka-interface din dito. Bakit ako may hardwire? May hardwire ka pa galing sa transformer. Pero yung transformer mo, naka-hardwire din sa relay, which is magko-communicate din dito. So bakit ako dalawa-dalawa? So yung mga hardwire ko, pupunta sa isang binary conversion, media converter input from copper to a ribbon connector na pupunta sa main RTU. Bakit ako may hardwire? Kasi itong particular design na to, bukod sa i-control nila remotely, i-control ko rin locally. Kaya lang, ang kaibahan lang ng ginawa namin dito sa particular project na to, kinokontrol namin siya through HMI dun sa loob ng substation. So yun yung tinatawag na local control. So ibig sabihin, imbes na nakatayo yung tao sa harapan ng switchgear at dun siya mag-ooperate, no. For safety reasons, ilalayo namin siya. Kaya naggumawa kami ng HMI. And itong mga hard wire connection na to, pupunta sa HMI na yon na local. Yung mga soft connection, pupunta sa remote. Okay, kaya nagkaroon tayo ng RTU at meron tayong tinatawag na automation controller, which is basically ito po. Ito yung relay namin na pang high voltage, pero ito yung communication cabinet na sinasabi ko. Maliit lang, di ba? Ito yung HMI. Kung gusto kong i-operate yung mga switchgear kanina na pinakita ko, na line up, main tie main, gusto kong i-operate, hindi ako tatayo sa harapan ng switchgear. Nandito lang ako sa likuran niya, sa side, safe location, doon sa loob ng substation. May keypad ako, i-click ko lang kung ano yung gusto kong i-trip. Kaya may hardwire ako na pumunta dito. Kasi kailangan ko makita yung status, kailangan makita ko yung mga blocking circuits ng relay, nakakonekta lahat so that hindi ako magti-trip on a faulted bus, mga ganon, may interlock. And then yung communication naman na yellow, ito yung pupunta sa remote. So kung gusto nilang i-operate doon, makokontrol na nila yon through this remote communication here. Makikipag-usap sila sa relay. Ito namang hardwire ko, makikipag-usap ako sa relay locally. So pinag-separate namin yon for security purposes. Para redundant. Although, pwede siyang tumawid. Kita nyo to? Pwedeng tumawid through the Ethernet switch. So lahat ng relay ko nasa Ethernet, pumunta sa RTAC na tinatawag, yung controller, pupunta sa aking keyboard locally para makontrol ko siya. At the same time, meron din akong main RTU, and then from that main RTU, makikipag-usap pa rin ako through sa mga external interlocks ko, through the Ethernet switch, single mode fiber, pupunta na sa remote. So separate pero nakakatawid sila. And redundant para pag nasira yung isa, meron pa akong isa. Pero mag-a-alarma yung isa kapag may nasira doon or na-disconnect. Ito naman yung plant-wide. Okay? So when we go to responsibility, again, numerical relays is an electrical item. Although electronic siya, hindi pang ECE yan. We decide what relay to use, how we program it, and since itong mga relay na to is inherently factory design and ang liability nasa factory, hindi po pakikialaman kahit tayong mga electrical engineer yung design nito. So that means ang pakikialaman lang natin yung application, yung setting, and then yung interconnectivity na kailangan natin. So we govern the relays. Hindi po i-govern ng isang electronic professional yan. Kasi anong i-istampa niya anong isa-sign and seal niya sa electronics nito? Ano yan, proprietary na ng manufacturer. So wala siyang karapatan na sabing approve yung inherent design ng relay. At wala rin siyang karapatan na sabihin na approve yung application ng relay. Kasi hindi naman siya marunong mag-relaying eh. Tayo ang nagre-relaying, so tayo dapat mag-approve. However, when you go to the communication cabinet na katulad nito, may components dito that requires a communication professional. And ano lang po yun? It's just the Ethernet switch. Yung ating, yung RTU, hindi nila pakikialaman yan. Yung Ethernet lang at saka yung specification ng fiber optic. And then yung sasalo sa kanya on the other end. That's their liability to make it sure that the signal strength is good enough and all the the communication devices are able to communicate from one point to another. That's their job. Pagruruta ng fiber optic sa atin pa rin because it has to comply with code. But the test of those fiber optic that will indicate the amplification of signals kung gaano kalakas, that is their job. Kasi hindi natin ma-interpret yon. Hindi po sinusoidal wave yon. Okay? So, there's a collaboration. But in this particular case, tayo ang nag-govern. Siguro 10% lang sila kung meron silang involvement or 20%. The 80% is all on us. Even system architecture is on us. It's just a collaborated work that will involve them in a small scope. It doesn't mean that they can sign and seal our stuff. They can sign and seal yung part na ito yung communication Ethernet ko, compatible siya sa Ethernet sa kabila. Hanggang doon lang sila. Kahit sa the signal strength. Yung cable ng sila magsasabi kung anong fiber gagamitin mo. Ilang strands, anong klaseng strand, ano yung mga component. Yung signal strength, kapag tinetest, sila ang titingin. But who's gonna lay the cable? It's going to be electrical because it has to comply with the electrical code. So thank you very much, guys. I know I exceeded my time a bit. My apologies, and hopefully nakapagbigay ako ng magandang, in a very short period of time. And the handouts, I already sent it to Sir Brian and the organizers. So pwede nyo pong hingin sa kanila, and it's just basic. And thank you very much po, and to the opportunity, to ARGOB, everyone, in the IIEE family, our national office. Thank you very much. The floor is yours, Mr. Brian.
Yes, Sir Prime. Good morning. Good morning dito sa Pilipinas po. No? Yeah, we're trying to see if there are some questions here in the Q&A or chat box. Okay. So thank you very much, Prime, for this very comprehensive, no, in spite of the time limitation. So seems like siguro you've explained it very clearly na walang nagki-Q&A or walang nagki-question po. So
Ito yata maganda pag kokonti lang yung a-attend.
we have around almost 200 na participants po na attendees.
Okay, since
So,
wala po nag-QA and 3M is coming and they're one of the sponsors, just to let everyone know that the cables, especially medium voltage cables, most of our failures sa planta is due to the terminations because that's the weakest link. The cable itself is robust, but the termination is sometimes the failure of it is caused by human error. So we need to make it sure that we specify the right termination, and we want to make it sure that qualified people is going to do the terminations, and we want to make it sure that we quality control it properly. Yun po yung sasabi ko lang. Around I think it's around 300 million over the span of 20 years is the cost, dollars is the cost of the plant in all the plant here. Statistically, it's because of the cable terminations. So importante po yung cable termination point. So thank you 3M. Good luck po. Educate people. Thank you.
yes, thank you, Sir Prime. Actually, yung 3M po was moved to this afternoon. But anyway, yeah, it was really scheduled right after your webinar. Yeah. No, so I think I just have one question, Sir Prime. With the development of our numerical relays, does it mean that our solid state or the electromagnetic relays would now be really a thing of the past now, or do they still have some value in our industry po?
Well, they still have some value if they are not yet reaching the point of their design life. Okay, so it's not gonna be fair. Na sabi nga nila you can run it to fail, right? So gaano ba ka frequent na may fault sa system? Hindi normal na nagkakaroon ka ng fault, okay? And that's why the reliability people has a job to do, to predict. If there's a fault, they need to investigate. They need to do the root cause. In a static relay, you may have a very limited information to create a root cause analysis. Then you have to do further. You have to do further testing and everything of the specific failed equipment. But if the static relay is still working, and you can only prove that it's working if you're testing it. Hindi yung Como hindi nagtitrip, ay okay lang yan, parang fuse. Alam mo, ang isang device lang na pwede kong pagkatiwalaan na hindi ko itetest at kahit lalamukin yan at babahayan ng gagamba, yung fuse. kasi silyado siya. Pero ang relay, if you have a static relay, you have to test it. It doesn't mean na basta mo na lang i-phase out because it requires money to do it, right? So but you can find that the static relays are already predominant on the smaller ones. Katulad ng mga NGR relay, yung ating mga grounding resistor monitoring relay, yung mga relay na maliliit, yung mga pang motor na maliliit, normally mga static pa rin sila. May mga deep switches pa rin kasi maliliit sila na relays. They are more on the branch circuit end. Yung mga ground fault interrupter ninyo, normally yung karamihan sa kanila static pa rin. Bihira ka makakita ng numerical kasi overkill na pag numerical sila, right? However, sa mga malalaking relay, they are already numerical, and yung mga static unti-unti nang na-phase out. Those statics are only limited now to the smaller ones. Mga overload relay ninyo, yung mga ground fault GFCI relays ninyo, okay? Mga RCDs, they're all static already, okay? They're still static, and I don't think they're gonna be numerical. Kasi parang walang economic justification kasi kung ginawa yung numerical yung mga yon, magmamahal siya, wala nang bibili. Okay? So there's the practical side of things. So these numerical concept is, as of now, is applied to the big feeder relays. Okay.
So the main point is we just have to be selective with our specifications of where to apply these type of relays. No?
Yes.
meantime,
So
yeah.
so the bigger your system is, the bigger the possible outage is. Kailangan may risk assessment kayo. And of course, applying a numerical relay to a totally statically operated plant is going to be costly. So you have to do that on a phase basis, like staggered basis. Okay? Yung unti-unti yung pinapalitan. Unti-unti yung sineset up yung system.
Okay. Yes. Thank you for that insight, Sir Prime. But I don't know if you've already answered these three questions in the Q&A or two questions.
What are the three questions here? Okay, let me read it myself. Sir, pwede bang gamitin yung different brand of numerical relays in one system? What is your take on this? Curious lang. You can have different brands kasi you can have different brands in one system because the only difference between them, of course, it's always best to have one brand. Kasi bakit? Because mas maganda yung iisa lang yung the way you set it, the way you test it, iisa lang yung manual na binabasa mo. So masakit sa akin na maintenance sa saka operator na ang dami kong binabasang manual. Tapos magkakalituhan na kung alin yung para kay Pedro, alin yung para kay Juan, right? So yun yung tinatawag na you have to standardize so that yung culture ng maintenance and operations iisa lang. Okay? Is it gonna work kung iba-ibang relay? Yes, it's gonna work. Why? Because they can still communicate as long as they communicate on the same protocol. Okay, kunwari may mga protocol tayo na mga communication protocols tayo, may DNP3, meron tayong Modbus, meron tayong IEC 61850. As long as those relays are capable on those communication languages, then they can communicate to each other. The only drawback there is that you're gonna be setting them differently. Kaya masakit para sa magme-maintain. Madali lang sa inyo na nagdi-design kasi ito yung bilhin nyo, itong commission, bam, bye-bye, bahala na kayo sa buhay nyo. Kawawa yung mga nagme-maintain, iba-iba yung binabasa nilang manual. Right? So mas maganda yung ini-standardize ninyo. And saka mas mura kung iisang klase lang. Nakakakita lang ako ng iba-iba kapag meron tayong set A and set B. Parang redundant. So huwag kayong mag-redundant sa relay na parehas ang make. Kailangan magkaiba ang make para it makes sense on a security and reliability standpoint. Okay. Next is we have a problem with our feeder substation. If feeder 1 trip, the feeder 2 also trip. What would be the fast possible cause? So parang sinasabi mo, assuming na ang fault mo is nasa downstream ng feeder 1. Tapos nagtitrip yung feeder 2. Kapag nag-trip yung fault, nagkaroon ka ng fault sa feeder 1. Kaya nagtitrip po yon, maaari na yung backfeed mo, kasi kapag nagkaroon ka ng fault sa downstream ng feeder 1, yung fault manggagaling sa utility at saka yung mga ibang katabi niyang feeders. So ang nangyayari po doon, pag nagkaroon ka ng fault, baka yung backfeed mo galing sa feeder 2 na magko-contribute sa feeder 1, baka yung setting mo doon napakababa in such a way na napipick up niya yung contribution na nagbabackfeed. Okay? So ibig sabihin, hindi tama yung pagkakaset ng feeder 2 mo kapag nagtitrip siya due to a fault on feeder 1, which doesn't make sense to me. The only current that will flow to that relay from feeder 2, if you have a feeder in fault 1, is just the contribution that goes up. So, ang tanong, ano ba yung nasa baba ninyo? Okay? Kung meron kayong main tie main doon, yung feeder to nyo is nag-supply sa isang main tie main, tapos naka-normally close tie kayo, ibig sabihin, yung utility na galing sa kabila pang feeder, pumunta sa tiebreaker, umakyat doon sa ano nyo, doon sa feeder to nyo, kaya siya nag-trip. Or, mababa lang yung fault current, may fault current na umakyat doon, which is a bit substantial, na ang setting nyo sa feeder to, napakababa. So that means, nag-trip siya due to a backfeed fault current contributing to the other location of the fault. So maaari din ganon. Bihira lang yung nagkamali yung communication kasi hindi ko naman kailangan ng interlocking between those two feeders eh. So hindi sila related sa isa't isa. Okay, yun ang suspecha ko. Baka mali lang yung pagkakaset ng relay ninyo doon at napipick up niya yung contribution. So kailangan iset ninyo base sa contribution na nanggagaling sa taas plus kung ano yung contribution na dadagdag. That means magiging malaki yung current. So masyado lang sensitive siguro yung pagkakaset ng feeder 2 nyo. The other thing is, well noted po. Okay. Good AM. We have a problem of our, parehas lang. So our substation has 2 feeder only. Okay, they mas simple siya. You conduct a short circuit and try to calculate what is your backfeed. And then try to calculate what is the fault in a unidirectional way doon sa each feeder. And then kung ano yung setting nyo sa feeder 1, siguro parehas lang sa setting nyo sa feeder 2. Okay? Kasi iisa lang ang bus na pinanggalingan ng feeder nyo eh. So you have to check that. Kasi baka nag-trip lang yung pag may fault dito, nag-trip yung kabila, ibig sabihin may backfeed na nakikita yung relay ninyo na nagtitrip siya. At saka i-test nyo rin yung relay ninyo. Baka naman may setting doon na parang mali yung pagkaka-enable na hindi siya dapat ma-enable, na-enable siya. Sabihin na lang natin, nagkaroon kayo ng directional element. Aksidente yung na-enable. So kung nagkaroon ka ng backfeed, magtitrip yun instantaneously. Nakakita siya ng backfeed eh. So tignan nyo maigi yung setting nyo po doon. Okay?
Okay, Sir Prime. So I think that was the last question, Sir Prime. I think also in addition to Prime, usually here, if walang na-conduct na coordination study, yung default setting is the minimum pickup. So most likely siguro, yun yung nangyayari.
Yeah, may nangyayari din yun na may default doon na hindi na disable, right? Baka nga may set 2 pa yun eh, naka-enable. So ibig sabihin dalawa sa isang overcurrent, dalawa yung nakaset na set 1, set 2, set 3, di ba? Baka mamaya accidenting na enable lang. So kailangan i-review niyo maigi yung i-review niyo maigi yung settings at tignan ninyo. Saka normally kapag pag numerical po 'yan, pag nag-trip siya, magi-indicate siya kung anong cause. So yung cause na yon, tignan niyo sa logic. Baka naman hindi siya dapat naka-enable, accidenting na enable, or naka-default factory siya, hindi siya na-disable. So kailangan ipa-check niyo sa isang relay specialist. Hindi ko sinasabing technician, sa engineer niyo ibigay. Kasi nakikita niya yung holistic system. Kasi kung ibigay niyo sa technician, ang technician kasi siya yung, okay, ibigay ko tayo to, iset mo. Ganun lang siya eh. Okay? Pero hindi siya yung nagdi-decide sa holistic system. Okay? Sir Bry, paki-snapshot naman ako diyan. Para for quality purposes. Ganito lang po ako, makwela po ako mag-deliver kasi I just want the webinar to be fun, okay? Kaya minsan nagkakarak ako ng jokes.
I was expecting that you have your guitar there on hand and
don't push it. Ikwento ko na lang yung puso siguro. That's a Cebuano, that's an unforgettable Cebuano story for me.
Yeah, hopefully you'll be experiencing that again when you come here.
No. I don't do the same mistake twice. I can assure you that. Ay, nako.
So thank you. Yeah, thank you for that, Sir Prime. And at this juncture, we'd like to present to you our certificate of appreciation. So ito na yung moment ng bag-stop shot mo, Sir Prime. Okay. So this certificate of appreciation from my Cebu chapter is presented to Engineer Primo G. Beltran Jr. as technical resource speaker on the topic Numerical Protection Relays Basic Application in the 28th Eastern and Central Visayas Virtual Regional Conference via Zoom held on September 16 to 19, 2021 with program accreditation number OEE 2020-007-308 with approved 25 CPD points given this 18th day of September 2021, signed by Engineer Mario C. Tabanyag, President, Engineer Luel B. Ratilla, VP Technical Affairs, Engineer Felipe C. Niliama, Regional Governor, Eastern Central Visayas, and Brian A. Pasilan, Technical Consultant and Advisor. So, once again, Sir Prime, thank you very much for this very insightful lecture, and I hope we have many takeaways, and looking forward to see you in the future webinars.
And mga sirs, yung manual na kay Sir Brian, so siya ang habulin niyo, wag ako. Tapos, and somebody asked a question, ano ba yung relay na nakaka-detect sa backfeed? It's called directional relay. It can be an overcurrent, it can be a power. In your case, it might be a directional element. Thank you.
Thank you for that additional insight, Sir Prime, and moving forward, good luck and keep safe. Yeah. Thank you. So, yeah, moving on to our next technical resource speaker. So we're just setting up some technical issues, no, with our audio, just for a few seconds. Okay, so how's our audio now? We'd like to have some feedback, just for our members to clearly hear us here at the venue. So, okay lang po ba, mga sir? Please give us a feedback. Thank you very much. Okay. Loud and clear. Okay, thank you. So, may we now proceed further. So, our next speaker will be is a PEE, an MPA, and an ACP in AAR in 2019, and as National Treasurer, and he's been with the IIE for several years now as an ex-com, and been serving IE for quite some time, and is presently the President and CEO of the United A1 Electromech Corporation. So please help me welcome Engineer Florencio D. Beringel, who will be talking about transformer operation and testing. So good morning po, Sir Beringel.
Good morning, Press Brian. Good morning, IIEE Cebu, and congratulations for your 20th regional conference.
Yes, thank you din po, sir.
Okay, so let's proceed. Our transformer system operation. So at the end of this presentation, the participant will have a technical know-how and may be able to simulate by demonstration the process how the transformer system operates. May I audible? System function, the system provide the necessary transformation to the specific voltage requirement of the transmission lines, feeder lines, distribution line, and the powerhouse. So system interconnection, this is interconnected with generator and switcher system. Our system component is the main unit transformer. So the main function of the main transformer is the step-down voltage generated by main unit generator at 13.8 to 115 kV, and feedback coming from the system in the event of the total plant shutdown. The low voltage consists of two delta connected to two generator, 50 megawatt each, consists of Y connected in the high voltage winding. The low voltage side is connected, as I said, in two main unit generator by means of bus bar and high voltage in switchyard. Another transformer is a 22 MVA power transformer. This is the auxiliary power transformer. Kinikater naman ito is generator 1 to 3, 6 megawatt each from 4160 volt to 115 kV. This is also Y delta connected. So our another transformers, a transformer, auxiliary transformer V 37.5 MVA, step down of course 13.8 to 115 kV, consists of two delta connected winding. So it is used for auxiliary 4 and 5, 10 megawatt and 18 megawatt respectively. This is connected also. The high voltage is Y and the low voltage is delta connected. We have also a station service power transformer. The station service transformer B is designed to step down voltage by either main unit number 2 or main unit number 3 from 13.8 kV to 480 volt to supply the plant power requirements and the powerhouse. An interlock switch 20 AG5 is provided to determine which generator will be supplied the station service transformer B. While station transformer A is designed to step down the voltage generated by auxiliary unit 1, 2, 3. So this is by means of disconnect switch 10 AG3 and 10 AG5. So it is 4160 to 480 volts. Well, the station service transformer in B can be operated at a time or simultaneously. Kung gagamitin natin yung A, so if the one transformer is in operation, circuit breaker 03 AG4 should be closed. And either circuit breaker 01 AG4 and 02 AG4 is open depending on which of the two transformer is in operation. So for AG01 AG4 from station service A and 02 AG4 for station service B. So kung naka-open yung A, yung 01, naka-close yung 02. When both transformer are operating, 03 AG4 must be open. So ito yung tiebreaker for both A1 AG4 and 02 AG4 are closed. So this is the system. This is coming from auxiliary transformer A or the pagka naka-close ito, naka-open ito, naka-close ito. So magagamit pareho dito. This is station service A, this is station service B. Coming from main unit number 3, if this is close, 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 open, open. If this is close, open, close, close, open. So vice versa. If this is close, close, open. Instrumentation, temperature indicator of the temperature of the low voltage winding each transport is monitored through a dial type temperature indicator. So each power transformer is equipped with a dial type transformer oil temperature monitoring. So this is the dial type temperature monitoring. This is the high level and wala namang low level. So kailangan lang nasa gitna siya. Oil indicator, the conservator tank of each power transformer is equipped with the oil level indicator to monitor the oil content of the tank. The high voltage bushing are provided with a sight glass in the head so that the oil level can be checked inside the bushing chamber. Deploy indicator, the main unit transformer, and the auxiliary unit, the power transformer 1, are equipped with oil flow indicator monitoring the flow of from the oil pump. So yung main unit number, main unit 122 MVA power transformer unit 1 and 2, and auxiliary unit power transformer 22 MVA is with conservator, and the cooling system is nitrogen. Oil condition, each power transformer is provided with the oil sampling vent for oil conditioning monitoring. So dito tayo kumukuha nung pagka mag-DBGA. Pressure indicator, a compound pressure gauge is provided for monitoring a pressure to nitrogen in the conservator tank, and another pressure gauge for monitoring the pressure to the nitrogen supply. Another, the tap changer, each power transformer is installed with a tap changer for corresponding high voltage adjustment. Of course, with control cabinet, each power transformer is provided with a control cabinet or cubicle where the operation of the transformer component can be monitored. Control switch. A manual off and auto control switch is provided to determine the desired operation of your cooling fan. So thermal relay serves as an automatic controller of transformer cooling equipment. So importante yung cooling fan. For example, in our 122 MVA, we have a 9 cooling fan. So isa lang mag-function doon, magkakaroon because of overheating of the transformer oil. Cooling system, every transformer is provided with cooling fan, either radiator cooler or fan that control the oil temperature of the transformer within the operating limits. So selector switch, the main power transformer and auxiliary unit transformer 1 is provided with a LED of flag selector switch for each group of fan. So as I've said, meron tayong mga set of cooling fan in the transformer and radiator. The protective device, nitrogen sealing. The equipment supplies a nitrogen sealing to the conservator tank, allowing the oil to be in contact with the gas rather than the air. This eliminates the oxidation, moistening, and of the transformer oil. So this is used for main unit number 1 and 2, 122 MVA, and auxiliary unit number 1, 22 MVA. The hydrating breather, auxiliary unit number transformer 2 is equipped by the hydrating breather, which uses silica gel as absorbent. Moisture and condensate can be developed in the oil due to the contact with the conservator tank is absorbed by silica gel. So yung auxiliary transformer B, the 37.5 MVA is using silica gel. Gas relay, each transformer is equipped with a Buchholz relay, which activate if the gas developed in the conservator tank. It is provided with 2 contacts, one for signaling and the other one is for tripping. So distance temperature detector. Distance temperature detector is provided for the power transformer. Its sensing element is placed where the oil temperature is highest. The oil temperature corresponds to the temperature of the hottest winding. So check din yung mga transformer is equipped with the lightning or such as arrestor as protection against the high surge voltage. So this is our lightning arrestor. This is a takeoff. This is the 115 kV line. This is auxiliary unit transformer A. This is transformer B, 0.51, 22, 122, and 22 MVA power transformer. Earthing. Each transformer system is properly earthed as a protected against electric shock for personnel. So every time na mag-shutdown and operation of the transformer, be aware in the earthing or the grounding cluster, the use of grounding cluster. System operation or normal operation, the transformer should always be in operation or ready for operation since they are one of the major and vital component of the plant. A transformer is said to be ready for operation upon make sure that all its parts component are functioning normally. The transformer are put into operation or energized by closing the corresponding disconnect switches and breaker. Shutdown. A transformer can be shut down by isolating from the system through the opening of the corresponding disconnect switch, breakers, and then energized through grounding. So sabi ko, importante yung earthing. After the shutdown, maglalagay tayo ng grounding cluster to divert yung store energy to the ground. So before naman operation, tatanggalin yung grounding cluster yung or your earthing. So this is the single line diagram of the Angat Hydroelectric Power Plant. This is our station service. This is 122 MVA power transformer, 122 MVA transformer B. This is 37.5 MVA auxiliary transformer B. And this is auxiliary transformer A, 22 MVA. Kagaya sabi ko kanina, this is our station service. Pag dito tayo kumuha ng supply, naka-close ito mga breaker na to, naka-close ito, yung tie breaker, naka-open ito, naka-open ito, naka-open ito. Pag binaliktad natin, open natin ito, kumuha sa main unit number 3. So pag number 3, close ito, open ito, close, close, open. Pag dito naman sa 2, main unit number 2, close ito, open ito, close ito, open itong lahat. Transformer maintenance. The standard organizations such as ANSI and IEEE consider the average transformer life of 20 to 25 years. This estimate is based on the continuous operation rated load and temperature rise of 65 degrees Celsius. Receives adequate maintenance over service lives. Significant number of transformers were purchased in the 1950s, 60s, and into 90s. Several have been replaced, but we have many that are nearing or already will pass. Their anticipated life should be expect the transformer replacement and failure to increase due to the age factor. Current minimum replacement is around 14 months to 18 months to 2 years in the future. The lead time may be extend beyond what they are today. So kung medyo problematic ang mga transformer natin, ganun katagal magpalit, 14 or 18 to 2 years bago dumating ang bagong transformer. Therefore, the high quality maintenance and accurate diagnostic are important for all transformer. But absolutely the essential of the older one, especially for critical transformer that cause a loss of generation. It is also very important to consider providing spare for critical transformer. So kung talagang medyo tagilid na sa DGA at hindi nagbabago, so you need to replace the transformer. For the transformer maintenance, table of content, transformer type, regular transformer check-up, accessories, testing of transformers, filters of transformer oil testing. For the transformer type, we have drive type transformer, we have oil field transformer, silt tab, we have also pole mounted, we have also maxipad, we have also conservator type system of the power transformer. This is conservator and this is the Buchholz relay. Oil field transformer, silt tab, pond mounted or compartmentalized transformer. So this is usually up to 200 to 3,000 kVA. So regular transformer check-up. Check vacuum pressure gauge for pressure reading. Check oil level. Check temperature maximum and minimum, the possible oil leak, paint condition, the transformer top and radiator for foreign material, the radiator condition, and of course, the fan and cooling system. This is the very important part of the transformer, the fan and cooling system. Transformer accessories, of course, pressure relief device, the bayonet fuse, tap changer, LV load bridge 6, oil level gauge, temperature gauge, pressure gauge, and Buchholz relay. The pressure relief device, this device a transformer last line of defense against excessive external pressure. In case of the fault or short circuit, the resultant arc instantly vaporizes surrounding the oil, causing a rapid buildup gaseous pressure. If the device does not operate properly and the pressure does not properly relieve, within a few milliseconds, a catastrophic tank rupture can result, spreading, flaming, or oil over the white area. So, posibleng sumabog pag hindi nag-function ng pressure relief valve. So, this is the other type, pressure relief valve. This is the reset. This is the reset. This is part of the component of the pressure relief valve. Bayonet fuse are used to protect transformer and distribution transformer. They are designed for use the pad-mounted or subsurface distribution transformer filled with transformer oil or approved equivalent. The assemblies combine the ease of the hot stick operation within the safe and dead prot condition. Usually, nagkakaroon ito ng leak sa mga O-ring. Tap changer is a mechanism used at the tap changer position in the transformer that enable the voltage regulation of the secondary side. So mamimili ka na lang dyan kung saan mo gusto dalhin yung direction. Load break switch is a switching mechanism wherein the transformer can be manually switched off, on, and the loop through operation. So at the same time, so magkakaroon lang ng changeover. Oil level gauge used to determine the oil level of the transformer tank. The center dial is normally marked a temperature of 20 degrees Celsius. High and low level point are also marked as a follow level change of the expanded contact of the temperature change. The proper way to determine the accurate oil level to first look at the top of the temperature indicator. So the oil level is very critical, particularly during the rapid changing of the temperature. Kapag mainit ang temperature, so nag-expand yung transformer. Kapag lumamig, bumababa naman yung transformer. So look for the level gauge. The pointer should be at least a reasonable level corresponding to the top oil temperature. So this is the construction of the different kind of oil level. This is the pace, the dial pace. This is the minimum and maximum. So, ganun din dito. This is the minimum and this is the maximum. So kailangan nasa in-between lamang sila. Temperature gauge. This device indicates the top of oil temperature transformer. The extra pointer normally red. So this is dapat ay red. Ito yung maximum. Indicate the maximum temperature since the last type of indicator was set. The red pointer rise within the main but will not decrease unless manually reset. So hanggat hindi na-reset, hindi mawawala yung alarm. Thus, it is always indicate the highest temperature reached since being set. So kailangan tingnan natin ang inspeksyonin why magkakaroon ng high temperature. So normally, used because of the cooling system and the presence of gas in the chamber. Pressure or vacuum gauge indicate the integrity of the seal of the construction. High pressure indicate an overload or internal trouble on the sustained zero pressure reading indicate leak and defective gauge. So kung zero na tayo, so meron na itong leak. So kailangan hindi bababa dito. Lalo naman kung naka-negative na, naka-vacuum na. So vacuum means negative and this is the absolute. Buchholz relay found only in the transformer with conservator tank. So kung doon lang sa may mga conservator tank. In our case, main unit 1 and 2 and auxiliary transformer A ang merong Buchholz relay. Yung isa wala. The purpose of this relay is to alarm the transformer is gassing. So the top contact activate pagka merong gas, magsisignaling or trip if the oil level is very low. So a pressure wave has activated at the bottom contact. If this relay is operate, do not re-energize the transformer until you have determined the exact process. So kung merong alarm, so kailangan natin i-shutdown yung transformer. Kung may gas, pwedeng i-relieve, i-vent yung gas. Kung kulang yung oil level, dadagdagan natin yung gas, yung oil. So this is the construction of the Buchholz relay. So this is the reset. Sudden rise of temperature relay. The purpose of relay is to alarm if there is a sudden pressure rise inside the tank. This relay is very sensitive and will operate if the pressure rise only a little. If very small pressure change occur caused by a small electrical fault inside the tank, this relay will operate. So pag nakadetect siya na any foreign object inside the tank, especially electrical fault, this pressure relay is operate. So, ito na yung construction ng pressure relay. So, this is the reset. Testing of transformer or field testing. The 6 standard of the transformer testing are TTR, winding resistance test, IR or PI or polarization index, oil electric breakdown test, isolation power factor test, and single phase excitation or DLRO. Transformer turn ratio or TTR, testing of ratios turn of winding with respect to another. The allowable tolerance is 0.50% and should match factory value. So titingnan natin yung the reference, of course, is the factory value or 50% of the tolerance. So this 3-phase and this is the single phase testing. The purpose of TTR to determine the turn ratio and the polarity of the single and 3-phase transformer, 1 phase at a time. So isa-isa. Confirm the nameplate ratio, polarity, and vectors. So i-confirm natin. Identify the trouble of transformer winding such as open, short circuit, and turn-to-turn sensitivity. Winding resistances, sometimes referred to DLRO. They measure the winding resistance across the terminal. Reading should be compared to factory test data or previous data. So importante yung previous data. Permissible deviation of this test field is 2%, up to 2% only of the factory test, the value of 75 degrees Celsius. So 2% of the factory test. The purpose of winding resistance is for commissioning or acceptance requirement. Verify the internal winding condition and interconnection for open or short circuit turn for the pore joint of the bad tap changer contact. IR or isolation resistance test is relatively quick and easy. Isolation resistance measurement are taken from individual winding to ground or winding to winding, or line to ground or line to line. The test consists of applying voltage to winding for a period of 10 minutes wherein the 1 of the minute measure resistance be compared to the calculate of the value of the formula given below. So R equals to CE over the square root of KBA, wherein R is the resistance of the winding ground with the other winding grounded between the winding in the mega ohms of 20 degrees Celsius, or R is equal to KB plus 1, where KB equal to the voltage classification of the winding under test for the transformer rated 100 kVA, and kVA is the rated capacity of the winding under test. C is the 0.08 of the oil filled of degrees Celsius, 16 for dry and 16 for dry compound filled, the untank filled transformer. Testing with guard, this is without guard, is 1.5 and 30 for dry, wherein E is the voltage rating of the winding under test. What is the purpose of the insulation resistance test? This is to determine the presence or absence of the harmful contamination or degradation of the transformer insulation. Kung may mga problema na yung insulation natin. Polarity index or PI is a test the electric absorption the test with the voltage is applied for a longer period of time. For good insulation, the resistance value will increase with time. The ratio of the 10 minutes is 1 minute reading. The index below 1 indicate the poor insulation. An index between 1 and 2, the insulation is questionable. An index 2 above is indicate the good insulation. So napaka-importante ng polarity index, the dryness of your insulation. PI is equals to resistance in 10 minutes over resistance of 1 minute. So again, an index with 1 is very poor insulation, 1 and 2 questionable, and 2 is the good or good insulation. The purpose of the PI is to determine the integrity and dryness of the paper of insulation. So this is a sample of standard test. This is the as found. This is the nameplate data and the insulation resistance test testing. The polarization index is 2. Nakuha natin is 1.87. So questionable, but based on the remarks is pass. The TTR, The limiting criteria percent difference calculated, the mu is 1 plus or minus 1 maximum in the service of 1 plus or minus 1 maximum. So nakuha natin is 0.03. Primary winding test, the limiting criteria should not exceed or plus or minus 5% of the adjacent winding. So the difference is 0.22 and 0.57. So limiting criteria for the excitation current test, for new is 10% maximum, in service is 10 maximum. Y connection is two-phase outer leg with similar excitation but notify the higher of the center of the leg. So delta connection of two phases outer leg with similar excitation, with notable lower the center of the leg. So the remark is passed. So kung titingnan natin, halos similar. So 14.72, 15.38, 14.2. Isolation power factor test. The limiting criteria power factor is plus or minus 0.5% or 50%. In service is 2%. So ang nakuha natin dito is 0.7. 0.7 lahat. For the hot color test, the limiting criteria power factor is 1 watt. So evaluation recommendation test result is satisfactory. Transformer maintenance of number 4, oil electric breakdown test. This test is made by filling of the test of the cup with the sample until the disc of 0.1 inches apart are submerged and applying the voltage of the advancing of 3 kV per second until the oil between the disc is punctured and the breaker open and recording the maximum voltage reached. So inulit ito 5 times. Kailangan 5 trials to get the average. The acceptable minimum breakdown of the new transformer is 30 kV and 20 kV in service transformer. So sa bago, kailangan makakuha at the gap of 1 inches of 1 inch, 0.1 inch or 2 mm. So dapat makakuha ka ng 30 kV kung naka-service 26 kV sa bagong langis. Purpose of the oil electric breakdown test, this is to capable the revealing momentarily resistant of oil of the passage of the current of relative amount of free water, dirt, and conducting particle the presence of the sample. So very critical ang pagkuha ng sample dito. Dapat walang tubig, walang bubbles, walang air. So solid oil. Insulation power factor test. This test indicate the power loss caused by leakage of current through insulation. On the transformer test, the power factor is winding with respect to ground and each winding with respect to other winding. So line to ground and line to line should be measured. The evaluation of the data obtained should be based on the comparison of data of any previous test of the same transformer test data. So kailangan laging merong similar from the similar unit. So yung importanting reference. If such data are not readily available, the power factor of greater than 1% is subject for investigation. Purpose, the power factor upon isolation is measured of it the electric power loss and it is not measured of each the electric breakdown strength. The power factor method is used primarily for testing the insulation condition of the high voltage bushing, cable, transformer winding, and transformer oil. At this method, they particularly recommended detecting the moisture and other loss-producing contaminant in the transformer. So by means of the insulation power factor test, measure natin kung mayroong mga other loss-producing the contaminant of the transformer, particularly if there is gas or water. Single-phase excitation test. On a single-phase transformer, the two current obtained should be the same. Current recording should be compared either with similar unit or data obtained from previous tests on the same unit. For three-phase core form transformer, a pattern of two similar current or one low current is expected. The lower current on one phase, usually H2 and HO, from the Y connected winding and phase H1 and H2 for delta connected winding is associated with that winding in which wood in the center leg of the three-leg core. The magnetic reluctance of the phase is lower than the other phase and resulted in lower excitation current value. For three-phase, the self-formed transformer may be also yield a pattern of two similar current and one in a low current, but only in the secondary winding is delta connected. An increase of excitation current magnitude by greater than 10% over normal value of the previous test, the value is indication of serious fault. So pag sumobra ng 10% the previous test, so sa trending, this is a indicate a serious fault. Purpose of single phase excitation test to measure for the field detection of the short turn, shorted turn, and core damage. This method is natural extension of the power factor test and make the use of the same test equipment. Numerous cases of extensive core problem like shorted lamination and winding problem or partial and high resistance short circuit between the winding turn. So, kuminsan nakakaroon ng ionization have been detected and using this method. Transformer oil chemical laboratory test. So, meron tayong oil quality test and dissolved gas analysis. So, oil quality with measuring the IPF, or interfacial tension, the neutralization number or acidity, water content or moisture, oil the electric breakdown test, oil power factor, and the color. Interfacial reveal the sludging of the condition of new oil 40 to 50 dynes. So for more particular of the weakened interfacial tension of the lower IFT number, it is recommended that the oil be reclaimed when the IFT number is fall to 27.9 dynes per centimeter. So take note that the new is 40 to 50 dynes per centimeter. At this level, the oil is very contaminated that must be reclaimed to prevent a sludging, which begin at around 22 dynes per centimeter. So sa una, magkakaroon lamang ng reclaiming. Reclaim yung langis or ididigas. Pagka hindi pa rin tumaas, another testing again. Acid number, the higher the acid number, the more the acid in the oil. New transformer oil contain a particle, no acid. Oxidation is insulation of oil form an acid of transformer ages. The oxidation product form a sludge participation out of inside the transformer. The acids attack the metal inside the tank form soap or sludge. The acid also attack the cellulose of accelerate the insulation degradation. So tinitira din nila yung insulation. Sludging has been found begin with the acid number reached to 40.40. It is obvious that the oil is reclaimed before it reaches 0.40. So it recommended that the oil be reclaimed when it reaches 0.10. Water content or moisture. For the service agent transformer, rated less than 69 kV, result of 39 parts per million are considered acceptable. For 69 kV through 288, the DGA test results is about 25 parts per million is considered acceptable. For greater than 288 kV, moisture should be not exceed of 20 parts per million or ppm. So keep in mind that the life of the transformer is of the paper, and the purpose of this paper is to keep out moisture in oxygen. So napaka-importante ng insulation ng ating mga winding sa transformer. Oil power factor test. This test is done by DGA laboratories. It is also done with noble testing. A high power factors indicate the deterioration or contamination by the product, such as water, carbon, and other conducting particle. Metal soap caused by acid, attacking the transformer metal, and product oxidation. The DGA labs normally less than power factor 20 degrees Celsius to 100 degrees Celsius. Double information indicate the service limit of the power factor less than 0.5 to 25 degrees Celsius. 5% to 20 degrees Celsius. If the power factor is greater than 0.5% and less than 1%, further investigation is required. The oil required replacement or fuller earth of filtering. So pagka ganyan pa rin ang ganyan, first, kailangan ibigas yung transformer oil. Pag hindi pa rin nagbago, papalitan ng transformer oil. If the power factor is greater than 1 or 25 degrees Celsius, the oil may be cause of failure of the transformer. Replacement of reclaiming is required. Above 2%, the oil should be removed from service and reclaimed. The replaced because equipment failure is highly probability. So kapag sumobra na sa 2%, kanina 1%, 25 degrees, kailangan na i-reclaim. Pagka sumobra na, kailangan ng palitan. Color. Which color are progress beyond the light brown remaining clear of the turbidity? So masyado ng malabo or cloudness. And any blacking, coloring, or floating the particle of shooting carbon endangered signal indicate severe arcing. So pag ganito na kalabo, medyo delikado na. TGA is a laboratory test using the oil sample taken from the transformer. The oil sample is subject to a vacuum to remove the combustible gases. So, kagaya na sabi ko kanina, kapag kuha ng sample, dapat solid oil. Walang presence of gas, presence of air, or any particle or foreign object. These gases can then pass through the gas chromatography, and each gas is extracted and analyzed for type and quality. The quality is given in parts per million, and the analysis is each presence provide a useful determining the condition of the transformer. Take note that the GA is the blood test of the transformer. Partial discharge. So dissolved gas analysis, partial discharge or corona. Electrical rust is hydrogen. High temperature heating, methane, ethane, and ethylene. Arcing, acetylene. Cellulose involved, carbon monoxide, and carbon dioxide. So ilan lang to? 1, 2, 3, 4, 5, 6, 7. 7 ang importanteng dissolved gas analysis result. So this is our sample test result. This is conducted several times. If you take a look at this, the hydrogen, as found is 5,191. The condition limit number 1 is only 100. For the methane, the condition number 1 is 120. As found is 181. Ethane, the condition number 1 is 65. As found is 250. The total combination is 720 as found at condition number 1, but as found is 6,470. The description of condition 1, 2, 3, and 4. For hydrogen, the condition number 4, the highest is 1,008, as found is 5,191. For the methane, the as found is 581. The condition number 4 is up to 1,000. It's questionable. Ethane, the highest is 150 sa condition number 4, as found is 250. So the total gas as found is 6,470. Here is the condition number 4 is 4,630. Oil quality tests indicate water content with normal limit of 35 ppm. The electric breakdown voltage test with normal limit is 26 kV. Neutralization number within the normal limit is 0.15 mg/kg per gram. Interfacial tension test with normal limit is 24 dynes per centimeter. Color is limit is number 4. Remarks: normal operation, hydrogen is 1,500 ppm indicate possible corona. Methane 80, possible local overheating and possible low energy spark. Ethane 35 ppm, possible local overheating, possible low energy spark. Ethylene within normal limit 150 ppm, acetylene with normal limit at 70 ppm. Carbon dioxide, monoxide with normal limit at 1,000 ppm or parts per million, and carbon dioxide with normal limit of 10,000 parts per million. Recommendation: installation of cooling fan to lower the temperature, trending the GDA and oil quality every 6 months, and lastly recommended to replace the transformer since the trending test result cannot be improved. So this transformer ay tinrending namin up in 2 years. The first year, nag-DGA kami, then after that, reclaim namin yung langis, hindi rin nagbago after 6 months. Then pinalitan ng langis, another after 6 months again, 1.5 year. And in kaport, hindi pa rin nagbago. So we recommend to replace the transformer since the trending test result cannot be improved. Transformer maintenance, also cellulose insulation. The life of is directly related to the condition of the cellulose. The paper, the winding, the lid, the seal, pressboard, spacer, block, oil flow, tube, and the particle board support and the laminated structure of support and wood structure. So this is the cellulose insulation. This is the wood structure, laminated nut, and the pressboard and the paper. So importante yung mga distance nito. What degrade the cellulose? Of course, primary source is heat, moisture, and oxygen, and the secondary is acid from the oil oxidation. What can we do about it? Keep the transformer healthy. Do not overheat. Keep moisture and oxygen out. If the transformer is sick, get help. Investigate about abnormal DGA result. The process replace in oil. So kung kagaya nung aming tinrending ng 2 years, every 6 months, the DGA result, so we recommend to replace the transformer. So that's the end of my presentation. Thank you. And if you have some inquiry, hello. 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 Yan. Ano ba ito babalik? Ayun. May balik.
Hello. Hello. Can you hear us, sir?
Yes, good morning. Yeah, I can hear you.
Sir, okay. So, thank you for your informative information, sir. So, with regard to transformer operation and testing. And now, so we would like to issue this certificate of appreciation.
Ano ba ito?
So, hello. So, certificate of appreciation. So, presented to Engineer Florencio D. Beringel as a technical resource speaker on the topic transformer operation and in the 28th Eastern and Central Visayas Virtual Regional Conference. Zoom conference held on September 16 to 19, 2021. Program accreditation number OEE 2020-007-308. Approved 25 CPD points given this 18th day of September 2021. Signed by Engineer Mario C. Tabanag, PE, President IAE Cebu Chapter, and Engineer Felipe C. Niliama, PE, Regional Governor, 7, Engineer Luwil Ratilia, PE, BP Technical Affairs, and Engineer Brian A. Pasilan, PE, Technical Consultant and Advisor. So,
Thank you, Engineer Brian. Thank you for giving me a time to share my technical know-how about transformer. And of course, again, congratulations to the host chapter, particularly to your president and organizer, Engineer Mario Tabanyag, and the regional governor, of course, the 2021 Board of Governors, headed by our president, Engineer Alan Alvarez. Congratulations again.
thank you, sir. Thank you, sir. So let's continue. So currently we have some minor changes with our program flow. So our next will be presenter is the technical sponsor presenter, which is the Brill's Howie Digital Power. Then after our technical sponsor presentation will be, our topic is the designing of solar plus storage system and residential energy solution. After the presentation of our sponsor. Oh. So, a Cebu Chapter 20 Eastern and Central Visayas would like to thank our sponsors, Self-Judge, Dong-Ai Enterprises and Dong-Ai Panel Board Fabrication, Presma Electrical Controls and Corporation, Panasonic, 3M, United Electrical Specialists, Grills, Luxaris Solars, and Huawei. Exponent Control and Electrical Corporation. Nodal Electric Trade and Services. American Wire, Duraplex, Laroon, Full Air System, Okay, so sorry for that technical problem we encounter. We were just waiting for the presenter to take his time to prepare his presentation. Meanwhile, so let's proceed first to Q&A on our previous topic. So, Engineer Beringel, sir, still there, sir? Hello, sir. Engineer Beringel. Oh, hello. So, sorry for keep you waiting. So, may I acknowledge Engineer Florencio Beringil, if you are there, sir.
Yes, yes.
Yes.
I'm here.
Okay, sir. So, while waiting for our next presenter, because they have some, so prepare time for prepare. So, we'll proceed first for Q&A with regards to
Okay.
your topic.
Okay.
So, there is some question here.
Okay, okay, no problem. Okay.
Sir, so there's the, wait, sir, ha? Yes, so, sir, we have a question here from Juvenal Ibesa. So, in oil sampling, if the transformer is in a vacuum pressure, how to withdraw this oil, sir?
Ah, kung naka-vacuum yan, ibig sabihin, kulang yung langis niyan. So, dapat mag-fill up muna dapat mag-fill up muna. Wala kang makukuha doon dahil naka-vacuum. So, meaning naka-negative pressure ka. So, kailangan ma-reset mo na yan, makabalik sa zero or above zero.
Okay, sir, that's all, sir. So, I hope Juvenal Ibesa address your question. The next is, when is the best time to conduct current analysis of a transformer?
Depende sa ages ng transformer. Usually, other is 1 year, pero sa trending, kung nakikita mo na may problema sa trending, we recommend 6 months, every 6 months. After 6 months, kung hindi gaganda yung performance ng transformer, particularly in transformer oil, the first step is to degas the oil, degasification. After degasification, again, conduct the DGA testing. If there is no improvement, so the next recommendation is to replace the oil. And then after replacing the oil, again, conduct the DGA testing. Pag hindi pa rin talaga nag-improve, so we need to replace the transformer. So that is transformer problem na pagka ganun. So the testing, the frequency of testing is depending on the transformer condition. But regularly, at least 1 year.
Oh, okay, sir. Thank you. Thank you for that answer. So, I hope Kurt Gerardis address that your concern and your question.
There is
And next
another
is,
question. Yes, yes.
sige, sir. Sir.
Another thing is the PI, the polarization index is conducted because this is to determine the dryness of the paper of the transformer oil. So as I've said, based on the standard, pag below 1 or 1, this is a poor performance of your transformer paper or the insulation condition. 1 and 2 questionable. Then 2 and above, that is very good polarization index indicate. So sa PI, doon naman sa mga bagong refer na mga windings, polarity index conducted na dapat hindi tataas yung voltaheng gagamitin mo doon sa desired voltage. So usually the polarization index is conducted to determine the dryness of the paper, of the insulation paper of the winding of the transformer or either in generator. That is based on the NETA standard.
Okay, sir. Thank you. Thank you for that.
Okay. Okay.
Next
So
question is coming from anonymous attendee.
okay, please.
Yes, yes, sir. We'll find some another question.
Good morning, Ken. Nandiyan na si Ken of Huawei.
Morning, sir. Morning, everyone.
So we have transformer that have already tripped our MOB several times. What could be the cause? Maraming mga cause. That's why you need the inspection. First, you will check the cooling system. Tingnan niyo yung cooling system. Baka yung mga cooling system niyo nagma-malfunction. For example, you have nine exhaust fan doon. Pagka mayroong mga exhaust fan kayo na 9, nagmalfunction yung isa, lalo na kung isang linya, tatlo kaagad. So magkakaroon ng tripping of the transformer. Another one is the presence of gas in a buccal sealer or sa base or tank. Another one is the presence of water in your system. So maraming causes. That's why you need a preventive maintenance standard testing, particularly the dissolved gas analysis. Okay.
Yes, okay, sir. Thank you for that. And next, we have a transformer that have already tripped or MOB several times. What could be the cause for this? This is from Adrian Libarios.
I already answered that question. As I've said, there is many causes of tripping, particularly, for example, in your conservation tank, the presence of gas. So kung nagmalfunction, nag-signal na yung buccal sealer mo, the presence of gas, pag hindi na-correct yun, magkakaroon ng tripping. Other one is overheating of the transformer hanggat hindi nakukorek yun, hindi mag-reset. So another one is the cooling system. Pag hindi maganda ang cooling system as a process of tripping also. Another one is the presence of foreign material or water in the transformer oil. So that's why you need to conduct the standard testing for the transformers to determine the causes of your tripping of the transformer.
Okay, sir. Okay, sir. Noted on that. The question was already answered. Okay, sir. So, how frequent does transformer be tested? It is annually, 2 years, or 5 years?
As I've said before, it's depending on the performance of the transformer. For the new transformer, many are hanggat wala sila nakikitang problem, hindi sila nagpapatest. But usually the frequency of standard testing is every year. Pagka medyo magandang, every year. Pero kung hindi maganda, at least every 6 months, depending on the trending of the transformer performance. But usually this is the standard testing is every year. So we go on to the predictive maintenance rather than the preventive maintenance.
Okay, sir. Thank you for that, sir. So, hope the question was addressed.
Okay, thank you. And again, good congratulations to Cebu chapter for your conducting of this very successful 20th regional conference, especially to your organizer of this
Okay, sir.
conference.
Thank you.
Okay.
Thank you, sir.
Okay, bye.
Sir, nandiyan na Huawei.
So, our gold sponsor, are you ready?
Ready na si Ken. Ken Wang.
Hello. Yeah. Hello, everyone. Can you hear me?
Okay, so again, So we'd like to apologize for the technical problems. So just our sponsor that is preparing already prepared their technical presentation. So again, let's call the Braille's Huawei Digital Power for their technical presentation.
Yeah, thank you. Thank you, everyone. Yeah, so thank you, everyone. Thank you for your time today. And this is Ken from Huawei Inverter Business Philippine Market. I'm responsible for the technical, and today I will make a brief introduction and description about our Fusion Solar versions, our Fusion Solar residential smart PV solution, especially for the solar system, for the two important components, which are inverter and also the energy storage system, for reference. And I will show that why we should install solar and what is the benefit we can get from the solar. So before I start the introduction, please allow me to make a brief update for Huawei company. Because for Huawei, we are very famous for the ICT, but still we are also a very big player in the solar industry. And right now, for all the Huawei group, our business cover more than 170 countries, and there are 194,000 employees all over the world. 96,000 are for the R&D. We really invest a lot in the R&D. We reach rank number 3 all over the world. I believe this is also the reason why we can get a very stable business growth for the past 10 years. And for the solar industry, Huawei is very proud for us to say that right now we are the #1 inverter supplier. Our accumulated global shipment ranked was 175 gigawatts by May of 2021, and we have been #1 from 2015 to 2020. And in each area, we also get a very good grade, like for all the APEC, 38% market share. China was 40, Europe 35. So in different regions, always we get a very big market share due to our competitive product and solution for our end user and also for our EPC customer. And for Huawei solar inverter, we cover 3 main scenarios, which are residential, commercial, and industrial and utility scenario. Our products, its capacity range from minimum 2 kilowatts to maximum 215 kilowatts. And not just the inverter, we also have our own energy storage system, which is battery. We also have our own management system, our optimizer, data logger. So for Huawei, we are not just an inverter supplier, but also a complete solution provider. So this is our definition for the solar market. And for Huawei Philippines, we have established their office in Philippines since 2001. And right now, more than 2,000 staff are hired, 86% they are from the local. So we have several offices here, like me right now, I'm based in BGC. And we provide our ICT product, our mobile phone, and definitely our solar product to serve the local Filipino. And we hope that in the future, there are more and more solar opportunity, solar projects happening in this market. And with the help of Huawei solution, we can get a win-win situation. For Huawei service, this is also our strength. Because Huawei, we can build a very strong local service team here. We have the 24/7 hotline to cover customers' requirement. Locally, we also have a strong service team to help customers solve the problem. We have the local warehouse, which means we have the local spare, local stock to help customers replace the failed solar inverter. So we provide a timely and professional service to help customers solve the problem. And the next is today's topic, our residential solution. So what is the advantage for an end user to install the solar, and what is the benefit it can get, and what is the point we can be careful from the technology aspect. So here I will share 3 things, which is optimal electricity cost, active safety, and better experience. These 3 things is extremely important for the end user to get a very good application. So if we are talking about a residential solar system, this is the architecture. We will find out that for a residential system, this is the DC and the DC panel. And for the DC panel, it will connect to the solar inverter. The solar inverter is a very important component which can convert the power from DC to AC, which means the solar inverter's input is DC, but output will be AC. And at the same time, we can also install the battery, smart string energy storage system here. So which means if there are extra energy from the module in the daytime, when people are not at home, we can use the battery to store the battery, charge the battery. And in the nighttime, we can use the energy from the battery to save the tariff, to save the electricity costs for the end user. And definitely this system will also connect to the grid. And we have a meter here. We have the meter here for the zero export. We have the meter for the zero export. And also you can monitor and manage this system in your mobile phone, in your laptop through our management system. This is a remote management system here. So in this scenario, for Huawei, we provide several important components. First is our string inverter, which is single phase or three phase. The power is from minimum 2 kilowatts to maximum 10 kilowatts for this residential scenario. But definitely we have other model, a bigger model for the CNI and also utility. And next is today's topic, energy storage system. How can we use the energy storage system, combine it with the solar system to make full use of the solar energy? This is a very important topic. And third is the backup box, because we know that sometimes we will face the grid outage, we will face the power outage from the grid. So if we have the backup box, you can use for a power backup during the power outage, you can still get the energy from the solar or from the battery. And also we have the PV optimizer for a higher yield, for the shading rooftop, and smart dongle for the communication, meter for the monitoring, for the management, and the management system for the remote control. So this is what we can provide in the solar system. And definitely we also have our local partner, which is Breeze. They can help the customer provide a panel and provide a solution for the installation. So for Huawei and our partner, we provide a complete solar solution to help the customer from end to end. And I will share some typical features that how we can earn more and get more benefit from the solar system. First is we should generate more PV energy for the daytime consumption. And the second is that we should store more PV energy for the nighttime consumption. So daytime, nighttime, if we can make full use of these two down, then we can make full use of the solar energy to help customers save the cost. So first, it's about the optimizer. How can we get a higher yield? Because we know that for one solar system, all the modules, they are connected one by one, and then it's a string. We call it string. But the thing is that if one module is shaded like in this picture here, then because they are in series, all the string will be affected. Their generation will drop down. But if we can use our optimizer in each panel, it can control each module and optimize each panel's generation. And each panel, even if one module they are shaded, for the other module, they can still work independently. So with the help of this, each component they can work fully working and work in its best point. This is a case for comparison. For the orange side and also for the blue side. For the orange side, for the module, they don't have the optimizer, but for the blue panel, they install the optimizer, and they are in the same rooftop. And after several months comparison, we will find out that for the blue panel with the optimizer, their yield is nearly 10 to 13% more than the orange module, which don't have the optimizer. So this optimizer is a very, very important component to help customer get a higher yield. And what's more, for the Philippine electric code, it have a clearly requirement about the rapid shutdown. This rapid shutdown means that for the Philippine Electric Code, it requires a solar system to shut down, DC side shut down, if the AC side or grid side have no power. If the power outage happen, if the inverter shut down, if there are no any energy resource from the AC side, then your DC side, you have to shut down. So what can we do to be compliant to this requirement? It's also through the PV optimizer. With the help of our PV optimizer, we can achieve the rapid shutdown function directly. No need any other rapid shutdown box. No need any other rapid shutdown device. It's already included in our optimizer. If the AC side shut down, our optimizer can directly decrease the voltage from the DC side from 1000 volts to 0 volts to ensure the safety for the firefighter, for the end user, for the owner of the roof of the house. So this is what we can do to ensure the safety for this system. And also with the help of the optimizer, you can connect more modules in one stream. For example, before, if there are no optimizer, you can connect maybe 10 or 12 modules per string. This is maximum. But with the help of the optimizer, you can install more. You can install maximum 200% overloading. For example, if this system is a 5 kilowatt system, then you can install, if the inverter is 5 kilowatt AC, you can install 10 kilowatt DC. This is totally no problem for our solution. And it will greatly help the end user help the EPC to do the commissioning to the installation. It will be much easier. So what I have shared is the solar part, and next I will share our energy storage system, which is our Luna 2000. So for our Luna 2000, this is its performance. This is appearance. It consists of two parts. One is power module. Is used for the power monitoring. It will not store the energy. But another is the battery module. So for the battery module, it's used for the energy storage. Each battery module is 5 kilowatt hour. And you can connect maximum 3 modules in one system. So for this system, the energy capacity could be 5 or 10 or 15 kilowatt hour for one system. So based on your real requirement, you can design it accordingly. You can choose the battery modules quantity, 5 kilowatt hour or 10 or 15. And also for the battery module, we have a built-in energy optimizer. So internally, these batteries, they are not in series anymore. They are in parallel. We have the built-in energy optimizer to optimize each battery module's working status, just like the optimizer in the solar rooftop. So even if the battery is not new, for example, the first one is an old battery, and the second one, third one, they are new battery. No need to worry. We can directly apply them together because we have the built-in energy optimizer to ensure that each component work in their best point. So this is our solution. I would say that for each battery module is 15 kilogram, and we support a parallel operation for one inverter, which means that for one inverter, you can connect to maximum 6 battery modules, right? So for the energy capacity, the minimum is 5 kilowatt hour for one module, and the minimum will be 30 kilowatt hour for 2 systems, which means that you can connect maximum 2 systems and 30 kilowatt hour for your roof, for your house, for the application. And what's more, we support a 100% DOD, depth of discharge. Some people will be curious and say that how is it possible to support 100% DOD? If you ask me this question 2 years ago, I would say that's not possible. But now with the Huawei's own technology, 100% DOD is already doable. We support 100% discharging, and you can make full use of the capacity from the battery. But definitely, if you want, you can also limit it and set it 80%. It's also okay. You can still left some energy in the battery, but if you just want to make full use of the battery, you can set it 100%. This is totally doable right now for Huawei technology. And we have 3 output discharging power, which is 2.5 kilowatts, 5 kilowatts, and 10 kilowatts. So we have different power, we have different energy rates. We can design it based on customers' requirement accordingly. So our design is very, very flexible. And we provide a 3-layer protection. For the battery, the cell level, we consider the lithium iron phosphate. This is the lithium iron phosphate battery for a safe and stable performance. And for the pack level, each battery pack, we have 8 sensors to monitor the temperature. So if for this system, totally 3 battery module, there will be totally 24 sensors to monitor all the state, all the operation. And for the system level, our battery is IP66 and is fully applicable for the outdoor application. It's no problem to install it outside. And we are also compliant to the safety standard VDE 2510. So no need to worry about the safety. It's extremely safe, but definitely because if you install it at outside, for the outside, the temperature will be higher. So we still recommend the developer to install it inside to have a low temperature operating environment. And also for Huawei, we provide a power backup solution. This is totally new this year. It's already ready, and we have many applications right now in Philippine market, like in Luzon Island, in Mindanao Island. Some customer, they already install Huawei solar inverter using our battery and our backup box. So it's in this picture, you can see that if the power outage happen, all the roof, all the villa, all the house, they will no power anymore. But for this one, it still have the power because they have our Huawei backup solution. So what does it mean? It means that for Huawei, we provide a component which is backup box. So for this backup box, it will distinguish the output to 2 parts. One is the critical load, another is the non-critical load, okay? So during the power outage, for the non-critical load, it will be chipped. And all the power from the solar, from the battery, the power will be provided to the critical load. So during the power outage, during the critical load, they can still get the energy from the solar and also from the battery. And then when the grid recover, the inverter can still provide energy to the non-critical load. So the critical load will get energy during the power outage, and when the grid is normal, both of them can still get energy from both solar and also the grid. So this is the our backup power solution. So I said no worry of the power outage because now we have the backup box. And the good thing is that if the power outage is not so frequent, you can also don't use the backup box. Just use of the battery and use the energy from the solar every day to help you save the electricity cost. This is also totally doable. And I will share our 2 times power battery ready for more energy. What does it mean? It means that right now, with the help of our Huawei solution, inverter plus battery plus our optimizer, we support a 2 times power. For example, for the inverter, if it's 5 kilowatts, for the inverter is 5 kilowatt AC, then you can connect maximum 10 kilowatts. You can connect maximum 10 kilowatts for the DC. This is totally no problem, and we can achieve 200% DC-AC ratio. Why we can do this? Because if you install 10 kilowatt, then in the daytime, 5 kilowatt can provide it to your house, to your local consumption. Another 5 kilowatt will be provided to the battery. So for the battery, it can be charged in the daytime, and in the nighttime, you can use the energy from the battery to use it in the nighttime for your aircon, for your refrigerator, for your lights, to help you save the electricity costs. Because we know that for Philippine DU, the tariff is quite high, nearly 10 pesos per kilowatt hour. So using the solar, it can really help end user to save the electricity costs. The business mode is totally doable. I will share the data later. So this is the finance model for one system, solar plus storage. So in this situation, you can consider 3 kilowatt AC inverter plus 6 kilowatt solar panel. So the specific production will be nearly 1,600 kilowatt hour per kilowatt P per year. And for the tariff, we consider 10.5 peso per kilowatt hour. I think this is the average level for the Luzon Island. For the Luzon Island, but for the Mindanao of Visayas, I believe that the tariff sometimes it will be higher, 12 or 13 peso per kilowatt hour. So the total capex, including the device cost, including the shipment, including the installation, it will be nearly 700 to 800,000 pesos for all the system. And we will see that for the ROI here, it's very good. For the ROI, it's nearly 6 years. So for the 6 years, you will get the money paid back. And at the start of the 7th year, you have already paid back your investments, and you can earn the money every year. So this is the system, including the solar and also the battery. And if there are no battery, just purely solar, the ROI will be better. The ROI will be nearly 3.5 years averagely for the purely solar. So after 3.5 years, your investment, you can get back your investment, and then every month, every day, you can enjoy the solar energy and save the electricity costs. So the finance model is extremely good because the tariff is so high. So no matter how we calculate, this business model is always doable. So this is for a tiny system, 3 kilowatt. If you consider a bigger system like this one, now the inverter is 5 kilowatts, the panel is 10 kilowatts, the battery, they are 20 kilowatt hour. Same, because now the system is bigger, so definitely the capex will be higher, nearly 1 million, 1.5, 1 million pesos, but still, the ROI is very, very good, nearly 6 years. And if you also consider the purely solar, it's also doable. And the ROI will be nearly 3.5 years also. Especially right now, is the pandemic. Due to the lockdown, people they have to work at home, right? And also the children, they cannot go to the school. They are educating at home. So definitely for the end user, the electricity consumption will be higher. Especially now, there is a shortage of the electricity supply from the DU. So definitely for the tariff, it will be higher. So it's very, very, for the commercial part, finance part, is really have a very obvious benefit for everyone. If you have the opportunity, you have the investment, you can really consider a solar system, because the tariff is so high. So no matter how, always you can win. This is solar. It's very easy. It's very easy because for me, my college, local college, they also have their own house, and they also buy our solar inverter from Huawei, from our partner Breeze, and it just take 1 day for the EPC team to finish all the installation. And if you want, you can check the status. You can check your system every day in your app. So it's really very convenient. For example, if you invest if you save 700,000 pesos in the bank, will the bank pay you 3,000 pesos every month? I believe no, right? But if you invest 700,000 pesos for the solar system, every month you can save nearly 3,000 to 4,000 pesos every month. So this is the difference. So this is why we recommend the solar installation. It's totally doable here. And for the system operation mode, it's also not complex. Just in the daytime, we make use of the energy from the solar, and in the nighttime, we make use of the energy from the battery. So in the daytime, in the early morning, when the battery they are fully discharging, the battery will go into the standby mode. And in the daytime, when there's a solar is raising, the irradiation, the sunshine is increasing, we can get the energy. And for the energy, it will be provided to the local consumption force to satisfy your local consumption. help you save the cost. And if there are extra energy, the extra energy you can get it, you can save it in the battery, and then you can use it in the nighttime. So in the nighttime, you can use the energy from the battery. So totally every day, you can use the energy from the solar for maybe for a 10 kilowatt system, you can get 40 kilowatt hour every day. So if you consider 40 kilowatt hour every day, which means it's nearly 400 pesos per day, right? 400 pesos per day. And if you consider 1 month, so you can multiply by 30. So 400 pesos per day multiplied by 30, which means it's nearly 12,000 pesos every month. So this is the avenue you can get every month. And we support the backup box for the power outage. If the power outage happens, for the critical load, it can get power and you can still get energy for both solar and storage. So definitely your system will be more stable even if the power outage happens. And we also support several inverter parallel together. If your house is really very big, you also want to use our energy storage system, we support the device parallel together to provide energy, to achieve a higher system, a bigger system. And the one more good thing is that now we are not just supporting the on-grid scenario, we also support the off-grid scenario. For our solar inverter, our single-phase solar inverter, we support a purely off-grid scenario, no grid anymore. It's totally off-grid, like in some island. So now we also support this. Just use our energy storage system in this scenario. And also we need to ensure the safety for the system. So not just the optimizer, not just the battery. For our inverter, it's also functional and provide a complete solution to ensure the safety. Fourth is about our arcing AFCI function, arc fault current interrupts. Because we know that arc fault is a very serious risk and challenge for the end user, for the firefighter, due to the unbroken PV cable, due to the loosened PV connector, due to the unreliable connection. So in this location, arc fault will happen, and it will reach a very high temperature, even higher than 3,000 degrees. So what Huawei can avoid this, for Huawei, we provide a AFCI function. Because arc fault is very hard to detect, it's very tiny. So it's very tiny. So we will use the arc fault. AFCI function to do the detection. And if the arc fault is detected by Huawei, we can directly shut down the system to further protection. It's very safe. And for Huawei, we are much better. For our single phase, our AFCI detection support 80 meter. And for the three-phase, we support 200 meter. And our shutdown time is much better than the IC standard. We support less than 0.5 second, millisecond level. So there's a picture for reference. Left side, you can see that if I close this function, the AFCI, the arc fault will always exist and it will not disappear. But if we shut down this function, you will see that the arc fault shut down immediately. The arc fault disappear immediately. So this is how we can prevent. The arc fault and ensure the safety for the comparison. And I will mention that for AFCI is also a mandatory requirement from the Philippine Electric Code solar chapter. So it's very important for the end user, for the EPC customer to consider this function. And last is about the battery experience. So let me make a brief summarize. So Huawei, just like I mentioned, we are not just an inverter supplier, but also a one-stop solution provider. We provide optimizer, our partner provide a module, we provide inverter, battery, management system, optimizer, and our app. So we provide a complete solution to you directly. You don't need to contact several device vendor, you just contact our local partner. And also we are also here for supporting you. So it will be easier for your procurement and also for the maintenance, for the after-sales service. This is Huawei's advantage because we have been market for more than 20 years. And this is our Fusion Solar app. You will find out that you can monitor all the components in your app. It's very extremely convenient. Like this is the app. You can monitor the inverter, the dongle, the battery optimizer meter. You can get how many energy you can get every day, every month. You can get the data. You can get the real-time data. You can see if they are working normally and if this what about the weather is sunny or is rainy. So it's extremely convenient. And for the communication, it's through our dongle, WLAN FE and also 4G dongle. For the communication with the management system, use your app or laptop. And for our solar inverter, we are no fuse design. You will not find any fuse, no any LCD screen, no any button in our device, because all these things they are quickly apart. It will increase the failure rate, so we will not consider this. And also the cooling is through the natural cooling, no fans internally, so no need to worry about the noisy. Our failure rate is extremely low, lower than 0.5%. This is the annual level all over the world. And also we have the local warehouse here. It's in Taguig. So if your device failed due to Huawei's reason, then we will ship a new one to you in 2 business days if it's under the standard warranty. Now our solar inverter standard warranty for residential is 10 years. And the lifespan is 25 years. So totally no need to worry about the application, about operation. It's extremely stable. So let me make a brief summarize for Huawei. In this solar system, in this scenario, we provide our solar inverter. We provide energy storage system, optimizer, backup box, and also our dongle, meter, app, and management system. For the battery, for the optimizer or backup box, it's optional. It's not mandatory. If you want to make full use of the solar, you can consider the storage. And if you consider a shorter ROI, you can also just consider purely solar. And all of our device, we support the AFCI function. We support the backup box. We support the storage. It's the same model. Which means that for one model, we support on-grid mode, we support off-grid mode, and we also support the hybrid mode. Only one model. You don't need to choose other model. Just one model for the application. And also, if you have any interest about the procurement, if you have any question or concern about the solar system, it's very happy to introduce our local partner, Bruce, and also our great partner, Luxara Solar Power Engineer Service. They will provide you a complete solution, for both the device, the panel, the installation, the electric design, rooftop design, and sir for Luxara is also a very experienced engineer in this market, and I think he have a very deep understanding about the system, about the market. So if you have any question, just directly contact us, and we will fully support you commercially, technically, no need to worry. So this is today my topic. Yeah, thank you for your time. Appreciate IIE this opportunity to let me do this presentation. Yeah, thank you all. Thank you, host. Thank you. So if you have any question, you can directly let me know. I think someone asked what is the service life for battery module or battery storage system. This is a very good question, sir. It's like this. For the battery, it's very hard for us to say the lifespan because it's related on how you use it. It's related on the charging or discharging circle. So different using habits, different using strategy will have a different results in a different aging and different lifespan for the battery. So it's not easy to say this. It's different. It's not same like the solar. For the battery, it's more complex. But no need to worry, sir. For Huawei, our battery here is 5 years standard warranty. Hello, sir. Luzara.
Hello, Ken.
Can we use different battery from other vendor? Sir, it's like this. Now for our system, we just support Huawei's battery and also LG's battery. But if you want to achieve a better control and better management, you should consider Huawei's own battery because they are under the same system. The internal software, the internal algorithm, it's aligned. It's aligned. So now we support only Huawei and LG, but it's better to use Huawei. Yeah, so yeah, if you have more question, you can directly email us, email Sir Gio Luzara or our Bruce, or if you have any technical question, you can also contact me and we will support you. Yeah. Thank you. Thank you, host.
You can put that in the chat box, no, for the question.
Yeah, sure. Sure.
Host, paki-unmute ikaw. The host. Nakamute yung host.
Okay, we will award this certificate of appreciation. Let me read the contents of the certificate. IIEE Cebu chapter present the certificate of appreciation in gratitude and acknowledgement of the invaluable support of our gold sponsor in the 20th Eastern and Eastern Central Visayas Virtual Regional Conference. Here, given this 18th day of September 2021, signed by IIEE Cebu Chapter President Engineer Mario Tabanyag, signed by the Regional 7 Governor Engineer Felipe Neliama, signed by the VP Technical Affairs IIE Cebu Chapter Engineer Lowell Ratelia, signed by Technical Consultant and Advisor Engineer Brian Pasilan. The certificate of appreciation is presented to Brills Huawei Digital Power. So a warm of applause to our sponsor. Thank you very much. So it's good to know that Brills, Huawei, and Gil Rosales are the one supporting Huawei products. So it's good that Governor Gil exchange, no? Pinauna niya yung Huawei Digital Power para ma-support din sa presentation niya. So Governor Gil, ikaw nang susunod. So the next speaker will be discussing the topic designing solar plus storage system and residential energy solution. Our speaker is a former governor, and he is the president and CEO of Losares Solar Power Engineering Services. Ladies and gentlemen, please help me welcome Engineer Gil Rosales. Losares.
Thank you,
Sir?
sir. Thank you very much.
Okay. Take it away. Tingnan nyo si Gob, ang gandang lalaki pa rin, no?
Teka, sandali po, nawala yata yung ano ko. Bakit ganon? Stop muna sharing. Yeah. Yeah. Okay.
Parang DJ ka, Gob, ah.
Ha? Hindi ko nga nilagay.
Parang DJ.
Hindi ko nga nilagay yung ano yung sombrero para makita nyo na my head shines brighter than the sun.
Sige, Gob.
Yeah, good afternoon. Kaya ko po pinauna kayong yung Huawei kasi naka-schedule sila ng 10:30. Kanina pa ako, simula pa lang na 7:30. I'm already on board, no? And I'm very happy for that, no? Kaya pinauna ko muna sila because of the delay, some little delay on us, no? So first of all, thank you po, no? Dito po sa congratulations, no? Si IIE Cebu chapter, no, for this 20th Eastern Central Visayas Regional Conference, no? Talagang very fantastic, and the CPD units, no, that will be in all the topics, no? And I'm glad that na-invite ako ni Engineer Brian Pasilan, no? And I would like to comment also na nakita ko na narito is our former national president, my good friend Jules Alcantara from Cebu, and also our former national president Joby Panghilason. Then good morning Gob Orlando Villapanya of the Foreign Region. Then I see also my counterpart in my Central Luzon region, si Governor Woody Erama. And also you have Sir Nonilo Nacion, no? On board, no? Okay, mabuti kanina na i-present yung sa dito sa solar, no? That is the storage, no? The Luna 2000 of Huawei, because my presentation that I will share you today will be based on the that will be what I can say that, no, a solar plus storage. Okay, a solar plus storage ngayon in the industry. As you know, solar has grown quickly, no, over the last decade, no, but ultimately to tap into the full value of solar energy, okay, we need a way to control the timing of that energy use, no? And that the best way to do that is with energy storage. You see, ang natin, ang solar talagang conquer, no? The Philippine island last year on the third quarter, nagkaroon tayo ng pandemic na all quarantine. So everybody, no, all over the Philippines, that is now, no, looking forward, no, to install solar installation at the rooftop, no, lalo na ngayon sa mga bahay, because everybody are quarantine. Dito sa amin sa Maynila, naka alert level number 4, no, of the quarantine things, no. So everybody has to, pag mainit ang panahon, so nandiyan, di ba? Dapat magkaroon ka ng solar installation for the savings para dun sa aircon mo, lalo na makapaglagay ka sa living room, no mo? Wherein hindi lang ang mga bata mag-aaral na naka-quarantine na nga, nasa loob pa ng kwarto na may aircon, then double quarantine. Okay? So if you have your in the living room, on the sala na meron kang small aircon lang diyan for the then, and that will be during the day, during the class, so it will be diba? It will be very fantastic in terms of reducing savings. Now, the topic about solar plus storage, no? Ang topic ko yung designing, no? Solar plus storage, no? System for residential energy solution. Maano po ito? In fact, it is a matter of 3 hours, no? Na presentation, but I will just make it na frame kasi I was just given 1 hour, then gusto ko sana magkaroon ng at least mga 15 minutes for question and answer kasi this is a topic that you will enjoy. And in fact, the storage system, no, na dito sa atin sa Pilipinas, una pa lang nangyari last December, no, last quarter na pumasok dito yung Huawei, no. It is now a new battery system, a new battery energy storage system. I think you know about BESS, no? Battery energy storage system na nangyayari ngayon yung mga papunta sa smart grid, right? That is yung mga megawatts, no, in the container all over the country. There are now projects on that, no, supporting our grid, no? And also in the very near future, I think, especially in Negros Island, where we have so many solar farms, kapag nagkaroon ng clouding, no, nawala ng bagsak, and this is DC, that is solar, so kailangan ng battery energy storage system in order to come up with this, no, pati sa smart grid natin para maging hindi tayo reliable. And that will be the thing here, no, because now energy storage is the ultimate partner for solar energy. After all, the sun only shines at certain times of the day. Batteries allow you to consume more of the clean energy produced by solar energy, making the value of your solar investment shine through even more. Kagaya po ng ko, di ba? Ng ulo ko, my shine, sabi nila my shine, my head shines brighter than the sun. And I look forward to that. This is a clean power from the sun, a clean switching, no, to clean solar energy. Okay, mag-share po ako, no. Ano ba 'to? Teka, sandali pa. What's happening? Excuse me po, What I will do is full screen. Okay. Naka-panelist ba po ako? Naka-panelist po? Okay, okay na po, ano? Hello? Hello? Hello po?
Sir, kita na po.
Okay. Kung
Sige,
buo siya,
kita
no?
na po.
Buo. Yeah, okay.
Go on na siya.
Okay. Okay, thank you po. Okay, so the topic is designing solar plus storage system for residential energy solution. Okay, as climate change becomes more severe, no, more weather events will worsen, causing more power outages, no, for longer durations. Actually, sa atin, 'di ba, sa renewable portfolio standards natin, dapat by 2030, we have to reach at least 30% no renewable to change the fossil fuel, the coal and so on, ma. Kapag hindi, then that will be a problem for us with respect to our Paris agreement on the climate change, no. Magkaroon tayo ng mga flash floods and so on. So, I hope that with this, no, with the green renewable energy option, the net metering, and more no solar installation, more renewable energy installation, we can make it, no. So the coronavirus has also emphasized importance of sheltering at home, and battery backup, that is with solar, that is the solar plus storage, is the most no effective way to ensure that the lights can stay on in an outage. So your energy system, something like that, no, become better, cleaner energy, clean energy, and backup storage. So you can see here, no, on this point, no, itong inverter natin, okay. Then at the bottom, iyan na po yung battery energy storage. Yung dati, ang alam natin, kapag sinabi nating battery for solar, yun yung DC coupled. Ito po yung mga lead acid dati, no, the battery chemistry, yung mga BRLA, no, variable liquid, no, acid, no, the PBA, no. But now, yung dumating, no, thank you to Mr. Tesla, dumating yung ano, di ba, lithium ion batteries. Okay? The lithium ion batteries, which gives us better, no, in terms of the energy density. Saka ngayon, kapag yung mga dati na mga lead acid na battery, yung mga gel type, no, lead acid, yung fluid, yung depth of discharge niya hanggang 50% lang. So you cannot make use of the charging and discharging of that in the full cycle. Nowadays, with this battery management system, the new battery, no, and in compliance also, naalaman natin na, di ba, yung sa electric vehicle natin, it will be coming soon, we will be seeing all over the Philippines on the road, no, yung electric vehicle, and that is already approved, no, from the Republic Act, no, for the utilization of that, no. And I hope that marami pa tayong infrastructure and charging station. So it is now coupled with this solar plus storage, no. So when you have this at home, then there is that charging station to be coupled with your battery system. Ngayon yung lithium ion, you know that we use it in cell phone, okay? And one type of lithium ion batteries na ano is lithium iron phosphate, no, LiFePO4. Yung po ngayon yung ano, that is the new thing, no, in the system, no, na ginagamit ngayon ng mga with respect to the solar plus storage. So ngayon, hindi na siya makikita mo, hindi na battery bank, no, na ito na po siya, no ba? This one, no, ano na po siya in module. So merong nasa taas, nandun yung battery power module na meron siyang energy management system. Then yung sa baba, there is this mga ano siya, mga module na 5 kilowatt hour, then 10 kilowatt hour, 15 kilowatt hour, as explained kanina ni Engineer Ken, no, of Huawei, no, with respect to that. And also other companies, no, like SMA, like Goodwe, okay, like Pronews, they have also their battery system. Ang pagkakaiba lang ngayon na pagpasok dito ngayon ng yung pagpasok sa Pilipinas ng battery system, yung Luna 2000 na Huawei, yung inverter nila battery ready. So hindi na yung separate pa yung system. Okay? Okay. So what happened? Okay, the sun delivers valued energy to your home every single day, no? Completely free of charge. A PV roof system allows you to generate electricity for your home, save it to 80% of energy cost, and contribute to the energy transaction. So that is what we call the PV, no? Photovoltaic plus energy storage system. So you see, hindi na battery naka-module na kagaya nito, no? I think this is a Tesla thing, no? Okay? So that is that thing here. Now we have residential storage. We have cost, system size, reliability, power generation, on-off grid. Kaya ngayon po, yung mga inverter ngayon is that na siya, grid tied, then hybrid. So pwede siyang on-grid, pwede siyang off-grid. It is battery ready already. As you can see here, yung rito, yung battery rito, LG Chem, di ba? On that, kita nyo rito, we have the solar, then ito po yung system niya, di ba? On this, rin siya, module type, no? Where there is a management system, then you see, there is that electric vehicle charging that completes the system, okay? So what components make up a solar PV system? So, solar photovoltaic panels, we know that is to convert solar energy to electricity. Inverters to convert DC electricity to AC electricity. Ayun yung main the electronic part, the only electronic part of the system, the inverter, no? To convert DC to AC. Then the racking and mounting system, no? To affix your solar panels to your roof or to the ground depending upon your installation type. Performance monitoring, ito na po yung to track and monitor the output and health of your solar panels and inverters. Dati, di ba, hindi pa natin nakikita because of the technology nowadays. Meron ng application, may apps na sa smart phone natin, no? Whether you use iOS, no? Apple, you use Android, no? Or you use Huawei o operating station, makikita mo yung application nyo on that. You can monitor. Kahit na nasaan ka, kahit nasa ibang bansa ka, mamamonitor mo yung harvest ng solar production mo, no? As I'll explain kanina. Okay, so very simple system on this. Solar cells absorbs energy from the sunlight, okay? Then the cells that collect the energy turn it to DC by the inverter. Then DC electricity is passed to the inverter to convert to AC. Then you can use the electricity in your home, store it if you have a battery system, okay, with what we call the battery energy storage system, or send it back to the grid. Yun yung tinatawag natin kapag applied ka ng net metering, you are a qualified end user, no, a QA of net metering, you can export that meter and they will pay it, no, from your export, no, and that is you get what we call an renewable energy credit, no? Okay? So that is another savings from that, okay? So there are actually two basic types of inverters, no? String or central, then we have the microinverter. I think etong most common natin ngayon dito, yung natin sa array, etong string inverter, no? Or na ginagamit natin ngayon sa mga bahay, sa commercial, pati ngayon sa solar farm. In fact, the central inverter, dati sa mga solar farm, ngayon pinapalitan na ng string because of the technology advancement ng string, no? Then we have, ito nakaano siya sa string. I will discuss to you mamaya about how we will somewhat design on this. I prepare just a simple design. Then meron tayong what you call that, a sample design problem, but I think because of the time allocation, I will just include it on the on those things na future reading nyo, no, when I give you the copy of my presentation. Then we have the microinverter. Ito po yung string centralized inverter na yung inverter niya per module. Okay? Hindi kagaya ng sa string or central, meron siya mga string na nakalagay. Ito, bawat inverter, bawat module, meron siyang inverter. Okay? So, ito yung mga brand ngayon, kagaya ngayon, may brand dito, yung dinadala ng M-Spectrum, no, ng Meralco, yung N-Pace, no, microinverter. Then we have AP system, okay, and other inverters, yung whole miles, no, from China. You have those microinverter. Now, meron din tayong power optimizers inverter na string inverter mo, then meron kang optimizer, no, naka-module level din. Yun yung kaninang na-discuss na if you have this, parang sa microinverter, you have the requirements now from our Philippine Electrical Code, no, 2017, from Article 6.90.2.6 A through D, na kailangan natin yung tinatawag na rapid shutdown system. So, kapag naka-microinverter ka, there is a built-in already rapid shutdown device system. And also, if you have a string inverter with optimizer, with that optimizer, you have a built-in, no, rapid shutdown system. Aside from more energy, at least 30% that you can connect, no, to the that you can have, and you can maximize your PV input, no, na solar mo sa taas. Let us say if you just have a 5 kilowatt inverter, may optimizer ka, po pwedeng 200%. You can just not just have 5 kilowatt but 10 kilowatt, no, on your rooftop. Okay? Now, the racking and mounting system are the pieces of hardware that affix your solar panels to your roof or to the ground. Ito ngayon, there are two types, no? Yung fixed mount, na ito yung nakalagay natin na remain stationary, nasa bubong natin, ma? And meron ngayon tracking, dito wala pa yata tayo sa Pilipinas, na merong single axis, merong dual axis na ipinipalo yung sun, di ba? On this basis. But in the United States and in Europe, meron na sila mga ganito, di ba? In fact, yung mga lumalabas ngayon ng mga panel na malalaki, no? Yung mga larger size like mga 600 watts, no? Dito na kailangan dito sa tracking, no? Mas maano. Kasi una-una, pag sa fixed natin, we need space, di ba? Nang yung natin, kung saan ilalagay natin sa bubong. Etong sa fixed mount, limited lang space, lang dito, maliit lang ang space sa kailangan mo, no? Yung laki lang ng area niya, no, for the tracking mounts. And it is very important now, this tracking, lalo na sa atin, meron na tayong signal number 5, no, in terms of the wind. Kaya dapat yung mga racking system dito, dapat yan, ba? Yan, hindi kinakalawang, saka dapat hindi kagaya nito, dalawa lang, di ba? So you have to what you call this one here on the track, on that thing here, dapat tatlo na ngayon yan, di ba? But of course, depende yan sa orientation niya, sa kayong pagkakalagay niya, either in the nakaganyan, di ba, na portrait o kaya landscape. Okay? So depende yan. And kapag let us say mas maganda yung tatlo, di ba? Meron ka ritong nakalagay sa pangatlo rito, di ba? Better. Then you add more L footers. Okay? Para sa din nakaano ng konti, there are some spaces for the wind, kung saan yung galing ng wind, para nakakahinga siya sa there is no much pressure, which is very important nowadays. Okay? Okay. Now, yung performance monitoring, ayan po yung sinasabi ko sa inyo, di ba? Provide you with the detailed information about the performance of your solar panel. With a monitoring system, you can measure and track the amount of your system produces on an hourly basis. Your real time. So you can have this from the cell phone, no, from the smart phone natin. Then you can have from the logger, no, and also this another monitoring system. Ngayon, kasi very ano yung ano natin in terms of the smartphone, no, na gamit natin to pirme. So you can track there, no? Kung ano, yung application mo, let us say, kung ano yung hinaharvest niya, ano yung binibigay niya dun sa load mo, sa consumption mo, no, yung you can have your what you call the self-consumption from your solar na pumapasok sa load mo. Kung ano rin nakikita mo, ano ba yung pinapasok na from the input the input meter, no? Di ba meron tayo export, di ba? Yung export, yung pag ano natin ngayon, when we have the import, from the import meter, yun yung galing sa distribution utility. Makikita kung meron. Then, kapag may battery ka, makikita mo rin, kapag kasi yung battery ngayon, because of the technology, you can use the battery, no, to provide AC. So, hindi na lang DC coupled ang battery system ngayon, it is also AC coupled. So, DC and AC. So, what you mean to say is that, kapag nakaset up siya, no, na yung battery mo, na-charge na siya, pag charge na siya, tutulong na siya mag-provide ng output. Mag-provide ng AC output, no? To your load. Ngayon, kapag sobra na sa load, then applied ka ng net metering, qualified end user ka, then you can also export that to the grid. So, ayun yung kagandahan ng system po ngayon. Okay? So, you have those things there, no, on the okay. So what is the grid tied, no? Pag sinabi natin grid tied, I will just limit on this grid tied, no, and hybrid. Kasi ito yung solar plus storage natin. Grid tied, on grid, utility interactive, grid intertie, and grid backfeeding, terms used to describe the same concept. That is a solar system that is connected to the utility power grid. Yung tinatawag na nakaparallel siya. Okay? So, system is utility interactive, and the electricity produced by the solar panel blend with the electricity coming from the distribution utility or sa mga provision natin electric cooperative. No? So, a grid tie inverter has an anti-islanding protection. Ano po yan? Yan yung safety feature that automatically disables the inverter PV feature if it detects that there is no grid electricity. What does it mean? Kapag nawala ng kuryente, automatic na inverter mo dapat meron siyang no islanding, no? Hindi siya hindi siya magba-backfeed kasi kawawa naman po yung mga noon, napapatayin sila kasi you know the voltages, no, in the residential, in the rooftop ng mga residential, that is 600 volts. Sa commercial po, that is 1,000 volts. Yung pong sa mga ground mounted sa solar farm, that is 1,500. Kaya lang yung 600 volts lang sa residential, that is so much po. Okay? So, it is solar is power generation. The only electronic part, which is just a part, is the inverter, no? Kaya dapat talaga rito ang mag-pipirma ng is a professional electrical engineer. Period, no? 101%. Okay. It means that your solar PV rooftop will not work during blackouts. Okay? So kaya kapag nag-a-apply ka sa distribution utility for your net metering, unang requirements diyan yung specification na inverter mo saka yung certificate of conformity na meron siyang anti-islanding protection. That is for the safety features. Okay? So what are the equipments for the grid tie? Grid tie inverter, microinverters, whether you use it, no, and the power meter. Ito po yung to replace the current power meter na kapag wala ka pang net metering, dapat zero export. Okay? That is, we'll need to replace the current power with one that is connected, no, to the, or that will be concluded on the net metering. So it is called the net meter or two-way meter. Ito na po yung natin, which is a bidirectional. So papalitan yung import meter natin, then papalitan niya ng bidirectional na nandoon po yung import and export. Kaya 2 metro. Then another metro na nilalagay ngayon from the regulation of the Energy Regulatory Committee, ERC, no, from DOE, yung pong REC meter, the Renewable Energy Certificate meter. Yung po yung, doon po natin makikita kung how much we are exporting. And how we collect those carbon credits, no? Binabayaran po yun yung REC meter certificate. I think now that is equivalent to 1 megawatt hour, no? If you have a REC applied meter. Okay? So, hybrid, ito na po yung solar plus storage, which combines both the grid tied and the off-grid system. Can be described as off-grid with the backup power o grid tie with extra battery storage. Yan na po ngayon. Yung pinakita ko rito, ito po yung sorry po. Yung dito na battery bank, ito yung mga lead acid natin dati. Okay? Na ginagawa nila na hybrid, kaya lang ngayon po, because of the new, no, the lithium iron phosphate, no? Yung lithium iron po kasi nagkaroon ng problema. I think some of you have heard about what happened, no? Doon sa Mart noon sa Amerika, na with the lithium ion nagkaroon ng sunog kasi meron siyang thermal stress. Ngayon with the battery technology na lithium iron phosphate, it has no thermal stress. Kaya lang mabigat siya kasi lithium iron. Kaya sa mga electric vehicle, malabo yung lithium iron, di ba? Na na battery ang ginagamit, lithium ion. Okay? So ito po yung grid tied, no? With battery backup. I call it solar plus storage, PV, no? Photovoltaic, then storage is BESS, battery energy storage system. Nakita nyo rito, from this, meron na tayong tinatawag na AC coupled battery inverter. Ngayon po, yung mga labas na inverter, no? Kasama na po siya. Ito yung grid tied dito, okay? On these things here, no? Ito yung grid tied. Okay? Ito yung grid tied inverter natin. Then, nakaano siya? Itong AC coupled battery inverter na to, kasama na po siya doon, no? Kasama siya doon. Okay? Yan po ngayon yung sinasabi natin na battery ready. Okay? So, with the AC coupled, then yung battery, nakaano na po siya dito sa battery niya, you have this battery system connected, no? What we call, no, na meron siyang tinatawag na critical load. Ito yung backup box, no, na another panel na ilalagay mo diyan yung ilalagay mo diyan yung tawag dito. Ilalagay mo yung i-connect mo yung mga pagdating ng brownout, no, nagkaroon ng power outage, those are only the critical loads that will be supplied by the battery. Okay? Okay. So a grid setup can be combined with the battery backup such as solar power charges the battery and backfeeds the grid when there is an excess. No? When the house needs more power than the solar array produce, it can pull from the grid or the battery. So dalawa po yung pinagkukunan natin, di ba? One from the grid, one from the battery kapag hindi kaya, no? So when the grid goes down, the battery supply power to a critical load sub panel. Ayun po yung critical loads, no? So yung iba non-critical, yung po nagkaroon ng brownout, hindi siya magpa-function. So which serves as a few household circuits, kagaya nung natin nilalagay natin dito pag meron tayo niyan, kagaya ng rep natin kasi 24 hours yun nakalagay siya diyan, di ba? Saka yung mga importante, yung kagaya sa project namin sa hospital, nakalagay yung critical loads ito sa ICU room, no? Sa panel niya, there is a sub panel for that, for the critical loads. This enables you to keep important things like the fridge, air conditioner, lighting, computers, and perhaps electric range production na kailangan mo during the power outage. Okay? So yung takbo ng niya, kapag nag-shift siya ron automatic, no, for the critical load power outage, depende sa battery mo, di ba? Kagaya kung meron kang 5 kilowatt hour, and that is for this battery system ngayon, it is 100% DOD, depth of discharge. So it means to say, yung 5,000 watts mo, no, 5 kilowatt, it is in 1 hour. Kaya kapag ang load mo is only half, magiging 2 oras. Okay? So, kunyari 2,500 lang ang ano mo, magiging what you call that, magiging 2 hours ngayon instead of 1 hour lang. Ngayon, let us say you have 5 kilowatt hour, tapos ang load mo lang is 2,000 o 2 kilowatt, no? Kaya magiging 2.5 hours tatakbo yung battery mo. So ganun kaganda ang battery system ngayon. There is that energy management system. Okay? So when we have our di ba, on this, no? We have the PV cells in series. Okay? Alam natin pag series, 'di ba, constant 'yan. Then we have the solar cells, then the current same voltage double, no? Nakita nyo rito from the curve, ito yung IV curve no, which is the main thing, no, in our performance characteristic. Kapag single cell, then we have the 2 cells, no. Kaya 0.6, no, yung ano niya rito, then it is 1.2. Okay? Kapag dalawang 2 in series. So you have something like that. Kapag parallel naman, voltage same, current double. So, yung ano natin, yung sa design natin nito, dapat meron tayong mga string series yon, dapat marami tayong parallel para to increase pag parallel ka, you increase voltage. Kaya kapag same voltages, no, in parallel, kasi from the Kirchhoff's voltage law, di ba, same voltages but the current multiplies. Okay, it is a summation as you have seen this, no? So that is the effect of the series in the parallel BI curve, no? So you have the single, you have the maximum power point, no, in terms of this maximum power point tracking, MPPT, where you can get, no, the maximum voltages and the maximum current per hour. Yun po yung ang current natin, yun po yung harvest. Okay? So the more voltages the more array in series that we parallel, the more kilowatt, no, DC power that we can get from our solar. Yan po yung sun from the roof for your home, no, how to produce your electricity. So solar plus storage allows you to generate your own green electricity with your very own rooftop PV system. So the electricity you do not use yourself is automatically fed into the utility. You will receive a feed-in tariff for that, no? Yung po ngayon, kapag ine-export mo, nasa ano pa lang tayo, blended generation charge. Kaya dito sa Maynila, from Meralco, kung 10 pesos to 11 pesos, o palagay mo 10 pesos, ang kapag nag-export ka, babayaran lang sa iyo ngayon kasi blended generation charge lang, it is only 4 pesos and 50 centavos. Kailan nagbabare rin po yon. So almost half lang ba? So alternately, you can store electricity in the battery for later use. A storage system can make you even more independent of utility companies. So with the solar plus storage, kasi pwede ngayon yung solar natin na AC coupled, pwede ngayon mag-apply ka rin na time of use. Kagaya rito sa amin, meron na time of use sa Meralco, diba? Dito sa amin sa distribution utility, you can apply for the time of use. Kapag meron kang solar plus storage, i-charge mo yung battery mo during the night. Kasi that is yung tinatawag na POP, no? Peak o peak. Yung rates niya during the at night, mababa. Then, pag fully charge siya, sa umaga mo siya gamitin, yung battery, then that will give you more, that is peak rates. Kaya babayaran sa iyo peak rates. Then you export that. Ayun po yung system niya yun. Kaya with respect to this, kapag nangyari, kagaya ngayon nangyayari sa California, this is now the craze, no? And the government has given them incentive tax credit and also many freebies, no? Pati mga nagkakapag loan, then maglagay ka lang na solar. And in terms of that, para bang nangyayari, you are an independent, no? You are already a prosumers, no? You produce and also you consume. But ang nangyayari ngayon with the solar plus storage, ang grid ngayon, ang nagiging backup mo na lang because you can have your energy independently. You can have power, okay, on your own. So yan po yung series kanina na ito yung behind the meter. Kita nyo rito during the in terms of the supply from the grid's electricity consumption to. Tapos papasok ngayon, kinarge kasi yung battery, no, battery charge. Okay? Then pagdating ng 12 hours kasi malakas ang PV generation diyan, di ba? So bina-battery charge niya. Then from there, ito yung direct feed in, di ba? Sa nito, sa grid. Ito yung galing sa grid from the import. Then gagamitin mo pag load demand sa hapon kasi wala na siyang power. Wala na siyang di ba? Wala nang solar generation, wala nang sun. So, i-discharge mo siya. So that is the thing here, no? Kagaya rin po sa smart grid, yung tinatawag na duck carb. Para ma-solve mo yon, you have this battery energy storage system, the best. So that is the behind the meter, that is peak shaving, BRE, no? Variable renewable energy smoothing, time of use, no? And power quality improvement. And that is the design, ba? In terms of the modules, we have this main components, no? On the electrical side, the panel, and the inverter, and the photovoltaic modules. So, it is a sample of that where you have, no? On this, no? In terms of that, I will not discuss much about this, but I have given this to you. I will give you a copy in order that you can pinpoint on that. And as you can see, what is more important here is also the grounding electrodes. That is very important. Okay? On whatever things on this. Then also on the copy that I will give to you, meron akong sample doon na pati yung sa installation, kung gusto mo magpa-install ng ganito, ilan ang kailangan mong rack system, ilan ang kailangan mong whip, no, yung electrodes, no, grounding, ilang panels ang kailangan mo on that, ano yung mga dapat mong ilang mounting hardware like L-fit, like end clamps, like mid clamps, kung ilan ang kailangan, I will be giving that to you. But I think I have no much time to discuss that in detail. And this is an example of that where we have, no, ito yung battery, where we have the PV module with optimizer, kakonect siya doon sa inverter, no? Then there is the battery connected that, no? Ito na yung natin, yung energy smart string energy storage system. Then meron tayong backup box, no, for the critical loads, no. So nakakapasok po siya. Ito yung mga critical, so during the brownout, ito po yung natin. Then yung non-critical loads connected, no, to the grid. Kaya pag nagwalang hindi tatakbo yung sa non-critical. Okay? Then we have the main distribution panel. Okay? So you have that simple system, the design. Then when tayo dongle, whether it is a WLAN, no, yung data, or kaya you have the Wi-Fi, connect, no, to the system. Then meron tayo smart power sensor. Ito po yung sa limiter, no, zero export. So kapag hindi ka pa dapat meron kanyan. Ang problema po natin ngayon, kasi marami ngayon nag-install na hindi muna kumukuha ng electrical permit to proceed for the solar installation. Nag-a-apply lang ng electrical permit kapag nakakabit na yung solar, which is mali, di ba po? Dapat may mag-monitor po dyan from our OBO, no, from LGU, no, yung sa electrical division doon, na dapat with respect to that, also ang nangyayari lang, nag-a-apply lang ng electrical permit for the nakakabit na yung solar kasi mag-a-apply na net metering. Ngayon, pag matagal ng net metering, basta lalagyan lang nila ng zero export, ayos na. Kaya lang problema po yan kasi from the zero export, yung limiter na yon, ang kuryente po masyadong mabigat, di ba? Maliit na butas yan, kagaya ng tubig, naka-vacuum, lulusot-lusot. Kaya kapag may power outage, hindi ka may limiter ka, may lumalabas po dyan. In fact, sa mga namomonitor din yon dito sa production natin from the grid flow, no, makikita mo na meron lumalabas. So sana po maayos po natin to, and with our IIEE, no, in terms of that, we have to shut out, no, na electrical permit muna ay nang unang-una, then a good solar provider, and a single line diagram, no, that is signed and sealed by a professional electrical engineer. Then with the load analysis, nandun po yung voltage drop calculation, short circuit analysis. Okay? Then kapag may transformer, where there is a transformer sizing, that is the dapat gawin po dapat. Okay? Okay. When we size a natin, meron tayong tinatawag na ano, 'di ba, kung ilang hours, no? So you have the load profile energy demand, capacity of your plant solar PV rooftop. So the grid tied solar PV is sized based on the electricity consumption at daytime from 6 a.m. to 5 p.m. No? And recommendation, the total size of solar PV is not greater than the computed daytime consumption to avoid excess of power wastage. So, kapag naglagay ka po ng ano, hindi po pwede na ano, I'm not after for the zero net energy or the zero net house, energy house, no? Kasi po yung distribution utility, ano niya po yun di ba? Facilities niya yun. Kaya dapat may babayaran ka muna. Kaya kalimitan, pag maglalagay ka dapat ng solar, sa mga commercial, meron tinatawag silang contracted capacity. Hindi ka po pwede maglagay na solar above your contracted capacity. Dapat meron kang ano. It is just a savings for you. Okay? So, pag maglagay ka niyan, pati sa bahay, dapat gusto mo makasave lang ng 50%, 60%, hindi yung 100%. Okay? Kahit marami kang pera, ayun po yung dapat natin din i-monitor. Okay? So, that is how you assess your load. You have the load sizing, no? Appliance, kung ilan ang kailangan mo na watt hour per day. So, from here, you have the number of hours that you use. Then, you have the 16,700. So, that is kilowatt, no? So, 16,100 kailangan natin. Then, the equal hours per week, no? 116,900. Then, on the PV design simulation software, makikita natin po for the year, from January to ano, kung ano yung expected natin from our place, from the configuration, no? Pagka-mount ng solar panel natin, ilan yung mapoproduce niya for January, February, March, throughout the year. Doon naman mako-compute po. Okay? With respect to this, this is a manual in terms of your load profile. No? So when you want to size, let us say, no, directly, no, from a electricity bill, let us say you have a 500 kilowatt hours, no, per month, for the year. Kaya para makita natin per month nito, divide natin by 30, di ba? Kaya you have 16.7 kilowatt hour per day. Ayun ang ano mo from your 500 kilowatt. Di ba pag 10 pesos, so you are paying 5,000 pesos per month, no? On the average. Yung iba po gusto magpalagay ng solar, binabayaran lang 2,000. Para hindi po maayos kasi yung investment niya, hindi siya dapat at least mga 5,000 above, no? Then you have a savings kasi mahal pa, hindi pa kamurahan po no, ng solar system installation. So, kapag dinivide natin to, that is the isolation values, and that is in kilowatt hour per meter day. Ang peak-sun hours natin, ang Pilipinas from the map, nag-a-average lang tayo ng 4 to 5.5, depende sa area. Meron po yun nandun sa NREL, no? The National Renewable Energy Lab na ginawa nila. Kagaya dito sa Metro Manila, may area na 4 lang, merong area sa Laguna, Cavite na 3.8 lang. Then meron namang ibang area. Kagaya dyan sa Cebu, I think mga 4 point something, mga 4.5 Kaya yung peak hours. Kaya etong nakuha natin na 16.7, divide natin sa, let us say, no, I just use here 4 hours. Yan ang ano natin. Na dapat ilagay natin. Ito para to di ba, to cope up with the 500 kilowatt. That is 4,170 if the system is 100% efficient. But we know there are those derating factors. 'Di ba? Yung mismatch, yung ito pala, 'di ba? Inefficiencies, no, yung mga system loss. Mismatch or dust factor, no, soiling, array temperature factor, no? Temperature is very important. Wiring efficiencies, no? Imperfect electrical connection and inverter efficiency. So yun po yung mga point natin diyan, okay? So, ito po yung sizing, no, ng ating system. Yung derate factor, almost is 0.84. Kaya lang, mas ginagawa ko 0.8 kasi paborito ko po yung number 8. Kaya kita niyo yung logo ng kumpanya ko. 8, diba? Infinity. So, PV size, when you divide that, no, makakakuha ka ngayon ng dapat 5.22 kilowatt. So ngayon, kapag yan magiging 0, hindi yan ilalagay ko sa'yo. Babawasan ko yan. Let us say 50% lang o kaya 60% lang. Ayun na ilalagay natin. Okay? That is for the savings. Ngayon, for the 5.2 kilowatt, ilang panels? So if the solar panels for 35 watts, di-divide mo lang siya, kaya you need 12 panels for that. Kapag ang panels mo 380 watts, divide mo siya 13.74. So you need at least 14 panels for the 5.32 kilowatts na. Okay? You just multiply 380 by 14, that will be 5.33 or 5,320 watts, no? Peak. Now, so how many modules? Yung sinasabi natin, select the inverter and module, determine how many more you need in series. Ito pa yung sa stringing, ito yung pagdi-design. The power rating, kailangan natin dito yung specification ng module, no, ng solar panel saka yung inverter natin. Divide the system power design by the power string, how many series string matches inverter. Kasi meron po tayong tinatawag na open circuit voltages na inaano natin. Then also, it has something to do with temperature coefficient, no, of the panel, of the module. So what are the module choices? So ito, ano natin dito, yung mga dapat nasa tier 1, tinatawag na tier 1, no, na mga modules kagaya ng Longi, Jinko, Trina, nandun po sa top 10 siya. Ibig sabihin, they have all the standards and passed, no, in terms of that, no. Maraming siya lang production. What are the inverter choices? Yan din po, no? Yung mga inverter, titingnan nyo rin po yung mga futures nila, no? Kagaya ng mga inverter ngayon, kagaya po ng SMA, Huawei, Pronews, no? Solar Edge, no? Those are the good inverters. Goodwi, okay? Sangro. So yun po yung mga magaganda mga inverter na nasa tier 1 and they have the safety features. Kagaya ngayon dito sa mga inverter ngayon na yung mga surge protection device, no? For the safety. Saka yung nilalagay natin sa combiner box sa DC, saka yung arc plus, you know, or yung arc plus interrupter, no, AFCI, naka-built-in na po siya ngayon. Lalo yung arc plus, very important po yun. Konting ano lang po yun, isunog agad yun. Kaya ngayon, naka-built-in na ngayon, hindi mo na kailangan sa PB combiner. Okay? Meron na siyang mga pictures. Then, you need backup power. So, yun yung sinasabi ko sa inyo kanina. So, you have those things there, no, in terms of that. And no islanding, ito yung sinasabi ko sa inyo. Kasi, just a frequency standard, kapag nagkaroon ng hindi siya nag-sequence, no? When a frequency drips even 0.2 Hz, the utility starts shedding loads. The voltage becomes more variable. So, yan po yung problema, no? Yung out of phase, no? Canceling each other. So, inverters have to be able to follow the utility waveform and shut out under a variety of circumstances. Kaya yun kailangan natin, no? The power back feeding into the grid could create a dangerous condition called islanding. Kaya dapat ang inverter natin merong siyang certificate conformity na merong anti-islanding features. Okay? That is safety. Okay? So, ito po yung sa series natin kanina, when we have a series voltage adds, when we have batteries in series voltage adds. Kapag series string, one current flow, putting module series increases system voltage, no? So, ayan po yung kaninang sinasabi ko nyo kasi meron tayong tinatawag na maximum power point tracking, no? Range of voltage points that the inverter will set, no? Yung maximum power point niya para yung harvest natin maganda. Okay? We maximize that. Hindi lang yung una-una, kagaya ng shading, maalis natin yung pati yung inclination niya. Kagaya rito sa Pilipinas, nag-aano tayo ng mga 8 degrees up to 20 degrees na inclination, ba? Na dapat naka-true south kasi nasa northern hemisphere tayo, kaya dapat naka-true south. So hindi ba nag-aano ang sikat ng araw from the east papunta sa west, kaya dapat nakaharap tayo sa more on the true south in order that you can have maximize, no, the harvest. Nakaano siya. Kapag nasa nasa Australia ka, iba. Southern hemisphere sila, kaya na pag nasa Australia ka, northern part naman sila. Okay? Ang Singapore nasa gitna. Okay? So the open circuit voltage does not exceed the inverter's maximum voltage range. Ayan po importante. Okay? Kasi kapag hindi, mag-iinit. Mamamatay. Buti nga ngayon, yung mga magagaling na inverter, meron silang, na kapag nagkaroon ng problema gano'n, hindi siya pupunta sa system, isa-shut off niya. Okay? And do not shade, no? Kasi sayang po 'yan. Okay? Nakikita na po ngayon to, kagaya nung, 'di ba, kapag kagaya nung this is just like having one Christmas tree light burn out in the string. No current flows. Kaya kapag may shading, doon sa isang string mo, mayroon nakalagay na shade, yung isang panel mo na nakalagay sa naka-series siya, wala, yung buong string wala. Kaya lang yung kaninang diniscuss with the optimizer, yun lang part na yon, kapag meron kang optimizer that's module level, yun lang part na yon na merong ang magkakaroon ng letter performance. The other na walang problema sa shading is 100% performance pa rin. Kaya yung kagandahan po ngayon, no, for the technology. 'Di ba sa Christmas light natin kapag naalis na naka-series kasi yan, naka-burnout is na patay. 'Di ba? Kaya dapat parallel siya. So ito po yung natin series string sizing, no. Kailangan natin inverter peak power tracking voltage. Yan po yung nakita natin MPPT, operating voltage, no? So kagaya po nito, no ba? Yan yung sa mga inverter kagaya nito, I think yung kanina sa Huawei, ito this is SMA, no. Importante po itong peak power tracking voltage. So ito po yung yung sa natin, 'di ba? In terms of the panel, ang importante rito sa panel natin is that ito po yung this is very important in the design, no? Ito yung pirmi kong inaano rito. Unang-una, ito pong part na to. The temperature coefficient of BOC. Yan. Pag sa temperature, ko sa inyo mamaya. Then, let us say here on the on these things here, no, let us say if I use a 435 watts, no, here, then let us say the open circuit voltage, ang importante sa akin dito 48.7. Yan po yung importante pag nag-ano ka sa string, pag the design, okay, para you can use kung ilang minimum panels para tumakbo ng maganda, may startup voltage sa inverter, tas anong maximum na ilalagay mo na panels, okay, anong maximum na panels na pwede mo ilagay, okay, para tumakbo yung system na writing, okay. So those things there are very important, okay. I'll show you later. Okay pa po kayo? Ayos pa kayo dyan? Pinamabilis ko na lang po ng konti, pasensya na po, kasi ito no. So yan po yung isa pong in terms of the ito isang parameters, no. Kita niyo yung open circuit voltage, then the maximum power voltage, no. Importante po yan mamaya na makita natin. So that is the basic rules. Itong basic rules ito, parang rule of the thumb lang. Hindi natin i-consider yung this is not temperature adjusted. Kasi ang solar panel po hindi init ng araw. Ang kailangan natin kasi kapag mainit, 'di ba? It will degrade the performance of the panel. Bababa ang harvest. Ang kailangan natin intensity of light, no, from the sun. Ayun po kailangan. Kaya ito, based on this, kapag meron akong 380 watt panels na may BOC of 40 volts, then inverter ko may maximum na 600, saka start voltage na startup na 150, I can see how many panels. Para rule of the thumb lang. Again, not based on the standard temperature values. Ang standard temperature values natin is 25 degrees centigrade at 1,000, no, 1 kilowatt, no, 1 kilowatts per square meter. Okay? So that will be, let us say, from the maximum panel sa kailangan ko, 600, okay, over 40 volts, open, that is maximum 15 panels on a string. Hindi ka po pwede maglagay na more than that. Ngayon, para naman tumakbo, yung 150 day startup, divide 40, I need 3.75, so I have 4 panels dapat. Hindi po pwedeng tatlo, hindi tatakbo yung inverter mo. So that is just the basic rules, no? Kaya lang hindi temperature adjusted. Mamaya may pakikita ko sa inyo on that. Ito pala, no? So calculating voltage change to temperature hot. So ayan po yung mga natin, the maximum voltage BMP is 40.9. Ito po yung kanina doon sa natin, di ba? Doon sa, I think it is from the Longi. Okay? Kaya ito po yan, no, computation na ang temperature niya na standard is 25 degrees. Let us say, kamukha nung mainit, kagaya sa Nueva Ecija, masyadong mainit doon, may ng 48 degrees centigrade. Sa sa Middle East, mas mataas, di ba? Nandun ako nung sa Oman, nasubukan ko yung 50. Yan, nasa Oman ako dati, no? That is some years back, no? Nasubukan ko yung init. Buti na lang ang humidity mababa. Kaya hindi masyado, di ba? Saka dapat sasakay ka ng kotse, na sasakyan, kulay puti. Kasi pag hindi ka makakaano on that init. So, when you have that, kukumpute mo yung B maximum at 48 degrees, kaya minus niya, di ba? On that. Ito po yung temperature, 0.026 is the temperature coefficient. Okay? Okay? Coefficient of interest, no? At standard temperature condition. So, ano mangyayari? So, if I use a 5 kilowatt, this is from a 5 kilowatt inverter, yung ano niya, inverter's minimum PPT voltage is 90, di-divide mo siya ng minimum module. Ito na nagawin natin, kailangan niya ng 2.62 modules. So, what does it mean? Dapat, at least, meron tayong 3 module para tumakbo yung system natin. Okay? Ngayon, yung cold naman, sa temperature coefficient, diba? It is a negative because the voltage gets higher as the temperature gets lower. Yan po yun. Okay? The open circuit voltage is 48.7, again from the specs yan, no, ng ano natin. Okay? So, at standard 1,001 kilowatt per square meter at 25 degrees standard temperature condition. Naging 8 degrees. Lumamig. Diba? Sa ibang bansa, negative, diba? O lumabig. Let us say, inano ko 8. Kasi again, kaya ako inanong 8 favorite number ko po. So, at 8, ginawa natin mo yan, nakakuha tayo ng 53.56. Kaya, for the longest string ng modules natin, take inverter's maximum voltage divide by the maximum module VOC. Kaya, 600 yung maximum voltage natin na inverter, divide by 53.56, we have 11.2 modules. So, we can start now with 12, 13, 14. Okay? 12 modules on that, ba? So you can choose, no, in series. Now, the final choice depends on things like available space, no? Kung dadagdagan mo yung string mo. Okay? Then ipapara rin mo lang. Okay? So, for manufacturing string sizing, we have website ng mga nagsasupply, no, ng panels. So, basic rules, how to string, ensure that the minimum and maximum voltage are within the inverter range. Okay? So, ito po yung wiring sizing, voltage drop. Bilisan ko na lang to. Palagi ko yung oras natin. Ano na? Nagugutom na palagi rin kayo. Diba? Voltage drop, ampacity. Yan. What we do is choose the larger Y always. No? Ito po yung voltage drop, computation.
Last 5 minutes, sir.
Yan. Ilan
Sir,
na?
here, last 5
Yan.
minutes.
Okay. Sige. Thank
Last
you po.
5 minutes na po.
Sige. Okay. Mabilis na po akong tumakbo eh. Okay. So, you have this, pakita ko na lang sa inyo how to use it. No? Meron tayong from the PEC. Then, ampacity, without significant heating, ito pa yung PEC article 3.102, doon natin makikita. Yan po yan, naman, direct from that. No? Sa PEC 2017 natin. No? Ito yung isa nito, allowable ampacities. So, how we circuit size, no? Must be able to carry 156%. Paano nangyari po yun? Yung continuous duty yung 125, nasa PEC po yan, no? Tapos, 124 irradiance, kaya naging, pag minultiply mo, 1.56. Yan po yung for sizing for the overcurrent devices. So, yan po yung pag merong derate for temperature, meron po siyang mga correction factors. Okay? So, again, when combiner box, when paralleling occurs, plus, minus, di ba? Kapag series, plus, minus. Okay? Reminder, parallel increases current. Okay? So, yan po yung typical module specs. Ito po yung ampacity, how you compute for that, no? So again, because of the time, no, but don't worry, no, you can read this on your free time. I do this, no, to share this on these things, di ba? Para pag gusto mong ano ka na rin dito, you want my PowerPoint presentation, I will share it to you. No problem for that. Okay? So ayan po yung ampacity. Then putting all together, size PV system to serve the load or fit the roof or fit the budget. Yan po yan, di ba? Gusto mo maglagay, marami, wala namang budget, ayun yung problema, no? Then choose PV module inverter. Now find permissible series string, then find the number of parallel strings to get the power you want. Okay? Size the voltage drop from the PV inverter from the inverter to circuit box. Okay? So yan po yung mga module selection, di ba? Yan yung inano kong bibigay ko sa inyo, di ba? Sinama ko po diyan, ito po yung sample design. Makikita nyo rito po yung ano. Ito sa string inverter po, yan yung modules, ilan magagamitin natin na paano makukuha yung ilang rails, no? Meron din pong ano yan, naka Excel form na ipapasok mo na lang pati yung presyo pag mag-aano ka. So those who are in the business on this, pwede ko pong you can send me an email, no? You can see my email afterwards, no? So that I can share to you para madali na, di ba? Site characteristic, no? Nandiyan yan kung ilang modules siya, then the physical layout, no? So makita nyo, no? Ilan yung kailangan mo na mga mounting hardware, no? Okay? So kagaya ito pong inverter, ano po yung MPPT range niya, okay? So these are on the design, no? Na dapat nakaano siya sa okay? So nakita nyo rito, ilang rails? 4. Rail length niya 35 inches. Kaya ko yung inches dito kasi mas po ko sa inches. Ilang footers, no? Yung mga L-foot o depende kung ano yung paglalagyan mo kasi ang L-foot ngayon yung mga standard lang na metal roof. Pag may mga ngayon yung mga Japanese style, yung mga Zeon, kaya ibang klase 'yon, ba? Kaya malaman mo kung ilan ang kailangan mo, ilan din yung kailangan mo end clamps, mid clamps. Tapos yung webs, no? Ito yung grounding. That is the grounding para sa electrical equipment natin, grounding and bonding. Okay? Then you have footer for the then this have disconnect. Then the future of residential solar kay energy storage replace net metering. Yan po 'yon, ma. So na-discuss ko na sa inyo kanina to, okay? Just on that, the reason why we have this battery energy storage system, okay, on the lock carb, no? Ability to time shift. Kaya it peaks in the pag uwian, di ba? Yung load natin nagpi-peak, yung power generation natin baba. Diba? Wala na. Okay? Kaya papasok na rito to. Kaya eto gagamitin natin dito ang battery. Kasi loads peak in the evening after families arrive home from work and school. So when in markets where net metering is not allowed or is heavily penalized, cheap energy storage may provide the alternative. Pwede niyang palitan ang net metering. Kaya watch out, no? For that, no? This is technology. So beyond these high level findings, I found that the economic sources are highly dependent on how utility structure the rates and that this relationship is not always initiative. Sa nga po, sa Australia, ang export mo, blended na sila, diretso. Kung 10 pesos sa import mo, ang babayad din nila sa iyo 10 pesos din. Sana pagdating ng ganon. Then sa India, yung net metering po natin dito sa atin, to apply 100 kilowatt peak and below. Sa India po ngayon, 500 kilowatt, pwede ka mag-apply ng net metering. Kaya, let us say, mga commercial, that is now having that. No? Given the important role that trade stock will play in the shaping the pure distributed energy, more research needed for regulators, utilities, academics, and renewable energy provide to ensure that distributed storage realizes its full potential to enable clean and reliable electricity system. Secured, no? Kaya nga sa ibang bansa, meron tinatawag na net metering, storage, energy storage net metering. Nangyayari na po yan sa California, no? Sa USA. Behind the meter, solar plus storage, they discharge their battery, exporting, stored back to the grid and receive an net energy credit. Kaya yung utang nila, niloloan nila, actually, yung pinambabayad nila from here, yung ine-export nila. Kaya ang ganda. So NEM paired story is simple once you understand what's happening, and there's no better way to understand it than walking through some real world example. Kaya nga po sana natin sa Pilipinas yung kasi nandoon po pamilya ko sa California. I'm very happy for that, no? Na nangyayari doon. Sabi ko nga sa Pilipinas, sana all. Sana raw po, sana all, no? So yan po yung natin, no, yung in terms of that, no? Okay? Following the light of the sun, we left the old world, sabi nga ni Christopher Columbus. So, congratulations and more power, IAE Eastern Central Visayas Regional Conference. And I salute you, no? Congratulations, IAE Cebu Chapter.
Thank you, Engineer Hill. Ang ganda pa sanang makinig sa iyo. Ang dami naming natutunan. Actually, compared yung price ng Cebu sa utility at saka price ng Meralco, mas mura kayo dyan. So, this is a very good opportunity, no? Ng taga Cebu, taga Central Visayas, at saka taga Eastern Visayas na magsusolar na tayo.
Yeah.
Para
yung ano ko yung nakita nyo sa akin, yung ano ko, shoutout ko, switch to solar energy. At sa Cebu,
Okay.
guys, Beko yata, 12 pesos mahigit no? Ayun ang ano ko.
Tama.
There are areas
Sige.
na mga may 18 pesos, right?
Tama, Engineer. Tapos siguro mag-post ka rin ng mga future seminars mo, Engineer, para ma-share ng mga membership dito sa Cebu. But kulang talaga tayo sa oras ngayon. So, i-award ko na itong certificate of appreciation mo ngayon.
Yeah.
Sige, salamat, Engineer Hill. So, let me read the certificate. IIA Cebu Chapter awards the certificate of appreciation to Engineer Virgilio S. Lusares as Technical Resource Speaker on the topic Designing Solar Plus Storage System for Residential Energy Solutions in the 20th Eastern and Central Visayas Virtual Regional Conference. Given this 18th day of September 2021, signed by our President, Cebu Chapter, Mario Tabanyag, signed by Regional Governor, Engineer Felipe Niliama, signed by BP Technicals, Engineer Brian Pasilan, signed by Technical Consultant and Advisor, Engineer Brian Pasilan, and signed by the BP Technical Affairs, Roel Ratilia. So ladies and gentlemen, let's award the certificate of appreciation to Engineer Virgilio S. Lusares. Maraming salamat po, sir. A warm of applause.
Salamat
Okay,
po,
so
salamat.
we will proceed. Yeah, you're welcome. You're welcome, sir.
Salamat.
We'll proceed to the next speaker.
By the way po, yung mga may question, mag-send na kayo sa email o kaya dyan sa chat box po natin. Mamaya po, aansweran ko po.
Okay, so while nagla-lunch kayo dyan sa bahay, so we will have a presenter, a gold sponsor. By the way, kanina while nawala yung mga chapter presidents, merong chapter presidents meeting na ginagawa ng governor kanina, kaya medyo nawala yung mga chapter president nyo. So, I hope the gold sponsor, Nodal, is ready. So, ladies and gentlemen, please help me welcome Nodal Electric Trade and Services to do their presentation. So, Nodal Electric. So there will be a video presentation, and then after the video presentation, there will be a presenter. So sit back and relax, and let's try to watch the video presentation of Nodal Electric.
Dedicated to establish a lifetime partnership with its valued clients. Nodal Electric Trade and Services is dedicated to establish a lifetime partnership with its valued clients by providing cost-effective and quality products and services. Our vision is to become one of the leading electrical trading and services company in the region that will help promote products and innovations that the industry needs. We also envisioned not just to thrive, but to expand as well to help create more jobs in the country. Founded in 2014, the company opened its first branch in Nueva Cebu. And later expanded in the year 2015 when it opened its second branch in Tagbilaran City, Bohol. Services has an extensive product and services portfolio, thus providing you solutions becomes easier and faster. To ensure our clients with the quality of our products, we partnered only with the best and top brands in the electrical and lighting industry, such as and with our great intent to help raising our current measures in fighting this worldwide health crisis, we made sure to add solutions into our portfolio, premiering with the UVC light disinfection technology from our partner Signify, previously known as Philips. We also offer design and estimates on top of other services to give you total solutions, helping you save your time and your money. a tough year. The world may have slowed its pace, but this doesn't stop our energy from striving in providing solutions, in giving light. We firmly stand that Nodal Electric Trade and Services is your road to a brighter side.
So that was the video presentation of Nodal Electric regarding their products, their offices, and their branches. Okay, so ready na si Alison for your technical presentation. Alison from Nodal.
Yes, good afternoon, sir. Good afternoon, everyone.
Sige, yung partner nyo, Nodal, Signify, no?
Yes, sir. Yes.
Okay, good.
Yes. Good afternoon,
Sige,
everyone.
good afternoon.
Hi, good afternoon, sir. Before I start, I'll give the floor to Ma'am Geraldine, ma'am, so she can introduce herself, sir. Yes.
Okay, okay. Sige.
Hello. Good afternoon sa tanan. May udto sa tanan. Nahuman na ba tagkaot? So, thank you so much IIE Cebu chapter for inviting us in this event. Actually, it is our 4th time, and IIE Cebu chapter is means so much a lot for us because for this attending exhibit, napo kayo should help for us Nodal Electric nga ni-grow. So as we have already shown in our company video presentation, we are proud to be the first value-added partner of Signify Philippines in Vismin. We are certified sister integrator of Signify. In this year's IIEE Nodal Electric is proud to partner with Signify as their partner. They will give more information for presentation of solar, street lighting, and UVC disinfection for 14. I am glad to introduce to you Signify, our Signify partner, Mr. Allison, field service manager of Signify, Mr. Allison Relion. So daghan kayong salamat sa inyong tanan sa pag-support, and thankful kayo ming part ni diri bisan for the pandemic, but we are here nga ni support gihapon ta sa IIEE activities. Mayong udto o keep safe and God bless us all.
Thank you, Ma'am Geraldine. Good afternoon, everyone. Sir, I'm Alison De Leon po, by the way. I'll introduce myself. I'm the Field Service Manager for Signify Philippines. So, Signify Philippines po, kami po yung Philips Lighting. So, we are the Philips Lighting Group. So, currently in 2018, our company from Philips, nag-change po kami ng corporate name into Signify, but all the products po is still branded Philips. So yun po, we're very happy that one of our partners in this mean, which is Ma'am Geraldine from Nodal Electric. So we have partnered with them because of their technical expertise as well. So in this I think I have 40 minutes for presentation. As much as possible, I would try to give the basics po talaga of dalawa po yung presentation. One would be the UVC and the second one would be yung solar street lighting solutions ni Signify. Okay, I would start po my presentation. I'm coming from Manila po. I'm in Quezon City now, pero naka-lockdown po kami, pero at least okay naman po kami dito sa Manila. Yes. I'll share my screen now po. Wait, here. Share. Ma'am, can everyone see my screen?
Yes, Alison.
Yes.
Yes. Good afternoon, everyone. Okay. Sir, this one, I'll try to have my presentation. Ita-timer ko po siya para at least yung atid with time. So, first one, we would like to discuss the UVC disinfection applications po. Okay. Okay, a little background of our company. Philips Lighting is now called Signify po, world leader in lighting systems. So currently po, what we have, okay, for common disinfections, there are two types po kasi. There's surface disinfection and air disinfection. Usually po kasi, meron po kasi sa surface, when we go to surface, meron po kasi siyang mga pros and cons eh. So like, yung sa surface disinfection, there are two types. So ano po siya, chemical sprays at saka yung wipes. I'll try to open this one, the pointer. Yan, this one. And the other one po kasi, meron po yung iba, naglalagay po sila nung parang mga chemicals, nagsispray sila. Ang problem po nun kasi, sa health hazard po kasi siya, kasi malalangha po natin yung mga odors nito. The other one, yung naman po, meron rin naman, on the other side, meron din po sa air disinfection, we have yung ito on this side naman po. So it's cheaper, but ang cons niya, mga HVAC systems, ganyan. So these are the two common disinfection methods, surface disinfection and air disinfection. Now, saan po ngayon pumapasok yung UVC light? So technically po, yung UVC light, that's why new air and surface disinfection, di ba meron po yung isa yung chemical. The other type po, using light na, yung mga lamp, UVC lamps. Now, UVC light has the power to disinfect. So ito po yan. So currently, our company Philips, actually, yung technology po talaga ng UVC, matagal na po siya. So 35 years na po siya in the market already. So we were the one who pioneered this one po kasi. So ginagamit na po siya. So ngayon, this presentation, I would explain po further paano po natin siya ginagawa, yung solution process. But before the solution process, we will go back to the basics po ngayon. Now, why UVC light to support effective disinfection? So number one, proven po siya successfully used for air, surface, and water disinfection. So number two, wala po siyang known pathogen na resistant. So mostly, halos lahat po ng bacteria, virus, and even po yung COVID, kaya pong in-neutralize ng UVC. So fast po siya, mabilis in a sense na yung ilaw, pag inon mo po siya na walang tao, automatically in a few minutes, kaya na po niyang i-disinfect yung room. Okay? And versatile, pwede kahit ilang beses niyo po siyang gamitin, madali po siya, very versatile po siya. Madali niyo po siyang ma-on and off magamit yung mga equipment. Now, a little basics of the UV light. So technically po kasi, there are 3 types of UV. So UVA, UVB, and UVC. So what is UVA? So yung UVA po kasi, it's coming from 315 to 400 nanometers. So usually, saan po natin siya ginagamit? Ginagamit natin siya when using curing, sun tanning, or yung mga insect traps. Di ba yung sa mga ano po, sa mga restaurants, di ba meron po kayo nakita yung mga insect traps pag yung mga fly na mamatay, that's UVA. UVB, ano naman po siya, that's from the range of 280 to 315 nanometers. Ginagamit po siya sa medical use. For example, yung mga phototherapy sessions, kunyari may mga patients po na merong psoriasis, for example. Yung light po na tinitreat doon, that is using UVB na lamp. Now, UVC, the third one, is coming from the 200 to 280 nanometers. They are used for disinfection purposes and germicidal applications. Okay, this is UV light po siya. Yan. So it's divided into 3. UVA, UVB, and UVC. Now, some important facts po, no? So no pathogen cannot escape UVC disinfection. This is scientifically proven na po siya. Viruses, bacteria, and fungi. So you can visit our site, makikita niyo po doon, you can download all the viruses, bacteria, and fungi that UVC can kill and disinfect. So it's been there for 40 years. So pero hindi po siya ginagamit UVC disinfection devices are not for medical applications. Okay? Now, this is the chart po kung saan po siya. I'll explain po in detail on the next few slides. So these are a table of what the viruses, bacteria that na kaya pong i-disinfect ng UVC. Now, the latest one, okay, we have partnered with Boston University in Massachusetts. So ang ginawa po doon, ginamit po namin yung UVC light and based on that po, na-validate po na kumbaga meron po kasing tinatawag na term yung inactivate. When we say inactivate po, once na tinamaan ng ilaw yung mga viruses na yan, sir, inactivate. That is the medical term. Ang nangyayari po, hindi na po siya hindi na po siya potent. Parang technically dead na po siya. Parang ganoon. In medical terms, that is what we call inactivate. So in yung a dose of 22 millijoules will result in 99.999% deads na po yung COVID. So technically, sir, UVC can also kill the viruses of COVID-19. On this one. Now, ano po ang kagandahan ng UVC lamp? Number one, hindi po siya nag-emit ng ozone, ng toxic ozone gas. Kasi napansin niyo po yung kaninang video, di ba yung picture, di ba pag nag-spray po ng mga chemical or something, mga ganon, nag-emit po yun ng ozone. So on our part, yung mga lamps po natin, ozone, wala po siyang ini-emit na ozone. Kaya po siya, environment friendly po siya. Okay? But take note, ang sinasabi po namin when using UVC po talaga as much as possible, dapat wala pong tao sa loob. Kasi meron pong harmful reaction ang UVC light sa body and sa light. Number one, kung sa body po siya, pwede pong masunog masunog yung skin. Number two, pwede pong ma-damage yung retina ng eye pag tinamaan. Kaya when doing UVC, we're very strict po talaga that dapat po wala pong tao sa loob ng room or animals or anything, any living creature should not have, there should be no one inside the room when using disinfection of UVC. Now, these are the types of virus transmission. So they can be direct airborne, transmission between people, indirect airborne, transmission through airflow, and the third one, indirect surface-borne, contaminated po. So when we say, ito po yung madalas ngayon, yung kunyari, meron pong infected, may nahawakan niya yung mga gamit, so ito po yun yung indirect surface disinfection. So paano po natin siya ngayon tinitreat? So ginagawa. So there are 2 types of air disinfection. That would be open air disinfection. Kunyari yung sa room, maglalagay ka ng trolley for example, i-disinfect yung room. Number 2, meron po tayong tinatawag na upper air disinfection. So we're using po yung yung hangin para ma-disinfect po ngayon yung hangin within the room and area. So on this one, I would explain po this. So this is an example po nung this one, sir. Open air disinfection. So this is the working hours. Pag wala na pong tao, ang gagawin po, maglalagay po tayo ng trolley sa loob. So once na inon natin yung trolley yan for a certain period of minutes, for example, 20 minutes. After 20 minutes, disinfected na po lahat ng tatamaan ng ilaw. Except doon po sa mga hindi natatamaan ng ilaw. For example, yung mga ilalim na surfaces na hindi po natatamaan ng ilaw, yun lang po yung hindi madidisinfect. Pero everything na matamaan po ng ilaw, disinfected po siya. Okay? So what are the UVC solutions that we offer? Now, the UVC, we have 3 types po, disinfection applications: room and surface, air, and object. So meron po tayong home, which is consumer. Ito po yun. Okay? This one po, meron po tayong mga small disinfection lamp, and then meron rin po tayo yung portable na mga air disinfection. The latest one that we have, ito pong color gray na to, sir, meron rin po siyang HEPA filter. Ito, this one, this is the latest release. The second one, in offices po, meron po tayong mga UVC buttons. Ito po yung tinatawag nating mga trolleys na pwede po natin ilagay sa room. Once nag-operate, i-disinfect niya po naman yung buong room. Another one would be on the air. We have the upper air disinfection. These 2 types, yan po. And then the third one, the object, yung mga UVC chambers. Yung UVC chambers, para po siyang, para po siyang microwave. Ilalagay mo yung kunyari, wallet, cellphone, laptop, salamin, mga ganyan. Pag nilagay niyo po siya doon, tapos parang lang po, press nyo lang kung ilang minutes siya, then automatic po yun, i-disinfect niya po yung mga gamit na yun. Later, I will give examples of this one. So those are the 3: room or surface disinfection, air disinfection, and the third one would be object disinfection. Now, why choose us? Kasi number 1, design po talaga for efficacy. Number 2, a lifetime of reliability, kasi po talagang meron po kaming service contract with them, and then service and support, and the fourth one would be here. Okay, now a little overview na po tayo. Papakita ko po yung mga example. So this is the example of a UVC desk lamp. No? Ito po siya in 2 colors. So for example, ito po yung ginagamit natin siya. So how is it? For example, in a living room, when you place it in the middle of the living room, within 45 minutes po, kaya niyo na pong i-disinfect yan. Living room, 28 meters squared within a 3 meter range. Then yung bedroom naman, mga 30 minutes po siya, and yung mga washroom, mga po siya, I think this would be mga 15 or 20 minutes siya. Yan, dito. That is for the bathroom. So paano po yung explanation niya? Yan, this is an example po. Yan, middle, tapos yan, kunyari po, pag wala, then ito po, pag naggawa na po siya, pag kunyari nag-operate na siya na walang tao, mag-on na po siya. Okay. Ano po yung safety safety feature nito? Meron po siyang sensor sa loob. So once na may detect po siya na moving on, kunyari may pumasok po biglaan, automatic mag-shutdown po yung unit kasi yun po yung protection circuit niya. Kasi po dahil UVC is very harmful to the skin and to the eyes. This is also an example. For example, nilagay po siya sa bathroom. Ganito na po siya. This is an example, actual example. Now we go to the second one, which is the surface disinfection, surface applications po. So meron po tayong tinatawag na movable robots, meron din po tayo yung mga buttons, and meron din po tayo yung mga cabinets. Now, mag-concentrate po tayo ngayon dito sa surface disinfection, yung UVC trolley natin. So in our portfolio po kasi meron po siya a single arm and dual arm. Yung arm na po yan, pwede niyo po siyang what you call this, yung degree angle po pwede niyo mabago from 90 to 180 degrees, pwede po siya. Pwede niyo po siyang baguhin yung rotation niya. So I'll give you an example po. Ayan. This is an example po, no. This is ito yung single, this is a single trolley and this is a double trolley. So pwede po 'yan. Actually, marami na pong gumagamit niyan dito sa Philippines and globally, marami na po. Philippines, marami na rin po siyang gumagamit. These are the classic examples, okay? So, pwede ano po yung application niya? Pwede po siya sa office, school, building, banking, hospitality, food outlet, hair and beauty salon, bus and train stations. Yan. Pwede po siya. Now, this is an example of a single trolley and a double trolley. So, may makikita po kayo dito sa gitna, yung puti na to. Yan po yung ano siya, PIR sensor. So, pag meron po siyang motion, automatic isa-stop niya po yung operation. Okay? So, this is an example of this one, and meron rin po siyang remote control para makontrol niyo po yung unit. If you want it, kunyari, nilock niyo na po siya, sinara niyo na yung door. Kung gusto niyo po siyang i-operate, pwede niyo rin po siyang i-operate dito sa panel mismo, or you could use the remote control as well for operation. Then, okay. So ngayon, paano po natin malalaman yung coverage area? For example, I'll give an example po. No? Ito, a single trolley. For example, calculations. Yan. For disinfection, ito po, coverage area, for example, 24 meters squared. So, disinfection time niya, 15 minutes po siya. Pag mas malaki po yung area, mas tumatagal po yung minutes ng disinfection time niya. It's the same with the control. So, ito po yung parang ano niya. So, this is your square area, and then this is your coverage area po, yung circle. So, automatic within this one po, ito po yung kaya niyang i-disinfect on this one. And then, this is a specification. Hindi ko na po masyadong ipapaano po. Don't worry po, we will share the presentation later sa lahat po ng participants. Okay? So, okay, now, ano po yung certification? Technically po, IEC standards po yung ginagamit natin. So, these are all the certifications that we have. For safety, we have 4 certifications for EMC. Meron po tayong 4 din. And then, for disinfection performance, ito po, meron pa rin po tayong ginagawa in this one, sir. So, nagkama pa rin po yung IEC has no standard for disinfection yet. So, we're working with IEC on this one to do the certification as well on this. Hopefully, sir, very soon. Now, the third one would be object disinfection. Ayan po, mapapansin nyo, para po siyang microwave, no? So I'll give you an example po. So meron pong maliit, mini, then small, and then the medium. I'll give you an example po siya. No? Parang ganito po yung picture niya. So pag inopen niyo po siya, may mga trays po yan sa loob. Dito niyo po ilalagay sa mga trays yung mga gamit. This is a classic example po. Papakita ko sa inyo. Ayan. Ito po yung mga tray. Ito yung loob niya. And then, paano po natin siya ginagamit? Okay. Napansin niyo po, this is the medium and this is the large size. Meron na po tayong lumabas na large size ngayon. Paano po siya ginagawa? Okay. Mapapansin niyo po, no? This is the one. I'll give the play po. Kung saan mag-play po itong video. Anyway, ang ginawa po dito, sir, no? Nilagay po sa tray yan. Cellphone, gadgets, laptop, and everything. So, nung nilagay po siya sa loob, ito po yung ginamit niya. So, dinisinfect po siya ng after 15 minutes. After 15 minutes, actually, ginawa nga po sa example na to, 10 minutes lang eh. After po nun, sir, disinfected na po yung area. Ay yung lahat ng nilagay doon sa loob. Ayan. So ano po yung safety feature niya? Once na-open po yung door, automatic, off po agad yung unit. It's the same as kasi that is what we, always incorporate in our systems, in our, yung safety features. Lalo na po pag UVC. Ayan Ayan, papakita ko po. Ayan. This is an example. Release po. Ayan. So nilagay pati mga credit card, lahat yan pwede po siya. Yan, pati po yung laptop yan. Sir, ang ginawa po, inopen po yung laptop para yung loob rin yan. Yan. Yan, pati po yung yung sa iPhone yung mga yan. Ayan, then si-set lang po yung timer. And then on. That's it. Ayan po siya. Ayan. See? So that is, ayan po, so that is an example of, yung cabinet disinfection. Okay? So, we also have a new ones, lalo na po pag kunyari yung sa mga buildings na po na malalaki or public areas. Then po, dito po ngayon dumadaan yung mga gamit. So, na-disinfect po siya. We have this as well. Ang tawag po natin is luggage UVC panel. So, if you have any questions po, just contact our partner, si Ma'am Geraldine on this one. Okay, example po yan. Kunyari sa mga back of the house, ayan po, doon po pinapasok yung mga bag, lahat yan. Dinidisinfect po, papasok doon, tapos po, ano po, lalabas po siya dito sa dulo. Yan. Something like that. So, ito po yung ano, object disinfection. And then the third one, I think the third one is ito po, yung air disinfection. Now, the air disinfection, meron po siyang two types, wall-mounted at saka yung ceiling-mounted. So, ano po yung picture niya? So, parang ganyan, mapapansin niyo po, nasa taas po siya. The reason why nasa taas po siya, above eye level, para safe po yung ano, yung, ang ginagawa po niyan, hihigupin po niyan yung hangin, then ilalabas niya rin po. Paglabas po ng hangin dito, automatic, ano na po siya, disinfected na siya. This one. Okay, this is an example of a wall mount. Yan. Ito po yung ano, eye contact. So mapapansin nyo, meron po siyang clearance talaga para lahat po ng hangin nasa taas, yun po yung i-disinfect niya. So yan. This is an example. Now, this is a picture of wall-mounted, and also this is another. Ito naman po yung example nung ano po, ceiling-mounted naman. Nandun siya sa mga taas. Okay. Now, this is an example po no that we did abroad. So ito po siya sa mga offices, yan. Ito po, ayan oh, yan sa mga ano po, sa mga rooms, yan, using pantry, nakalagay po siya doon. So mapapansin niyo po sir, ito po yung mga aircon, 'di ba? So this one, ano po, meron po yung specific design which is our partner, sina Ma'am Geraldine, Nodal Electric. They know how to do this ano po calculation. So please really ask them if you want this po. We will gladly help you on this one. The design and everything. We will ano po, ibibigay po namin sa inyo. Example, latest po na ginawa namin sa buong Hong Kong, ito na po yung mandatory sa kanila. So Hong Kong used this one po. Ganito po. Miski sa public spaces nila, meron po lahat na nakaganyan. Okay, this is for upper air disinfection. Okay, the other one, meron po kaming tinatawag na air disinfection bin, yung portable. Ito na po yung pwede sa offices din, sa mga bahay. Yung parang ano po siya, parang what do you call this? Yung parang aircon, something na electric fan, something like that. Ito po siya, parang ganito siya. Yes, we have. The latest one, yung meron po kami yung gray, meron po, ito po, yung meron po siya, pakita ko po sa inyo, no? So yan, the same, this is the coverage area, and the same time, ito po, yan, pwede niyo po siyang gamitin yan sa office, disinfection, and then the latest one po kasi, ito, this one, meron na po yung latest na nilabas namin, meron na rin po siyang included ng HEPA filter as well. Yan. Okay? We'll discuss this everyone. And then now, if you could see here po, this is the latest one that we have. Meron po siyang kasamang HEPA filter as well. Yes. This is for air disinfection. Okay. Upper air, cooling, ano po, yung cooling coil, okay. What if pag ano po, kasi marami po nagtanong sa amin Alison, can UVC also be put in centralized air conditioning? Pwede po. So this one, it is used po in our cooling coiling cleaning, yan, cooling coil. And then sa air handling unit po, pwede po siya natin siyang ilagay. So the design, kami rin po ang gumagawa through our partner Nodal Electric on this one. Pwede rin po siya. So technically in the Philippines, naka-NDA lang po kami, pero yes, one of the biggest company in Metro Manila. So yung lahat po ng facilities nila, all their air handling units po, nilagyan po namin nila ng ganito. So I would on this part, I would explain it here. Ayan po. This is the system. So doon sa between ng cooling coil po and heating coil or cooling coil, doon po nilalagay si UVC. Ito po. So once na pumasok po lahat yung air na yan, papasok po lahat and everything. So once na, pag lumabas na po yan, papunta na po sa mga rooms, technically yung mga hangin po na lumalabas doon, disinfected na po siya. Yeah. So this is an example of the HVAC system. So we have implemented it po globally. Philippines, we have it already po. So if you have any questions po, please go to our partner, ask for their support, and we will really help you on this one. This is for HVAC systems as well. Okay, and then lastly, okay, ito po yung sinasabi namin, in using UVC, there should always be a safety side on it. So kaya ano po talaga kami in using this UVC disinfection, definitely po talagang tinitrain po namin yung mga gagamit, yung mga clients on the safety of this one. So we have our safety protocols as well. Yan. We have instructional safeguards. Yan po, proper warning symbols. Meron din po siyang time safeguards, yung mga delay timers. We also have equipment safeguards. Ito po yung mga door enclosure sa mga chambers, and the last one or yung containment safeguard, yung mga UVC access, yun po, meron din kami. Okay? So I think that is for our UVC. If there's any question, after po yung after second presentation ko po, if there are any questions po, i-hold ko po muna on this. Okay, i-hold ko po muna. And then after po nung second presentation ko, we will have, I think, a 5-minute Q&A. Lahat po ng questions nyo, please write it down. And then isa-isahin po namin sagutin after our second presentation. Okay, this is for the UVC. And then the second one, would be here, the solar. Okay. Also, because we are the world leader in lighting po, so we have solar street lighting as well. Okay. Nakita niyo po yung pinakita ni ng video ni Ma'am Geraldine, yung Bohol. So that is that is using the street lights of Philips. Okay. We also have a project po. Actually, we have projects already that we've done. Technically IoT na po yung street light. So that is what we did with Puerto Princesa and Cananga. So lahat po ng street lights na yun, sir, namo-monitor na po siya sa cellphone, namo-monitor na po ng city sa laptop. So kahit nasaan po sila, they can monitor and control their lighting anywhere. So that is also our street lights. Yun po yung yung connected lighting namin. My presentation now will now focus on solar street lighting po as well. So this is one of the portfolio now. So my agenda po, there are 4 agendas. So yung building blocks ng solar lighting system. Number 2, types of architecture. Number 3, solar portfolio. And number 4, battery autonomy and charging duration quick calculation. Okay. What are the building blocks of the solar lighting system? Now, ito po yan. At least yung si Sir Lisanis po kanina, he explained it. So hindi ko na po masyadong explain kasi in the previous presentation, na-explain na po ito very clearly. Sir, thank you po talaga. I learned a lot. We learned a lot from that one as well. Now, ano po yung building blocks ng solar street lights? So it's the same. We have the luminaire, we have the pole, we have the panel. Okay, we also have the battery, and we also have the charge controller. So now, what are the types of solar lighting system architecture? So sa atin po, there are 3 types, non-integrated, semi-integrated, and all-in-one. So for the non-integrated, when we say non-integrated, ano po siya? Hiwa-hiwalay po lahat siya. Ayan, no? So from the battery, charge controller, PV module, hanggang yung ilaw po, yung light mismo, yung module, we call it luminaire, the street light luminaire. Ano po siya? Ito po yan, non-integrated siya. So pwede po yung battery nasa pole, or pwede rin po yung battery nasa ilalim ng lupa. So yan, then the controllers, the charge controller are here, and then ito po yung PV modules. Yung mga ilaw po nandito. I'll give you an example on this one. Ayan po. This is a semi-integrated na po siya. So ito po yung PV module mo, this is your charge controller, battery, and then ito po yung solar street light. Now, mapapansin niyo po, very rigid po yung unit kasi meron po siyang tinatawag na ganito. Ito po. So yung IP66 rating po kasi. So yan, kaya po siya, fully secured po siya. Okay? This is an example po of semi-integrated. Now, ano po yung ibig sabihin ng all-in-one? So yung all-in-one, ito po yung example, sir. Your PV module, battery, charge controller, and ito po yung mismong yung street light mismo, yan sa ilalim. Okay? That is all-in-one. So yan po yung tatlong types, non-integrated, semi-integrated, and all-in-one. Now, So ito po yung lumen versus wattage. So ang well, in lighting terms po kasi 'di ba? Ang sinusukat po talaga natin sa lightings is yung lumen, which is the brightness. Not the power. Kasi po yan po yung natutunan ko when I joined Signify. Ngayon po ang inaano po talaga natin, so when we measure light, it's always measured in lumens. Now, this is an example po of a data sheet of a solar street light. Okay? Now, mapapansin niyo po dito, we have the system. Ito po yan. So, 10 watts, 20 watts, 30 watts, and 48 watts. Then we also have the lumen output niya, lumen package, and then the solar panel. Ito po yung capacity niya. And then, usually po kasi sa mga solar products, dapat po very familiar po dapat tayo. Ito po yung kailangan natin pag-aralan, yung runtime niya. Okay. The reason why yung runtime po kasi sometimes po kasi may nagsasabi, for example, may solar street light ako 10,000 lumen. Ganyan. Kaya niya in one day. So technically po, that is not true. Kung patatakbuhin niya ng 100% yung 10,000 lumen in one day, I think po hindi po siya aabot ng 24 hours. Why? Because po nung battery size niya. Kung AC powered po yan, walang problema. Pero pag battery, so ano po siya, dependent tayo sa battery. It's like the UPS system as well. So ito po yung mga runtime. So be very specific during runtime hours na. Later po, I will give you an example on the runtime as well. Now, mapapansin nyo, ano po rin siya, meron rin po tayong IP rating, then yung class rating. Okay. Yung class rating po kasi, there are 3 types of class rating. Class 1, Class 2, and Class 3. When we say Class 1, yung unit po, the luminaire itself, needs to be grounded. So, dapat grounded po siya. Meron siyang grounding system na kasama. Kailangan nyo pong i-grounding unit. When we say Class 2, yung unit po, kahit hindi nyo na po siya lagyan ng grounding, okay na po siya, tatakbo na po siya. What is Class 3? Yung Class 3 po, hybrid po siya. Pwede nyo pong lagyan ng grounding or pwede nyo rin po siyang hindi lagyan ng grounding. Those are the 3 classes of grounding po. Class 1 needs ground. Class 2 will run even without ground. Class 3, hybrid. With or without, tatakbo po yung unit. Okay? Because in power po kasi, in electrical systems, grounding is very important. Now, this is the package po. This is an example. Hindi ko na po, okay, sa application po, saan po natin siya pwedeng gamitin? Parking, car sharing area, camping parks, yan. Small roads, yan po. Offices, and then city highways po, like what our partner did, Nodal Electric did, yun po sa Bohol. So that's an example po of main city roads po siya, yes. We have it. And also in accessories. Okay, AIO. So, okay, AIO stands for all-in-one portfolio. So, ito po, pakita ko lang po yung example. So, we have 2 types, yung Sunstay all-in-one. So, we have 2,000, 3,000, and 4,000 lumens po siya. So, now, hindi na po ako we have also the battery capacity, battery type, yan po. And then, this one, the runtime, mapapansin niyo po, no? So, pag wala pong PIR sensor, ito po kasi yung PIR sensor niyan eh. So if without PIR from dusk, so once na nag-light na po siya sa gabi, sa hapon or sa gabi, automatic po yung 5 hours po, fixed po siya. Pero after 5 hours, magbabari na po siya kada succeeding hours na. Yan, para po. Tapos yung autonomy, this is very important. Ito po kasi yung parang run length time niya eh. So later po, there is a slide explaining the autonomy po. I will explain. Now, what is the advantage of having a PIR? Mapapansin niyo po, yung PIR, 5 hours pa rin, pero normally, 30% lang po siya. So, 30%. Once movement, saka po siya mag-100%. Okay. Ano po yung technology na ginagamit? Hindi po siya, sir, yung biglaang mag-on 100%. No. There is what, in lighting terms po kasi, meron po kaming tinatawag na ramp up and ramp down. So when you say ramp up, dahan-dahan po siyang from 0, tataas po siya hanggang 100%. The reason why po siya na ramp up yung dahan-dahan, para hindi po bigla yung power, yung sa usage po ng power niya. So yan po yung mga systems na ginagamit natin. So naka-ramp up and naka-ramp down yung mga PIR sensors na units natin. Ito. So ngayon, mapapansin niyo po, once na meron, then after po yan, the next 5 hours po, fix po siya na certain percentage, then ganito po siya. Then normally hanggang mag-next day na po siya. Yan, okay? So the warranty for this one is 3 years po siya. Yan. Okay? Now, another one would be here. Ito po, another example. For the wattage greater than 4,500, so 5,000, 8,000, and 12,000 lumen, we have the SmartNet. Ito naman po yung pangalawa, yung Smart Bright, all-in-one din po siya. It's the same. Mapapansin niyo po, yung ano po niya, yung autonomy niya po, mas matagal po ngayon. Halos pareho rin po nung isa. This one is much longer po siya. Okay? So normally 20% po yung ano niya, yung bright ano niya, normally 20%. Yan. Usually the first 2 hours normal, yan 30. Then once detected, 100% po siya. It's the same, almost the same. And then wireless charging, 2 years warranty po siya. Now, ito po yung comparison sheet. I'll not dwell down on it po. Iano na lang po natin. Now, ano po yung isa pang product namin? So we also have what we call the Urban Spark. So, yung poste po at saka yung mismong luminaire na solar. Pero nasaan po yung PV module niya? Ito po yung PV module niya, makakansin nyo. Hexagonal. Okay? This one, sir, we also have it. This is our latest offering on this one. So, it's also 3 years. So, ano po yung example? Later po, I would explain kung ano po itong hexagonal na PV module na yan. Yeah, we have it as well. So, the solar array po, meron po kaming street lights and floodlights and wall lights. So, when we say street lights, ito po yung standard street light natin. Floodlights, you also have it. And the third one, ito po yung wall lights. Ito po, for example, sir, di ba meron po kayo nakitang mga solar na sa mga garden, for example, sa mga wall or sa labas ng gate, ganyan. Ito po yung ginagamit na yan. This one. Okay, this is the latest one that we have po, yung wall lights now. An example of this one, so yung remote niya po is through Wi-Fi. Yan po, ito po siya. Then inbuilt lithium battery po siya sa loob. So this is the mounting. This is an example of the Essential Smart Bright. And then this is a technical data sheet. I'll not run that down to. Okay, now, this is very important po, yung irradiance. So mapapansin niyo po kasi environmental factors. So ito po yung table ng irradiance niya. So, okay, so at 90 degrees angle to the sun, 100%. Habang nagdi-decrease po yung, nagtitilt po yung ano niya, yung degree angle niya, bumababa na bumababa. Yung output niya po is bumababa na bumababa. Okay? This is the this is the table. Now, this is an example, another example of the Essential Smart Bright. Okay. Example of our solar floodlight. Mapapansin niyo po, PV module, tapos po yung ano niya, yung charge controller niya po and everything, nandito na po sa loob yun, dito sir, sa loob ng street light. Yan. Okay? So parang tawag po namin dito is almost semi. Opo, semi configuration. Okay? So ito po siya. Okay? Now, infrared sensor, data sheet. Yan. I'll not dwell it down po kasi because of the time, I think sir, I have 4 minutes left for the presentation. Okay, non-integrated portfolio. So yung non-integrated, ito na po yung street lights. Okay? Yung nakita nyo po sa video ni na Ma'am Geraldine, ito po yun, yung mga parang ganito po yun. Yes, yung mga BRP. Yes, on this one. Okay? Pero this one that we are seeing, meron po kasi tayong version na AC, which is yun po yung sa video, meron din tayo po yung para sa solar version. Yeah, it's a different. Okay? Hybrid. Yan. Example, po, this one. And then, we also have po yung maximum power point. Ito po yung mga charge controllers. We also have it as well. So, meron po sa portfolio. This is an example po that we did in I think this is in Europe, this one. An example of the solar solution. And then the intelligent hybrid CCT, meron din po kami. And then also the solar module po. We have it as well. Yeah. Okay. And then okay, ito po yung sinasabi namin kanina, the latest one that we have, ito po yung solar panel module, yung hexagonal po siya. Ayan. Ito po yung nakakabit ngayon. 'Di ba yung sa iba pong solar yung parang flat siya na nakataas. Ito po nakakabit po siya doon. Yung poste po, nasa gitna nito, ito po yung poste, then ito po yun. So, ang maganda po dito, 360 po yung full day charging niya. Yan, okay? This one, ito po yung ginagamit pag yung, for example, if a client wants it special yung ano niya, yung solar street light niya with lamp, yan po. Ito po yung urban design na ginagawa namin. Yeah. We have it as well. So 100 watt peak, 140 and 190 the maximum, sir. Yes, watt peak. Now, we also have po the outdoor battery as well. Yan po. And then outer battery, ito po yung mga ano niya, ayan po, lahat ng mga features niya, we have it as well. And then, okay, now, pag yung hybrid na po yung solution, we also offer the remote monitoring unit, RMU. So yan po, parang SCADA type na po siya, yes. So this one, we also have our system, and this system can be integrated to third-party systems like SCADA, BMS, meron din po siya. So, if you have any questions on that po, our partner, Nodal Electric is here to support you on that as well. So, we have it as well po siya. So, ngayon, ang ginagawa po namin dito is ano po siya, parang naka-mesh ano po siya. This one, ito po. This is the connection po ng ginagawa namin. So, mesh network po siya, and then, ano po siya, Zigbee po siya from pole to pole. Yung ayan, Zigbee connection siya. So this is the standard setup of our solar RMU unit. We have it as well. And it can be connected to third-party devices like BMS, Building Management System, or SCADA systems. Yes, we can. Okay, so I think, okay, now, so ito po, solar system sizing. So, ayan. So very low understanding on LED solar technology, local players, over design and lack of standards. So yan. So ito po yung basics of lighting. So ito po, i-share na lang po namin. So in doing the parameters po, we need the longitude and latitude, air pollution, autonomy, and dimming profile. So battery sizing and PV panel sizing. So yan. Now, so for longitude and latitude, ito po yung tinatawag natin na direct normal irradiation. So DNI. So ito po yung specific na po. So this is coming from NASA po na in data. Okay? So we have it as well. And then the air pollution is another factor po siya. Mapapansin niyo po kasi once na polluted po yung yung sobrang pollution na yung countries, nag-e-effect po yan sir sa performance po ng mga PV modules po natin. Okay? So those are the considerations that to be taken as well, air pollution, irradiance, and then okay, another one, ito po yung tinatawag na autonomy. Example, no? Example autonomy. First day, siya, no? Umaraw. Then the second day, nung gabi, night, wala pong moon siya. The second day, umulan. So, tapos the third day, umulan po siya. So, ang ibig sabihin po ng autonomy is, yung tagal po ng duration bago ma-discharge yung battery. So kasi po, kunyari, walang problema pag yung buong araw, umaraw siya, so technically, sir, mas-charge po yung PV module. Pero pag umulan, there are certain times na minsan, hindi po magma-maximum yung charging niya. So ito po yung tinatawag na autonomy. So when choosing solar street lights, please consider po ito talaga yung autonomy, kung ano po yung sa runtime niya. Very, very important po siya. Okay? And then, the sizing of the battery, so the computation is here as well. Dito po siya. We will share this presentation po sa inyo. The sizing of the battery, we have it as well. And then the sizing of the PV module, the formula is here as well po. Okay. And then, okay, how to get the peak sun hours? We can have it through, sir. We have the website of NASA. So it's here po. So para malaman niyo po kung ano specific sa country na location niyo yung peak sun hours. This is the data. Okay? And then sizing of the cables as well. Ayan po, meron siya. This is an example po doon sa calculating tool namin. We have it rin po. Okay? And then I think for the last one, cable loss yan. Meron rin pong calculation din yan ang ginagawa. Yes, we have it rin po. So I think Ma'am Geraldine, to all the participants, I think that is the last presentation slide. I think we will now go po on the question and answer part. Ma'am Geraldine, would you help us po? Any questions po?
Pwede question and answer sa chat box na lang po.
Okay.
Sir Allison,
Okay,
Ma'am
sir.
Geraldine. Anyway, you can always answer them, and we will also post the answers in the web.
Yes, sir. Sige po. Yes. Okay po. Okay.
Wala namang question, sir. So,
Okay po. Okay. Okay. Sige po. I'll give to Miss Geraldine po ulit.
okay. So, Ma'am Geraldine, thank you for the presentation, no? Yung galing sa Signify. Thank you, Sir Allison. And at this juncture, we will award the certificate of appreciation. Let me read the certificate of appreciation. IIEE Cebu chapter present the certificate of appreciation to Nodal Electric Trade and Services in gratitude and acknowledgement of the invaluable support as gold sponsor in this 20th Eastern and Eastern Visayas Virtual Regional Conference given this 18th day of September 2021, signed President of Cebu Chapter Mario Tabanyag, Regional Governor Felipe Niliama, VP Technical Affairs Roel Ratilla, Technical Consultant Advisor Brian Pasilan. Ladies and gentlemen, so we will award the certificate of appreciation to Nodal Electric Trade and Services. Thank you very much and congratulations. Yeah, you're welcome. So,
Thank you, Allison.
next,
Welcome po, ma'am.
sige, Ma'am Geraldine.
Thank you, sir.
Okay, sir.
You're welcome. Yeah. So next will be the topic is about the motor principle construction and winding design. So to do this, please help me welcome the Vice President of Internal Affairs of IIE Mactan Chapter. He's a Facilities Engineer of Noyles Electronics Philippines Corporation. Ladies and gentlemen, please help me welcome Engineer Joseph Gary D. Dagpin, PEE. Sir Joseph?
Good afternoon, everyone. Can you hear me, sir?
Yeah, it's loud and clear. You can get through now.
Can you see my slide?
Yes, it's on display, so you may proceed now.
Okay, thank you for having me today. I will be presenting electrical motor principles, its basic construction, theory, and some winding designs. For this discussion, we try to put aside how the motors is used and its general application. So wala munang installation ngayon, no? So we will cover how the motor is made, its construction, and the principles behind it. For a brief history, early motors used electrostatic forces to create rotation due to difficulty in generating high voltages. It was never developed for practical purposes. Then Faraday discovered electromagnetism in 1820s, which laid the foundation of creating electromagnetic motors. In 1834, Thomas Davenport invented the first functional battery-powered electric motor that can perform specific tasks. Then, it was Tesla that envisioned industrial development in the 1880s through his invention of induction motor. More innovations made to this day, but the concept of electrical motor and electromagnetism remains the same in the 1880 perspective. Motors revolutionized the course of human civilization and start the industrial age. Now, 50% of the total electrical power consumption is due to motors alone, and 90% of the motors are induction motors. That's why most of our discussion today focuses on induction motors. Let's go to our goals and objectives. First, we will discuss the basic definition of electrical motor. Then, the second, parts of an electrical motor. Third, how electric motor works through electromagnetic induction and some motor mechanisms. And fourth, we'll try to review the basic motor winding configuration. Okay, what is a motor? An electrical motor is a machine that converts electricity into mechanical energy, mechanical motion. No? An AC motor or is a machine that uses alternating current electricity. No? What are those AC motors? The synchronous motors and the asynchronous motors. Under asynchronous motors are the induction motors. No? In DC motors, it is a machine that uses direct current electricity. The types are the series motors, shunt motors, compound, and there's also a permanent magnet motor. Then third is the universal motor, which uses either AC or DC source. So this one does not use that one in the DC, the permanent magnet motor, because of an AC source. Next, what are the parts of the motor? Lahat po disassemble ng mga motors, makikita to lahat, no? Let's try to review. So this one is an induction motor. At the end is the fan cover. There you see the cooling fan, which is attached to the shaft of the rotor. Then the end bell or the end plate. Then the cast iron frame, which inside is the stator and the windings. The next is the squirrel cage rotor, no, with bearings, shaft, and bearing seals. Then the front is the front bell or front plate. Next part is the rotor. No, what we see in the rotor is that there is the edges of the bars that runs along the axis of the rotor, but they are not angled, or they're angled maybe 30 degrees to the shaft. It is designed to reduce cogging torque, harmonics, and noise. By slanting these bars or these conducting bars, the torque is kept more uniform as the rotor turns. No, this set of aluminum conducting bars is called the squirrel cage. No, as we shall see later. Rotor is actually made up of stack of disc-shaped laminations of soft iron. We can identify why, and the reason behind why is it is stuck, not a solid one. No. So again, these are rotor components. There's a shaft, the bearing, the component of a cylindrical shape, which has an iron core lamination, and inside is the conducting bar of squirrel cage conductor. This is a significant part of the construction because this forms the wire of the rotor. Okay, this upper part is the solid cylinder of the rotor in comparison to the stack laminated part of the rotor. It is said that electrical conductors moving through a steady magnetic field or stationary conductors within a changing magnetic field will have circular currents induced within them called eddy currents. No, this one has large eddy current compared to this one, which has limited due to the stacking and separating with the lamination. Eddy currents consume a considerable amount of energy and often cause a harmful rise in temperature. So that's what we avoided. So this one has a lower temperature compared to the solid cylindrical rotor. And the stator is the same. No, it is constructed with an iron core with laminated disc. This one is inside this iron frame. The stator has slats, no? The total slots should be divisible by 3, so we can use it for single phase and also for 3-phase. Okay, that's all for the parts of the motor. Let's share this quote from Nikola Tesla. If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. What do you think we have come from Tesla to the modern times? Do we already grasp all these phenomenon? I think not. So there's still more improvement we need to study and research to further level up our knowledge with this. Okay, next topic is how motor works. Okay, this too is the experimental experiment for this equation here. This electromagnetic principles. First, this is a Faraday's law, which states that an electromotive force can be produced when there's a change of rate. D over dt is a change of rate of electric flux. The electric flux, magnetic flux is defined with this formula. It is an magnetic flux that was in the area across this magnetic field, no? Then sabi ni Maxwell, nakikita niya ito. Sabi niya may igaganda pa to, no? So he developed another formula from the Faraday's formula, which is the third equation of Maxwell. We know that the left side of the equation is the output and the right side is the input. But Maxwell said it can be reversed, no? So the first one is the simple Faraday's law. The n is removed because it is already defined in this closed loop integral of the unit length, no? So it says that rate of change of magnetic flux can produce an electromagnetic wave, no? Electromagnetic force. So this is the experimental. So if we push this magnet, there goes a voltage or electromagnetic field, electromagnetic force, no, in opposite direction because it opposes the line of flux, no. When we pull that out, this pointer galvanometer will go to the other way, but when we stop, it goes back to neutral. But in reverse, we tried it. This was the output and this is the input. It says that if we have an electric field along this wire, across this wire within the loop, there produce a rate of change of electric flux. This is the motor action, no? That one is the generator action. So what is the goal here? Is to produce a controlled magnetic flux. Okay, so let's try to examine this one. This is like a transformer. This one is the primary and secondary, no? If we try to put DC here and the secondary, if it is open, we can see a pulse, no? Only a single pulse because we cannot transform a DC directly. But if it is shorted here, there's a high pulse, no, of current. Now, if we put AC here, we can see in an open terminal, there's a negative AC, no, coming in this one. But if we short this one, there will be a high current pulsating in this wire. This shorted coil represents a shorted ring of the squirrel cage motor, exhibit a high current and creates magnetic flux directional along the metal core. Okay, this is just a representation. This stator produces an pulsating magnetic field, while this rotor, during startup, impress a reverse magnet on the rotor. No, the rotor is frequently pulled towards its active magnetic pole of the stator as it shifts phase, preventing change in rotor magnetic polarity. So the magnetic polarity of the rotor does not change on its phase, no, but the stator, it changes, no, due to rotating magnetic field. This is more evident in the generator when we see the wire here with a rotating field rectifier, no. So in rotor, the pole is fixed on its face. There, we see there. So with the rotation of the motor, the north pole and south pole is fixed. No? With the induction motor, we need slip to cut, no? The induction motor, the rotor speed must be less than magnetic rotor rotation to maintain EMF in the rotor bars. Because if the rotor speed and the synchronous speed, the magnetic field will rotate in sync with shorted ring and will not produce EMF and current. Okay, this is the rotating magnetic field, no? The stator rotates along adjacent pole, the rotor goes along with the rotor rotation. So we see here that the stator changes magnetic field in adjacent, no? But the rotor is fixed. Its magnetic pole is fixed. This is the rotating magnetic field in three-phase induction motor. So we see here in this positive, we check here, that one, then next pole, next pole, next pole, and next pole. That's how rotating magnetic field works. But in single phase, there is a different characteristic now, because there is a at least 90 degrees angle to rotate the motor, which enabled it for the stator to attract the rotor pole here. Much less if we don't have this auxiliary winding. No? So the solution is to put a capacitor. The capacitor shifts the current 90 degrees out of phase in the auxiliary winding from main winding current. This creates a rotating magnetic field. No, this 90 degrees shift. So let's explain that one. Okay, we see here the stator in different time. No, time A, time B, time C. We'll orient ourselves. Time B has one winding with polarity and one is zero. So B, the auxiliary winding is at peak and A at zero. So this is the main winding. No? At point A, the main winding has a power but decreasing, and the auxiliary has also a power increasing. So there is a magnetic field in both winding, and the resultant field goes here in diagonal. No? So the rotor goes here. In B, because there is no main winding, the rotor will orient to this direction. In C, when there is the auxiliary winding is in positive and main winding is in negative cycle, so there is a separate angle produced by the rotor, and go on. So you see now that there is now at least 45 degrees, no, rotation of to attract the rotor, and this is the rotating magnetic field of a single phase motor. So that's all for the how motor works. Let's go again with Tesla. He said the most important thing to me is the discovery of rotating magnetic field. No, Nikola Tesla introduced the two-phase RMF, while Michael Dobrovolsky on the three-phase RMF. This is the patent representation of Tesla when he make the patent for this. Next is the motor winding. My experience, my technician no, na nag-repair ng motor, tinanggal lahat ng terminal at walang label. Naging ganito. Ngayon, sinabi ko na kuha ka na ng scrap ticket disposal, hindi na natin magagamit yan. So, with our understanding with how the winding is placed, maybe we can avoid that scenario. Okay, let's start with the number of coils. So we know that there are two sides in a coil, no? So for every slots, there should be 1/2. Now for all this discussion, we need a sample data, the 24 slots, the 4 pole, and the 3 phase. No, so in the 24 slots, the number of coils should be 12. No, we will just review the single voltage, no, because the dual voltage just produce duplicate on the upper level of the winding. Then next is the number of coil group per phase. So it's a coils per phase, or number of coils over number of phase. No, for 24 slots, 3 phase, there should be 4 coils per phase. No, so 12 over 3. Now from yung at my early years, no, what my understanding with this pole is that there should be a complement pole down here, no, negative. So if it is positive, there should be negative. No, it's not the case. No, it's true with the 2 pole, but the 4 pole and 6 pole, it should be the adjacent should be the negative. No, positive, negative, positive, negative. This one. So the our winding connection would be starting, ending, ending, starting, starting, ending, ending, starting. If this is a 6 pole, then we can put that one again, still positive, negative. No, so again go starting, ending, 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 then starting. No, I think this is clear. So coil number of coils per group per phase is the number of coils for every phase. Next, the coil group and configuration. No, coil groups or the coils per pole equals the coils per phase over number of poles. So how many group within a pole? So for 24 slots, 3 phase, 4 pole, coils per pole equals 4 over 4 equals 1. No. In other case where there are more coil per pole, so there may be a concentric winding or there's a lap winding. So we'll just connect that number of poles, a number of coils in the pole, no, just like this one. Is the concentric is goes in circular, but the lap is side by side. Next is the coil pitch or coil span, no, the full 180 degrees of the electrical cycle. No, there is also called the short pitch, which is reduced in slot, no, to eliminate any harmonics. That is the 5th and the 7th harmonics around 144 or 154. So it might reduce this one to around 150. Now, the coil pitch for 24 slots per pole is 6 slots. No, 24 over 4 is 6. So where is that 6 slots? So the distance here to here should be 6 slots. No. So when a short pitch is used, the pole pitch, which is this one, will be now more than the coil pitch because the coil pitch is reduced. No, that's the difference. Okay, let's try to plot this one with a complete cycle in the motor stator. No, this is the one cycle, electrical cycle, and where is that slot difference? So first we check where is the line 1 and the piece A line and piece B line is separated within the stator. So is the formula 120 times coil pitch over 180 equals 4. So this one distance here to here is 4 slots. These are coil pitch which we already calculated before. Then this is the pole pitch. One cycle should be the series of positive and negative pole, no? This one. So positive to negative is one electrical cycle. Okay, so from our symmetric components, this angle is equivalent to 120 degrees. No? So how many electrical cycle in one turn? So a two pole has 2 over 2 should be one electrical cycle is equals to 1 rotation. No, but a 4 pole should be 4 over 2 because we need 2 because we need positive north and south, no, 2 poles. So it should be 2 electrical cycle and so on. So 6 would be 3 electrical cycle. So the slot angle is measurement increment of every slots, no? The number of pole times 180 over number of slots. So in the 24 slots, there should be a 30-degree angle if we reduce it one slot. This used in the short pitch winding. So 180 degrees as full pitch winding minus one slot. If we have this at 5 slots, would be 150 degrees angle. Okay. Let's forget about the 4 pole 24 slots. This is a 2 pole 24 slots. So let's see how the winding, the U1, V1, and W1 are distributed within the rotor, the stator. So the phase difference would be 8 slots. No, it was equally distributed around the stator because one electrical cycle in a two pole equals to 1 rotation also. So let's check this one. This positive, this one goes here, this one goes here, and this one goes that one. That's the symmetric distribution of the winding of a two pole 24 slots. Okay, we already have the data for the 24 slots, 4 pole, 2 phase, 3 phase. No? So this one is single coil. So 1, 2, 3, 4. This is the phase A, and its equivalent terminal connection. No. Then phase B should be 4 slots after this angle. So we shall see phase B is we need to have this counted as 0. 0, 1, 2, 3, 4. That's how we count this one. No? So this is the second line of our terminal, the phase B. Then the phase C should be 1, 2, 3, 4, 4 here. No? So U1, V1, W1. This is for the 24 slots, 4-pole, 3-phase motor. Okay. This is a stator winding arrangement now of the one is 36 slots, the 24 slots, and the 12 slots. All are 3-phase. So in 36 slots, there are 18 total coils, and the coil per phase is 6. The coils per pole, so 6 divided by 2 equals 3, 6 divided by 4 equals, so there's not a whole number here, no, 1.5, and 6 divided by 6 equals 1. The coil pitch, you can calculate this one with our formula. With the 24 slots, 3-phase, total coils is 12. The coils per phase is 4. The coils per pole for a 2-pole is 2. 4-pole is 1, and it cannot be used for the 6-pole, no. And for the 12 slots, 3-phase, there will be 6 coils, and coils per phase is 2. So it can only be used for the 2-pole, no. Okay, we will use this 4-pole 36 slots in our practical distribution. No? So we try to calculate this 1.5. So this one arrangement, there is another arrangement I see with this type of winding. So there you can see 1, 2, 3, 4, 5, 6 coil in a 4-pole 36 slots, 3-phase. The coil pitch is 10. The phase difference should be 6. So from here, 1, 2, 3, 4, 5, 6. So the second phase will be at this slot. Then the third phase would be at this slot. No, I didn't put the terminal, so there will be no clutter with our with the winding. No, so that's all. That's the end point. The U2. This is U1. This is the U2. Okay, that's all for our discussion for the winding, and I would like to part this presentation with Elon Musk quote. In order to have clean air in the cities, you have to go electric. Sir Jill Luzaris said that these electric motors cars will become more frequent in our street these days, and these electric cars also uses electric motor, especially induction motors. And that's all for our for my presentation, and thank you, IAE Cebu and the whole committee for having me present here.
Okay, at this juncture, we will award the Certificate of Appreciation. IIE Cebu Chapter presented this award, Certificate of Appreciation, to the technical resource speaker on the topic Motor Principle Construction and Winding Design in the 20th Eastern and Central Visayas Virtual Regional Conference, Zoom Conference, given this 18th day of September 2021. Signed, IIEE Cebu Chapter President Mario Tabanyag. Signed, IIEE Regional Governors Region 7, Felipe Neliama. Signed, BP Technical Appeals Lowell Ratilia. Signed, Technical Consultant and Advisor Brian A. Pasilan. So ladies and gentlemen, so a warm of applause to Joseph Gary D. Dagpin. So thank you very much, Engineer Gary. Okay, by the way, your support host for today, Bobby Marino. Support lang ni kay because si ato ang MC si Bob Cabarubias doon na sad siya laing mga commitments. So it's good that we save some time, so we will proceed to the next speaker. Okay, the next will be Republic Act 10968, the Philippine Qualification Framework. This will be done by one of our national officer, Vice President IIE National. He's also connected with TUP Manila, and he's very active in the national scene in IIEE. The National Vice President for Internal Affairs. Ladies and gentlemen, please help me welcome Engineer Lyndon Baggy. Good afternoon, Sir Lyndon.
Hi, good afternoon to all. So I will try to present my topic as short as possible. Because I think we are late by 1 hour na pala as per schedule. But anyway, because of the technicalities, talagang po. So may I share? Okay, so can you see my presentation? So this is actually this is actually a prelude to the activity that being performed by the PRC nowadays. Now kahapon nata si Honorable Jaime Mendoza is talk about the career progression. So what is career progression? He explained all of this, but why this career progression came about. So this is basically when RA 10968 was created, and that this what we call Philippine Qualification Framework. By the way, aside from being the VP for Internal Affairs of the IAE, I'm also a member of the Technical Panel for Engineering and Technology from CHED, and also the chairperson of the Technical Committee on Engineering and Technology. Now I start with the Philippine Constitution. So according to Article 14, it is the education, science and technology, arts and culture and sports. So in this article, section 1 is state that the state shall protect and promote the right of all citizens to quality education in all level and shall take appropriate steps to make such education accessible to all. With this article or section in the Constitution of the Philippines, they emphasize this concept of education. So sabi dan, education may be referred to the process of training the physical, mental, and or moral faculties of an individual. The purpose of education is to provide an individual with knowledge, skill, competence, or usually desirable qualities of behavior and character to render him fit for the duties of life. Education may be acquired through a formal course of instruction offered by institutions established for the purpose, or informally through means outside the formal school system, such as on-the-job training, exposure to work. Kaya yung kaninang mga nag-lecture, they share what they experience in their work, the self-learning and training under out-of-school study program. So ito yung mga estudyante na hindi makapag-aral. So it is said that life is a continuing education, or stated in another way, education is lifelong learning. Kaya di ba number one objective of the IAE is to promote trainings through seminars, and today we called it webinar. So the state shall establish, maintain, and support a complete, adequate, and integrated system of education relevant to the needs of the people and society. Kaya later on, I will discuss it in detail. Establish and maintain system of free public education to the elementary and high school level without limiting the natural right of parents to rear their children. Elementary education is compulsory for all students of school age. Kaya ngayon, ang tuition fee ay libre. So lalo na sa mga government institutions. Establish and maintain a system of scholarship grants, student loan programs, subsidies, and other incentives which shall be available to deserving students in both public and private schools, especially to the underprivileged. So some of us probably here are being scholars. Encourage non-formal, informal, and indigenous learning system as well as self-learning, independent, and out-of-school study program, particularly those that responds to community needs. And last is to provide adult citizens, the disabled, and out-of-school youth with training in civic and vocational efficiently and other skill. Kaya later on, we will realize na pag-aaral is not only for people na pwedeng mag-aral, but also those mga people na hindi makapag-aral, so the government will take care of this. Again, according to European Union, that support to higher education in an Asian region program, education is a cornerstone of every nation's social and economic development, and universities plays an indispensable part in education, research, and innovation. Now, before we proceed, I would like to define first ano ba yung mga terms na naririnig na natin as far as our education is concerned, but particularly doon sa mga member na nandito na ang anak nila ay nandito pa sa let's say basic education. So ito yung nire-refer natin na K-12 ngayon, that it should encompasses kindergarten, elementary, and now we have the secondary or yung high school, as well as alternative learning system for out-of-school youth and those with special needs. So they called it basic education. For higher education, this refers to post-secondary education offered usually by university, college, academics, or professional, or even technical institute with programs leading to academic degrees, diplomas, or certificate at the post-baccalaureate level. And of course, naririnig na natin madalas itong word na qualification. So nabanggit yan ni Honorable Jaime Mendoza. It refers to formal certification that a person has successfully achieved specific learning outcomes relevant to the identified academic, industry, and community requirement. A qualification confers official recognition of value in the labor market and in further education and training. Kaya lahat po ng mga programa sa atin, lalo na sa college, are being evaluated so that all student who will graduate are basically qualified. Yan yung nakikita na natin. That's why there are some programs na may board exam. So as you notice, last 2 days ago, lumabas yung EE board exam and we happy naman nagkaroon na ng board exam. And those who pass ay talagang natutuwa ngayon. But those who did not come because of some problem, probably next time, no, may susunod pa naman. Another term is the technical vocational education and training. So ito yung ating isa sa mga tinatawag ngayon, ito yung parang TESDA. This refers to the education involving the study of technology-related science, in addition to general education, as well as the acquisition of practical skill relating to occupation in various sectors of economic life and social life, in which comprises formal, yun yung sa school, and non-formal, yun yung mga organized classes outside the school system. Okay, and approaches. And of course, the last term is the trifocalized education and training. It refers to the shared administration of the educational system of 3 agencies responsible for education level. The first is DepEd for basic education. The second is TESDA for technical vocational education. And of course, part of this is training. And the third is CHED for higher education. Kaya isa sa naging factor nito because of the economic context. We are now in globalization. There is a paradigm shift. So dati hindi natin to pinapansin, but nowadays mukhang nagiging reality that we need to be part of the globalization, meaning the breakdown of national borders and emergence of regional economies such as European Union, ASEAN, and of course yung mobility. So parating nababanggit ito in the discussion about ACPER, ASEAN engineers, etc. So the demand of comparability, the national framework and the regional reference framework. And of course the resurgence of nationalism, the post-truth, and the end of enlightenment values. So yan ang mga nagkakaroon ngayon ng konteksto why we need to improve our educational system. So for national, there is a persistent critique of the mismatch between educational qualifications and the need for industry and economy. Ito nga po yung binabanggit parati na although ngayon nagkakaroon ng competition with different discipline, but dapat po magkaroon talaga ng match with regards to the needs of our industry and economy. The fragmented system of qualification in the country, the pressure of regional economic communities such as ASEAN, and the issue of comparability for the significant number of skilled workers and professional working in our country. So tayo lumalabas para magtrabaho, but may some foreign naman pumunta rito para magtrabaho. So ang tanong, dapat ba sila magtrabaho dito o tayo ba ay dapat magtrabaho sa ibang bansa? So because of this, we need to change our education. So nagkaroon ng paradigm shift in education. We are now from education to learning. Meaning, hindi ito tulad noon na magbasa ka lang ng libro, pag pumasa ka, okay na. Ngayon, ano bang natutunan mo sa pinag-aralan mo? That is why, because we tend to go with lifelong learning. It is the key for individual in the 21st century. Lifelong learning meaning as you finish your education, dapat meron kang natutunan at na-apply mo na for your personal needs. And from learning input to learner's outcome. So what is learner's outcome? Ito po yung pag graduate ang isang bata, to talaga bang pag pumasok siya sa trabaho, yun yung kanyang ginagawa. So marami tayong mga bata ngayon na pag-graduate sa isang program, sa isang degree, pag lumabas at nagtrabaho, iba naman yung ginagawa. So hindi natin siya learning outcomes. Hindi siya natuto dahil hindi siya natuto na gamitin yung pinag-aralan niya, bagkus ang nagawa niya ay iba sa ini-expect niya. So to help individuals adapt to the evolving requirement of the labor market, and better master the changing time frame and rhythm of individual existence. Kaya yung CHED ngayon, ini-improve, ina-upgrade, ino-contextualize yung mga programa in such a way na maging form part para yung mismatch with the industry ay malesen. So ito po yung nangyayari na sa atin since the time that this program was started. Ito yung ASEAN Qualification Framework, kaya yung iba nag-ASEAN Engineer, nag-Upper, nag-APEC, and ngayon meron tinatawag na career progression, specialization, and so on. Because we are part of the World Trade Organization, we call it mutual recognition arrangement. So there are 8 programs. Engineering is one. I think medical, architecture is part of it. So tayo ngayon, we need to meet with this recognition arrangement. Because of this, nagkakaroon ng staff and student mobility. Ito yung nagpapalitan ng estudyante para yung estudyante natin makapag-aral abroad and malaman kung ano ba yung pagkakaiba sa abroad and of course, ano ba yung binibigay locally. And of course, part of that is the training certification para magkaroon tayo ng economic improvement. So ito kasi is form part of lifelong learning na magkaroon ng training. Kaya tayo nagkakaroon ng seminar, although wala pa tayong training na nagagawa, but more on lecture. Katulad kanina, yung nabutan ko is the motor control. So siguro na-imagine nyo nung kayo nag-aaral pa, yung iba sa inyo, yung ba yung natutunan nyo nung nag-aaral kayo? O natuto lang tayo dahil nakita natin ngayon. So part yan ng training. And of course, education is important so that we could have equality and the image of the higher education in Tibet, plus the employment with the greater mobility of professional, talent, and skilled labor. Dapat magkaroon tayo ng quality assurance, standard labor, adequate and appropriate technology, intelligent work process, and of course, to support for our MSMEs and better have a sustainable development pension. So with this, nag-create ngayon ng Philippine Qualification Framework. So it is a quality assured national system for the development, recognition, and award of qualification based on the standard of knowledge, skill, and values acquired in different ways and methods by learners and workers educated, trained in the Philippines. Kaya Philippine Qualification Framework. The objective of this is to adopt national standards and level. Kaya later on, malalaman natin kung ano bang level kayo based on our learning outcomes to support the development and maintenance of pathway and equivalencies. So ngayon, CHED is preparing for pathways and equivalencies, meaning there will be a time that our training will be given credit unit in as far as the education system is being developed. The third is to align the international qualification framework. So with this development, tayo po ngayon ay naka-align na sa international qualification framework. So ano yung benefit? For person, we encourages lifelong learning, allow the person to start at the level that suit him and then build his qualification as his needs and interests, develop and change over time. Because of this, nagkakaroon siya ng recognized certificate and license. For employers naman, assures that the standard and qualification are consistent with job requirement demand. Provide common understanding of standard, qualification, and level. Kaya kung may mga employer dito, dapat ma-proceed rin natin, ano ba yung mga required qualification ninyo para ma-adapt na namin in terms of education. For education training providers, ensures transparency of training provision, conformance to standard and preciseness of accountability for learning outcomes, catalyzes reforms toward quality programs, provide common understanding of policy and guidelines on credit transfer. But at this moment, wala pa po tayo nito. Articulation, ito yung babanggitin ko later. Portability, bridge pathway, and of course, RPL, lifelong learning. For authorities in government, it provides the standard, taxonomy, and typology of qualification as basis for granting approvals to provide providers and stakeholders. Harmonized qualification in the ENT across the Philippines. Ito yung technology, okay, and enrichment. Then for Filipino as public, a change in the mindset that undermines technical education and the end of education inflations. So with this, ito pa yung mga ibang meaning ng qualification para mas maintindihan natin na ang qualification basically ay all formal awards. So pag binigyan ka ng awards, meaning yan yung qualification mo, which signifies that the bearer has some knowledge or competencies or they have successfully completed some learning program. Qualification are translated into statement of learning outcomes and associated requirement for awards. So it was started as early as 1998. However, based on the political situation, 1998 was Ramos' time. Diyan nata siya mag-i-end ng kanyang term. Pero nag-start na yung Tibet sector. Yung Tibet basically is yung NMYC do sa mga medyo may edad na. Yung National Manpower Youth Council. So it was converted to TESDA. Kaya initially nagkaroon ng Tibet sector. In 2003, you notice 1998, 2003, medyo malayo yung gap. It was the time of Erap Estrada, President Erap Estrada. Alam niyo yung situation, nagkaroon ng people power, so hindi na materialize ito. In 2003, Macapagal Arroyo, President Macapagal Arroyo came. So kinonvert niya yung Tibet sector into Philippine Tibet Qualification Framework kasi nahuhuli na tayo in terms of mobility. 2004, in-enhance niya, ginawa niya executive order to promote expansion of the QF. 2012, in-expand siya, in-institutionalize para mas maging maganda. Of course, nagkaroon ng development. In 2014, na-create yung Ladderized Education Act of 2014, which encompasses the institutionalization of the PQF. Ito na po yung tinatawag na Ladderized program. And in 2018, yan, ito na po yung batas. 2014 was the time of Arroyo, Benigno Aquino III, and 2018 is time ni ni Duterte na ata ito. Or end ni President Benigno Aquino. So, ang laman nun is that the Philippines must have a national policy. So, ginagawa na po ito ngayon o nagawa na. Kaya lahat ng ating mga program are basically competency-based. And based dun sa ating na-develop ng mga programs, it drivens labor market because of the leveling. And later on, actually this is the first year na graduate na yung ating mga itong taon na to, 2021, ay gagraduate na yung ating mga 4-year degree program, particularly in BSEE. So magkakaroon ngayon sila ng assessment-based qualification recognition. So sana with this assessment, we able to determine kung yung bang program na develop are coincide with the qualification na yung mga bata will be a first batch na magkakaroon ng learning outcomes na magagamit nila sa pagtatrabaho o pag-work. So ito po yung Pathways and Equivalencies Access Ramp, part of the Philippine Qualification Framework. So nahati ito basically into two. Wala dito ang PRC because PRC has a different activity na ginagawa na ngayon pa lang sila pumapasok. Tayo, meron nga tayong tinawag na basic education. Pag ang bata ayaw mag-aral, pwede siyang mag-textbook. So the TESDA is now part of that. So siya magpo-provide ng training and others. Or ang bata nagtrabaho na kagad, ayaw niyang mag-aral nung panahon na nagtatrabaho siya, pero bigla niyang nagustuhang pumasok sa informal or non-formal, nagkakaroon ngayon ng mga learning activity silang ginagawa through some agency. And one of the most popular is ETIAP, Expanded Tertiary Education Equivalency and Accreditation Program. Ito po yung nag-aral ka ng high school, nakapagtrabaho ka, naging professional ka, pero wala kang formal schooling, pwede kang pumunta rito. But there are limited school lang na nag-offer nito. So engineering has this ETIAP. So kung formal naman, meaning you apply for CHED recognition, you need to apply for accreditation. So each of the programs na na-develop during basic education, may mga agency or accrediting body na nagpo-provide ng certification. One of that is TESDA. So sa TESDA, meron tinatawag na National Certification 1 to 5. You notice itong naki-specify portfolio assessment, meaning i-assess yung mga accomplishment mo from time na graduate ka sa high school at ikaw ay nakapagtrabaho formally meaning may mga certification ka coming from your employer, may training na tinang ka, nagkaroon ka ng expertise, then this accomplishment can be converted into certification or portfolio na binibigyan ng grant ng TESDA provided you pass the requirement. Now, if you need a higher program, CHED may create or will create equivalency certification, yung tinatawag na credit transfer. So halimbawa, umatin ka sa mga association like management, management in the Philippines na isang organization, kumuha ka ng mga crash course, etc. Then na-fulfill mo yon, then pupunta ka kay CHED para magkaroon ng credit transfer. Pero at this moment, hindi pa to nare-realize kasi it's very hard to determine the equivalent unit, yung mga training na ginagawa. So I give you example is the Philippine Railway Institute. They are giving training to those employee or aspirant na magtrabaho sa mga LRT. So sila ngayon nagtitrain, and this training ngayon ay sinasuggest nila through a memorandum of agreement between CHED and the DOTR transportation na yung kanilang training will be credited. So pinag-aaralan pang maigi yun kasi it's very hard talaga to define what is the credit unit na nilalagay. Parang yung sa ating CPD points, may mga credit equivalent yan. Now, if you want to learn through education, yan, pwede ka mag-BS, after BS, mag-master ka, after master's program, mag-PhD. So yan ngayon ang trabaho ni CHED. Yan ngayon trabaho ni CHED to give recognition in terms of diploma, transcript of record. So from there, mag-grant ito. Then after that, merong tinatawag na post-degree kung gusto mo pang tumaas yung level mo in terms of pagiging professional or expert like mga doctor of medicine. So doctor na sila, but they tend to go for post-degree. Ito yung mga tinatawag na kanilang expertise. Okay? So from that, ito ngayon yung final because it was stated in the law in July 2014 na ang grade 12 o yung tinatawag nating K-12 is below level 1. Meaning as they graduate sa high school, hindi sila automatic na level 1 kasi dati naka-embed yan sa level 1, level 2. Ngayon hindi. They need to take assessment through TESDA if they wish to be an NC1, NC2, NC3, NC4, NC5 until mag-reach siya sa level 5 based on his work and accomplishments. Pero kung ikaw ay mag-aaral, ito ka, once na mag-first year ka, you intend to apply for NC1. May mga school na pagka natapos ka ng first year, nag-exam sila sa TESDA, nabibigyan sila ng certificate. So pwede sila magtrabaho, but on that level lang. So more or less helper sila or tumutulong lang at para lang meron silang kinikita kumbaga. Then second year, third year, fourth year. So notice yung fourth year is level 4. So kung ang bata, gawin natin sabing electrical engineering, at that moment nasa level 4 siya. So upon graduation, he can be level 5 kung magwo-work na siya. So level 5 'yon. So hangga't di siya nag-board exam at di siya pumapasa, he cannot be put in level 6. And of course, dapat meron siyang proof that siya nag-aaral, nagtatrabaho na on a particular given program na work na talagang relevant or related sa kanyang tinapos. Then, level 7, ito yung master's degree. Kung gusto mo pang mag-aral, then doctorate degree. Now sa atin, I think in-explain natin ni Sir Mendoza nung nakarang araw. Now once you take the board exam, pwede kang pumunta dyan sa level 6. But the CHED, or not the CHED, the IIEE, through IIEE, merong parang evaluation or assessment that you really be a level 6. Then nire-recommend ka sa PRC to give this recognition as level 6. Then level 7 is for PEE. Pag pumasa ka ng PEE and PEE, titingnan yung iyong evaluation. If you succeed based dun sa requirement ng professional career progression based on evaluation, you can be granted as level 8 na parang kapareho ng doctoral or postdoctoral. But PRC recognize it, not the CHED. Itong CHED is basically the formal schooling. Okay? Itong diploma, pababa, is the training given by TESDA. So, with this, the Philippines has only 3 domains: the degree of independence, the application, the knowledge and skill. Ngayon, kung pupunta ka ng Malaysia at doon ka magtatrabaho, medyo isa-isahin yan. Saan ba makikita yan? Of course, unang-una na sa transcript of record. Sa TOR mo, may mga subject relevant ba na pwedeng ilagay dito? So, sabihin, pag problem solving and scientific skill, lahat ng may mga math. Communication, leadership, teamwork, yun yung English, management, and others. Values, so form part yan, embed yan sa mga subjects supposedly. Social skills and responsibility, mga social science. Practical skill, yun yung mga shop. And of course, the knowledge of subject area. Ano ba yung skill na dadali mo sa kanila para makonsider ka na pwedeng magtrabaho sa Malaysia? Kaya ang Philippine Qualification Framework ay gumawa ng descriptor from grade 12, then level 1, di ko na isa-isa sa inyo to. I go with our part. Tayo ngayon is in level 6, level 7, and level 8. So, i-sample natin level 6. If you are working, no, nagtatrabaho na kayo with your degree, with your license, sa work nyo ba, did you demonstrate broad and coherent knowledge and skill in their field of study for professional work and lifelong learning? So nagagawa nyo ba ito sa tinatrabaho nyo? Second, application of professional creative work or research in specialized fields of discipline and or further study. So yung kaninang dalawang nag-lecture with Sir Losares and the one who teaches the present the motor, yung ba ay karagdagan para magamit mo sa iyong pagtatrabaho? Or the degree of independency, the substantial degree of independence and or team or related field with minimal supervision. So, did you work as your own na walang supervision? So, that is level 6. Then level 7, of course, makikita nyo na ang pagkakaiba lang niya is more on advanced knowledge. Ito broad, ito advanced, ibig sabihin mas mataas na level. Applied professional and creative work, ito yung ginagamit natin sa ating TER, kaya nagano tayo sa PE. Napuprove natin that we are now advanced, no? Advanced in terms of application. We learn from the time na nag-aral ka sa school, nag-work ka, pumasa sa REE, then ipuprove mo ngayon to your PE that you have to be given this grant or recognition. And of course, there should be a high substantial degree of independence that involve exercises of leadership and initiative, individual works, and in team or multiple disciplinary field. Kaya itong mga to ay dapat ma-realize natin to our certificates. Kaya yung mga certificate na binibigay ngayon, although naka-e-certificate siya, dapat makakuha pa rin tayo ng kopya para at least meron kayong documentation. Because isa yan sa mga titingnan kung meron bang proper training or proper seminar kang inatinan in which you apply these things other than yung tinatawag nating self-long learning. So the number, level 8, medyo mas advanced, no, highly. So kanina broad, incoherent, advanced knowledge, and ito ngayon highly advanced. So mas mataas na level. Ito ngayon yung expertise ng isang individual based on the tawag nito, career na nade-develop nyo since the start of your work. Mas maganda sana if you concentrate on one particular career na dire-diretso, that's a good thing. For me, as a teacher, I've been professional teacher since 1991. So lahat ng aking mga experiences are in teaching. And basically, I learned from being a department head, dean, college secretary, director, then even a vice president for a while. So yun, sinama ko yan as form part of my experience. So ito yung comparison with Malaysia yung kanina. For example lang naman ito. So dito, mapapansin yung medical doctor. So DS, meron siyang of course in cultural approach. For 4 year plus 1, nagkaroon ng pre-clinical, clinical, then may mga subject module, etc. Hanggang sa maging MD siya, ang nagbibigay is the national licensure exam. Sa Malaysia, K-12 pa lang nag-umpisa na sila. So yung mga bata ron, kung gusto niya maging doktor na siya sa K-12 pa lang. So doon pa lang nakikita na talaga na gusto niya maging doktor. So ganun din natin ginago ang Philippines. Kaya yung K-12 natin, ang most common na dapat ma-recall para sa K-12, lalo na may mga anak diyan, kung gusto niya maging engineer, dapat STEM ang pasukin. STEM is science, technology, engineering, and mathematics. Pag naligaw siya, mahirapan na siya sa college. Kasi yung ibang school hindi nagpo-provide ng tinatawag na bridging. No? Ngayon, kung ikaw ay social science, gusto mo, yun, HUMSS, Humanities and Social Science. Kung gusto ng anak mo ay sports, yun yung GAS, General Academics in Sports, kung talagang gusto niya lang ay maglaro. Or, yung isa pang apat yan, pwede doon. Or, pag wala talaga siyang, kumbaga sa ayaw niyang mag-aral, pero gusto niya magtrabaho kaagad, tanong niyo kung anong gusto, dahil meron tinatawag na TLE. Yun yung Training and Learning Education na specified for the particular activity. And, dapat, yung school na pupuntahan ay capable to do that thing. So, hanap kayo ng school. So, yan na ngayon ang kalakaran sa K-12. So, who are responsible for this? So, merong National Coordinating Committee. Ito yung gumawa ng batas. So, nandiyan Congress, etc. Technical Secretariat, PQF Working Group. So, isa kaming naging PQF Working Group during that time. Then DepEd, TESDA, CHED, PRC, DOLE, Economic Sector, and Industry Sector. Kasi parati itong nire-review kung talaga bang nami-meet natin yung gusto natin. Kaya sa ating group, ito yun. So, of course, nag-i-start kay DepEd for information and guidelines, si CHED for quality assurance, yung mga graduate nila, then TESDA for qualification register. So, hindi porket graduate ka ng CHED, hindi ka pupunta kay TESDA. Pwede ka pa rin pumunta kay TESDA kung kinakailangan. And kung galing ka naman kay TESDA, pwede kang pumunta kay CHED for pathway and equivalency. So yung natapos mo kay TESDA, pwede mong pa-credit. Pero again hanggang ngayon, di pa siya nare-realize. And after that, PRC will come in for international alignment. So ang PRC ang merong trabaho nun. So for example, you have a country A, country B. Sa atin, ito yung atin. No? 1 to 8. Merong country na 1 to 9. Pero may mga particulars naman na kaya natin. Ngayon, yung mga wala, yun yung nagiging disadvantage over us. Kaya dapat, yung country mapuntahan mo, match na match. I think in the Middle East parang nagiging match na dahil marami ng mga professional natin doon ang nag-a-avail ng ASEAN Engineer, AACPER, and APEC. So sa Philippines, 8 tayo. Sa Thailand, siyam. Sa Malaysia, 8. Indonesia, siyam. Brunei, 8. Cambodia, 8. Australia, 10. Masyado silang mahigpit doon. No? And of course, New Zealand. Pero all the ASEAN or other technology came from Australia. Yun ang ginagamit natin. We called it Signia Accord. Kaya ito yung kanilang power, no? To harmonize qualification across basic, technical, vocational, and higher education, kaya pinakita natin kanina. To align education standard and learning outcomes with level, descriptor, kaya meron tayong mga descriptor na pinopromote. And of course, this descriptor should provide information and guidelines in the implementation of UTF. Kaya inilecture ito sa lahat ng mga forum para mas aware tayo and to realize the quality assurance mechanism of Philippine education. And of course, the last is to develop and recognize a pathway and equivalency. Kaya medyo kasi mahirap talaga mag-provide ng equivalency. Of course, functional, nampasan ko na yan. So again, ito yung mga technical working group. Okay. So ang timeline natin nung 2017, wala pang COVID. 2018, wala pa rin COVID. Pero nung mag-2019, marami pa dito sa 2018 na hindi pa nare-realize. But the group start doing it para kung tayo ay pupunta sa ibang bansa to work, particular in ASEAN, magkakapareho na yung ating qualification framework. So, hindi ko na ano yan. So again, ito yung mga mobility. We are member of the ASEAN Qualification Reference Framework. Member po tayo nitong mga CMEO, ASEAN Quality yan. So mga member tayo niya mga yan. Kaya kailangan masunod natin yung mga policy nila and guidelines so that once we go to New Zealand, we go to Canada, we go to other country na member nito, ay hindi tayo mahirapan. Kaya for example, Canada, there was a time na may estudyanteng nagpunta ron, nung tinignan yung transcript of records niya, nakakita yung evaluator ng algebra, declared kagad siya high school. Kasi sa Canada, algebra ay tinuturo sa high school. Kaya yung TOR niya, parang lumabas pang high school. Pero ano siya rito REE siya. So yung kanina. So with that, thank you very much. Ito po yung reference ko. Philippine Constitution, Philippine Qualification Framework by Dr. Reynaldo Bea, Chairperson, by Dr. Cynthia Rose Banson Bautista from UP, and of course yung ASEAN Qualification Framework and the National Qualification Framework na sinishare ko sa inyo. So with that, maraming salamat and magandang hapon po sa inyo.
Okay, thank you, Sir Lyndon, for sharing that information. Yeah, it really supports what was discussed by Honorable Mendoza, and this information will really encourage our electrical practitioner for this framework of the Philippine qualifications, so that if they will go to other countries or perhaps they want to elevate their education and profession, so this will be the guidelines. So thank you for that, BP Lyndon. So at this juncture, yes, sir. At this juncture, we will award the certificate of appreciation. This IIEE Cebu chapter awards the certificate of appreciation for the technical resource speaker on the topic Republic Act 10968, the Philippine Qualification Framework in the 20th Eastern and Central Visayas Virtual Regional Conference. Given this 18th day of September, signed by the IIE Cebu President Mario Tabanyag, Regional Governor Felipe Niliama, VP Technical Luel Ratilia, Technical Consultant Advisor Brian Pasilan. Ladies and gentlemen, a warm of applause. The certificate is awarded to Engineer Lyndon R. Baggy. Maraming salamat po, sir.
Thank you.
Kita tayo sa susunod. Okay. So, let's proceed. So, Governor na naman yung next speaker natin. Okay, so hopefully ready na si Gob, no? Collado? Yeah. Our next topic is about Republic Act 7920. Sorry, National Treasurer ka na pala. Kasi hindi na ako na-update yata. Sorry talaga. Yung next topic is the Republic Act 7920, Awareness and Implementation. This will be handled by our National Treasurer. She's also the Operation Manager of Ideal Industrial Solutions Incorporated. Ladies and gentlemen, please help me welcome Engineer Esperanza Agarao Collado. Ma'am, so...
Yes. Yes.
So, ang pinakamayaman sa sa organization natin kasi siya yung National Treasurer.
Hindi naman
Sige
po.
ma'am.
Pera ng organization natin yon. Again, good afternoon everyone. Yes.
Good afternoon.
Hindi ko makita kung sino pa yung mga andito. Can you see my screen now?
Yes po.
Okay. Thank you very much. Thank you.
2020 po, 2020.
Yan, 7920. Baka iba nakikita mo, sir. 7920 nakasulat.
2020 po, ma'am, meaning vision. Very
okay.
clear.
It's very clear. I thought what you could see from my screen is 2020. That's why baka iba yung nakikita nyo at hindi yung screen ko. Okay. Again, thank you for that introduction, sir. Good afternoon, everyone. Good afternoon, Gov Eping, Sir Brian. Who else is here with you now? Si Pres, andyan ba siya? Nakita ko si Marlo eh. Hi, Marlo. Good afternoon. Yeah. Ngiti-ngiti ka dyan eh, no? Hi, Sir Jules. Diyos ko, dito yung BEE natin, former BEE. Parang nahiya naman na ako. nakita ko yung pangalan niya. Sir, good afternoon, everyone. Good afternoon, Sir Jules. Good afternoon po sa inyo. I'll be discussing now RA 7920, the new electrical engineering law, in which we should be all aware kasi before we graduate sa BSEE, meron po tayong subject ng electrical engineering law. Maybe this is just a refresher for all of us kasi siyempre pag ng students tayo, we don't concentrate too much on the laws. Tinutulugan natin ang subjects na to kasama ang contracts and obligations. Okay? But I will be more dealing on Article 4, Section 33, yung personnel required. It is for the protection of lives and properties. Okay? Pasensya na tayo. Bakit ayaw na mag-share ng screen ko? Yan. Sa IIEE is the solely accredited professional organization for electrical practitioners. This is for APO 016, founded in 1975 po ang IIEE. We just celebrated our 46th year anniversary. So when we say electrical professionals or practitioners, we are referring to the professional electrical engineers, the registered electrical engineers, and the registered master electricians. Okay. So our committee, in which I am the advisor, yung RA 7920 Compliance Assessment and Monitoring Committee, we only have this mandate to ascertain compliance to the rules, provisions, and standards explicitly provided for by RA 7920 and for related purposes. Ang objective lang po ng aming committee, which is to implement Section 33 of RA 7920. Article 4, Section 33 ng 7920. So ano po yung mga gagawin namin? Provide awareness program dissemination to stakeholders, evaluate and control the success of the campaign. Dissemination po talaga kami, provide database for monitoring and evaluation of complying establishments. And we have to study the profile of establishments kasi as per record, the number of establishments and the number of electrical practitioners would not be enough to employ these people for employment sa ating number of establishments. Kulang na kulang daw po tayo ng mga electrical practitioners, especially mga PEE. Okay. So Republic Act 7920, ang third regular session nila noong 1994. And it was signed noong February 24, 1995. Nasa 26th year na rin po to. Okay? So the Republic Act 7920 says that it is an act providing for a more responsive and comprehensive regulation for the practice, licensing, and registration of electrical engineers and electricians. So ilang years na po yung batas natin to, na-repeal ang 184, pinalitan po ng 7920. So as I've said, we will be more dealing on the Section 33 of Article 4, which is the personnel required. Except as otherwise provided in this Act, every electrical plant, industrial plant or factory, commercial establishment, institutional building, watercraft, electric locomotive, or in any other installation where persons and properties are exposed to electrical hazards shall not have less than the following complement of professional electrical engineer, registered electrical engineer, and registered master electricians. Okay. In electrical plants, establishments, industrial plants, factories, any establishments with a capacity greater than 500 kilovolt ampere and 600 volt, there must be one PEE or REE. For 500 kVA and 600 volt below, ang kailangan po natin is 1 RME. So may mga tanong po kasi na dapat yung 500 kVA ba PEE lang or REE? Either of the two po, kasi I just wanted to inform everyone the only difference of PEE and REE sa sign and seal of design plans. Okay? So in the practice po, it's either PEE or REE ang pwedeng i-employ. As a consultant, pwede ring PEE or REE po sa kanila ang pwedeng kunin. Difference ulit, inuulit ko, sa sign and seal lang po, hindi pwede si REE. Okay. And also, the employment of an electrical practitioner is not applicable to any installation which has a capacity of 50 kVA and 250 volt or less. Maintenance and repair must be done by a registered personnel, and there must be a yearly inspection and certification of safe operating condition by an PEE or REE or RME. So certification yearly lang po, just to ensure. It is just an assurance that it is being inspected po by a professional, that it is free from any hazards, fire-causing hazards po. Okay? So anong additional qualified personnel? When we have a 24-hour operation, every shift dapat po meron tayong electrical practitioner. Okay? Every shift of the 24-hour operation, for example po, hotels and hospitals. This must be manned by a licensed electrical practitioner as per law, per shift. Okay? Then we have the Board of Electrical Engineering Board Resolution number 12 series of 2000. It is stated here that the IEE is being authorized by the PRC BEE to render assistance to the Board of BEE of Electrical Engineering in the performance of its functions. It is stated in our RA 7920 Article 2, Section 4G of the new Electrical Engineering Law that we can render assistance to the BEE with regards to their functions. As we know, currently, we only have two individuals manning our board, si Sir FVM, the chairman, saka si Sir Jaime, the member, dalawa lang. So they cannot do the job. So ito po, nakalagay sa Article 2, Section 4G, Powers and Duties of the Board. They have to look into the conditions affecting the practice of the electrical engineering profession, adopt measures for the enhancement of the profession, and the maintenance of high professional, technical, and ethical standards, and conduct ocular inspection of places where registrants practice their profession, such as but not limited to, as mentioned a while ago, electric plants, substations, industrial plants, factories, commercial establishments, mga schools, watercrafts, electric locomotives, engineering offices, mga repair shops, and similar places to determine and enforce compliance with RA 7920. The board shall authorize the duly integrated and accredited Electrical Engineering Association. That's why nagkaroon po tayo ng Board Resolution number 12 in order for us to render assistance to the Board of Electrical Engineering. But not all can render assistance to the board. Okay? So it is stated in this Board Resolution number 12 series of 2000, nakalagay po sa wherefore natin. The board resolve as it hereby resolves to authorize IIEE to render assistance to the board in the performance of its functions under Section 4G of the new Electrical Engineering Law in accordance with the following guidelines. So, na-name lang po dito sa board resolution who are the individuals who can assist the BEE. Because not every electrical practitioner can assist the BEE pagdating po sa inspection. Meron pong naka-name lang dito, very specific. The following shall be qualified to be deputized to render assistance to the board to perform its functions under Section 4G of the new Electrical Engineering Law. Sino lang ba ang mga individuals na to? The incumbent national officers of IIEE, when we are talking this year, kung sino po yung incumbent from Natpres Alan down to the auditor. Okay? Who else? The incumbent regional governors of the IIEE. So you should know in your area who are the governors sa mga areas ninyo. Okay? You should be aware. Yung past national presidents of the past 3 years, pwede sila. The immediate and incumbent president chapters of IIEE, pwede rin po sila. The board shall create teams of 3 members, each to be constituted as follows. The incumbent national officer of IIEE, or in the absence of a national officer, a former president of IIEE, or a regional governor of IIEE as the team leader. Okay, so there will be 2 incumbent presidents of the chapter of IIEE as members. The chairman of the board shall appoint the 3 members of a team for a term of 1 year. Bakit po? Kasi po yung term po ng mga officers from national down to chapters is good for 1 year lang. Okay? The place of assignment of the team shall be designated in the deputization, preferably in the area of the chapter to which the 2 members of the team belong. Okay. The chairman of the team shall far as possible be a resident within the chapter where the plants to be inspected are located. Para maging aware po kayo dun sa jurisdiction ninyo, alam ninyo paano yung operations ng mga establishments doon. It's really needed na manggagaling doon sa jurisdiction ninyo yung mag-i-inspect, okay? The team shall not announce in advance their arrival in the plants to be inspected. So here in number 6 po, we were advised by our chairman, si Sir Francis, that hindi naman natin pwedeng gawin ito ng pabigla-bigla. Kasi wala naman po tayong police power, so maybe we could do it in a friendly manner. Hindi naman yung friendly you know what I mean na friendly, as in we are just being courteous lang sa pag-attend to them if we will have our inspection. Kasi sometimes there are members or professionals na porke nakita na may violation ng isang establishments, parang nagiging iba na rin po yung dating natin. So ang gawin natin para at least it's been years itong ating batas na to, hindi pa natin napa-implement. So it really takes time. So ang gawin lang natin, we have to inform them na magkakaroon po ng inspection. The team shall render a report and their inspection together with their evaluation and recommendation. After the inspection, after talking to the HR, kung nag-comply ba sila sa Section 33 of Article 4 or tinitingnan ninyo yung mga gamit nila, magbibigay po kayo ng mga recommendations. There will be a form that it would be filled out para at least makita kasi magbibigay ng recommendation. Okay? So, there are other establishments that they don't know the existence of RA 7920. Sometimes there are electrical engineerings in those establishments based on experience that they forgot everything about 7920, especially Section 33. Ito po, we were able to submit the plans to be visited to PRC and is still awaiting for the approval ng mga plans that we intend to visit. As you remember, guys, the committee requested from every chapter a list of establishments that they would want to visit in their jurisdiction, and it has been submitted to the Board of Electrical Engineering for their approval. So we are still waiting for the approval kasi parang in-approve naman na nila yung virtual na inspection. But I think it would be very difficult for us to do a virtual inspection because we will still have to schedule an appointment with these people. So nagkakaroon ng difficulty. So let's just wait for the approval of what we had submitted, okay? And the report of the team should be factual and unbiased. So I would like to remind everyone na sana when we visit establishments or any other factories or other buildings with their compliance to 7920, sana walang conflict of interest. Kasi sometimes people do visit these establishments because they wanted to have business with them. Parang ang nangyayari, as per experience, na i-relay din naman sa amin, na may mga nangyayaring ganon na parang tinatakot yung establishment so that mag-comply siya and then ipapagawa parang ganon dun sa mga tao na nagvi-visit sa kanila. Yun na po kasi pumapasok ngayon yung ating difficulty rin that sometimes people from these establishments would not allow us to have a meeting or have an appointment with them because of these reasons. So sana we would indicate our objective most of the time if we would want to visit establishments regarding their compliance, na kung ano yung objective lang natin, state natin. Let's just dwell on that objective, okay? So, kaya nakalagay dyan sa number 8, sana walang unbiased para walang conflict of interest. Number 9, the written report signed by the team leader and the members shall as far as practicable contain the following. As I've mentioned again a while ago, meron po tayong forms dito. Meron pong forms downloadable from prc.gov.ph para at least andun lahat yung mga information that would be needed doon sa isasubmit natin, okay? Kasama nung report or recommendation based on our inspection. The name of the company, the firm of the corporation, the place of business, the type of business, It's either single or partnership or corporation, the nature of the business and machineries installed, yung capacity nila, and the number of employees. Dapat nakasulat doon. Kung ilang electrical practitioners ang nagmaman doon sa kanilang kumpanya. Okay? So ano yung condition ng plant and machineries when you did your inspection? And others that deemed necessary for you to report to the Board of Electrical Engineering. So magkakaroon na evaluation and recommendation. It should be the chapter, okay? Yung chapter ngayon ang magre-recommend. It's not the individuals o member ng team. Sila ang nag-inspect, but it would be the chapter who would do the recommendation, okay? So this resolution has taken effect last 10th day of February 2000 pa. So 21 years na po yung board resolution na to. And I think Sir Francis also, nagda-draft sila ng ibang new resolution so that maging timely siya ngayon na dito para sa pandemic natin. And we don't know yet tungkol sa kwan neto, no? Pero napag-usapan kasi last year pa, kaya lang may pandemic, so hindi na natuloy yung usapan for a new board resolution. But then we will expect when the pandemic is over, sana everything would go back to normal para at least mapa-implement natin ang Section 33 of 7920 with the help of this board resolution. Okay. So as I've mentioned again a while ago, the limitation of practice of PEE, RME, and REE for the application of electrical compliance naman ng plants, industrial factories, and commercial establishments. So a while ago, PE and REE, 500 RME, 500 below, RME 500 above, it would be PEE or REE. So again, inuulit ko, between PEE and RME, the only difference is yung sign and seal lang po. Okay. So posting of certificates. Dito sa section 33 of 7920, it says there yung personnel required. Okay. So when you have the personnel in those establishments already, ibig sabihin, they are licensed electrical professionals. So they have a certificate of registration. If you could observe when you go to hospitals, when you go to doctors, so dentists, sa mga medical laboratories, that if you observe, nakapost po doon yung certificate of registration ng mga professionals attending to you. Ano po, bakit po yun? Para ina-assure po yung mga pasyente sa mga hospitals na yung taong nag-a-attend sa kanila, attending to them are professionals and they know what they are doing. So para magkaroon po tayo ng peace of mind that they are professionals, they are aware of what they're doing, ibig sabihin we are in good hands. It's also the same with the posting of certificates sa mga establishments. Ibig sabihin that establishment, when you see a compliance certificate, ibig sabihin din that establishment is being manned by a licensed electrical practitioner. Ibig sabihin lahat ng papasok doon o lahat ng empleyado doon ay assured po sila, may peace of mind na they are well taken care of. Why? It is a licensed professional ang nag-ooperate at nagmaman ng establishment. Ibig sabihin na ensure sila sa electrical safety. Okay? Sa lahat kasi yun ang sinasabi, ang cause of fire palagi is due to electrical reasons. So para hindi po tayo masabihan na walang magaling na electrical engineer sa Pilipinas, kasi 90% yata ng sunog ay dahil sa electricity, kailangan po nating maging compliant. It's not just for our colleagues to be employed, but also it would be assurance for the safety of lives and properties. Yes, sabihin na natin kahit naka-insure naman lahat ng establishments, but then it's still different when you start from scratch. Okay? So papalitan lang ulit ng money, they would pay you. Pero pag uumpisa ulit sa ground, magpapatayo and everything. So it's a different thing yung nasabing insured siya o yung talagang na-ensure yung safety ng property. It's not just the properties but also, of course, ang importante dyan, yung lives ng people inside those establishments. Okay? So yun po, kaya kailangan natin mag-post ng certificates as stated in Section 36 of Article 4. The owner, manager, or the person in charge of an electric plant, industrial plant, or factory, commercial establishment, institutional building, watercraft, or electric locomotive shall post or cause to be posted in a conspicuous place within such plant or establishment the certificate of registration of the engineers or electricians employed in such plant or establishment in a frame protected by transparent glass of equivalency. Very specific sila. Dapat naka-frame daw. Tapos may transparent glass para makita. And it should be posted in a conspicuous place. Usually, andun sa bulletin board when you enter the establishments, nakapost yung ating certificate of compliance together with the certificate of registrations ng mga licensed electrical practitioners natin. Okay? So this is now the process para sa application ng Certificate of Electrical Personnel Compliance. Okay. The first one, since it's pandemic, you could easily download the forms. Okay? Andun po yung forms sa Standards and Inspection Division counter. Or ma-download nyo sa www.prc.gov.ph. Then after that, fill out the form, secure the form in long folder with fastener, notarize po dapat ang Form 3 and 4. And then you have to attach copies of the professional license ID, yung PTR ng personnel, at saka yung endorsement letter from the chapter. Okay? So na lahat yon nasa inside ng long folder kasama ng 1 brown envelope and 1 documentary stamp. Bakit may documentary stamp? Yung documentary stamp po ilalagay doon sa Certificate of Compliance once all the requirements have been submitted and it has been approved by the PRC, lalagyan na po ng documentary stamp yung ating document, yung Certificate of Compliance. The next step, you have to proceed to the Standards and Inspection Division or in the nearest regional office for assessment and evaluation. They still have to evaluate the documents that you submitted as to completeness of the documents. Ano po? And then you have to prepare 2,000 pesos as fee. This is good for 3 years na po. Okay? Yung 2,000 that you will be paying PRC is already good for 3 years. So sa 2,000 na lang yan, na-ensure nyo na yung public na your establishment is electrically safe. So magkano lang yan yearly. And this would be shouldered by the owner ng company. Okay? So then after submitting that and paid for the prescribed fee, you have to wait for the notice of approval via postal mail. Okay? Yung tinatawag nating snail mail. Okay? From the PRC SID. Then upon approval, the certificate of compliance must be claimed by the electrical professional. Okay? If not, dapat may hawak siyang special power of attorney kung sino man yung magka-claim. Together with a valid ID. So that maibigay ng PRC. If not, if you don't have an SPA, it would not be released to you. Okay? Authorization letter is not enough. It should be with an SPA. Okay. And the certificate of compliance and the certificate of registration of the electrical personnel is now be posted doon sa lugar where people usually pass. Sa pagpasok mo, andun po nakapost lahat. Okay. I was not able to get a sample from PESA sa Cebu, sa Mactan, kay Gov. Eping. napakita doon sa kanilang company kasi this year in-ensure ni GovEPing na Section 33 compliant na sila. So, nakapost doon sa bulletin board nila yung mga certificate of registration ng ating licensed electrical practitioners kasama yung certificate of compliance. So this is just in wordings yung process natin. Ito po yung example ng Form 1. It's just a checklist and you can download this from the PRC website. Makikita nyo. Checklist lang po to kung ano ang needed na documents to be submitted in order for you to have a certificate of electrical personnel compliance. Okay? So ito naman po ang Form 2, yung process and action sheet. You will just fill out this form and ilagay ninyo yung mga informations being asked. Nakalagay dyan kung anong type ng service load natin, ilan yung capacity, connected loads, and everything so that the PRC can evaluate it. Kung ilan yung mga practitioners din na nagmaman doon sa operations ng ating establishment. So it is all in this form. All you need to know, fill it out. Okay? So information sheet din ng form number 3. 2 entries I've mentioned must be notarized. Don't forget. So andyan din nakalagay lahat. It's just the same. Nakalagay lang dyan on electrical personnel naman doon na nagsusupply sa firm, okay, ng power. All statements made in this form are under oath. Kaya sabi ko, dapat ito is naka-notarize. So this is an example of affidavit of the personnel, of the electrical practitioner. Okay? Dito, kaya it's the responsibility that we have being a professional ay masyado pong malaki. So it's not just passing the board exam and having an ID is already enough. Okay? So for every professional, especially electrical professionals, we have a very, very great responsibility. Sabi nga nila, great power comes great responsibility. Kasi if we are manning yung operations ng isang establishment, we have to ensure that it is electrically safe. So yung nag-take tayo ng board exam, binigyan tayo ng lisensya ng PRC just to ensure na these professionals are doing their job. As a professional, we have to perform our duty. Kaya nga kapag tayo ay pumalpak, kapag tayo ay nagpabaya, tinatanggalan tayo, nare-revoke ang ating license. That's why we are very careful in attending to our responsibilities if it is within the bounds of law para at least hindi po tayo matanggalan ng lisensya na panaghirapan natin mag-aral ng 5 taon at mag-review ng ilang buwan para kumuha ng exam at an instant sa simpleng kapalpakan lang, sa simpleng negligence lang, matatanggalan tayo ng lisensya and it should not happen kasi magsasubmit po tayo ng affidavit. Nakalagay po dito sa affidavit na to ang inyong pangalan, ang lisensya ninyo, kailan ang validity, that you have the responsibility in taking care sa electrical side ng inyong establishment. Okay? So, RA 8981, it is the PRC Modernization Act of 2000, stated in Section 9B. Ito rin po, it's a new law after ng 7920, powers, functions, and responsibilities of the various professional regulatory boards para naka-align lang po. No? The various professional regulatory boards shall retain the following powers, functions, and responsibilities as stated in Republic Act 7920. Okay? So walang nabago, to regulate the practice of the profession in accordance with the provisions of RA 7920, to monitor the conditions affecting the practice of the profession, in our case, the electrical engineering profession, under the respective jurisdictions, and whenever necessary, adopt such measures as may be deemed proper for the enhancement of the profession or occupation and or the maintenance of high professional ethical and technical standards. And for this purpose, the members of the board duly authorized by the commission with deputized employees of the commission may conduct ocular inspection in industrial, mechanical, electrical, chemical plants, establishment, hospitals, clinics, laboratories, testing facilities, mines and quarries, other engineering facilities, and in the case of a school, it must be coordinated with the Commission on Higher Education. Okay, to hear and investigate cases arising from the violation of the respective laws, in our case 7920, the rules and regulations promulgated hereunder and their code of ethics, and for this purpose may issue summons sub pena and sub pena duces tecum. Okay, so na-emphasize po dito again yung 7920 nung nag-release ng Republic Act, yung PRC Modernization Act of 2000. So this is an example of PRC, yung mga license, meron tayo neto. Not everybody has the PTR, yung professional tax receipt. You could get this every start of the year doon sa municipality or city where you belong. And it's an example of the recommendation letter from the inspection team, yung IIEE chapter in this case. Naka-address po sa PRC yan. It must be signed by the inspection team members. Okay? So example ng annual certificate of electrical inspection. This can be done by electrical professionals, yung mga establishments 50 kVA below. Magbibigay na lang po kayo ng annual certificate of electrical inspection. Mag-inspect lang kayo and maybe you could charge a minimum amount depending na rin kung sino yung magpapa-inspect sa inyo. It's just to give them assurance na meron talagang licensed electrical practitioner who inspected yung premises nila and na-ensure everybody na talagang electrically safe, and this would be submitted to the OBO of the city or municipality kung saan yung establishment. Okay? So this is an example also ng form, okay, na pag matatanggap nyo na yung certificate of compliance, notice of approval po coming from PRC. In this case, ang nakasign dito si Sir Rodi Peñalosa pa. Okay? So, ang certificate of compliance, as I've said, is good for 3 years. Yan. So, ito po yung ating galing sa Board of Electrical Engineering, yung nakasulat po dyan, yung ating certificate of registration ng isang professional. Everybody has this, yung mga licensed electrical professionals. You have this copy. It is being issued every time na kukunin na natin yung ating lisensya sa PRC for the new passers of REE and RME. You would be having this. You will request this, and after your oath taking, you can go to PRC. Kukunin nyo na yung ID ninyo at saka certificate of registrations. For those individuals na nawala na sa tagal na at hindi alam na itago, you could still request sa PRC a copy of your certificate of registration. Okay? So dati nakasulat pa dyan yung, tingnan nyo, may ballpen o pencil pa dyan, yung rating ng individual na to. Pero makwan na siya eh. Blurred na dito. Kasi sa case ko, meron naka-pencil siya na rating nakasulat doon sa certificate of registration ko. Okay. So this is a sample certificate of electrical personnel compliance issued by PRC. Ganito po ang itsura ng ipopost ninyo sa inyong mga establishments. It is written there yung validity ng certificate of compliance. Again, as I've mentioned earlier, 3 years po ang certificate of compliance natin. If the validity, just in this example, 2013 to 2016, in case 2016 is not written, count from the day that it was approved. Okay? So in this case, April 22, 2013. So you count 3 years hanggang April 2016 ang validity niya. Kasi there are certificates na hindi na po nakasulat hanggang kailan yung validity. So you will just check the date it has been released to you. Okay? And for the implementation of 7920, sabi nga natin, ang tagal-tagal na ng batas natin, but still, it is not being implemented nationwide yet. There are some difficulties being faced by the government agencies or other private establishments. What you could do, guys, para to help our profession, you could seek an accreditation by the local government, especially yung sa vice mayor kasi siyang may hawak ng mga sangguniang bayan, magkakaroon lang ng ordinance. In the case of San Pablo City here in Laguna, even we all know that it's already a law, Republic Act 7920, but still it's not being implemented fully. So what we could do to expedite the implementation, mag-start tayo sa isang maliit lang na area. Let's say sa isang city or municipality, you could talk to the vice mayor handling the sangguniang bayan. Or if you know someone from the mga councilors, pwede po sila ngayon dyan, pwede nyo silang pakiusapan na mag-sponsor po ng ordinance for the implementation of RA 7920, especially yung Section 33. Okay? That is one option. Okay? So we have to reiterate lang sa ating mga building officials na talagang kailangan talaga ang compliance natin dito, lalo na it is a national law. Kaya lang nga, sabi ko, ang hirap magpa-implement usually sa mga local governments kasi lagi nilang sinasabi, maliit lang sila, maliit ang era nila, so walang pwesto. Okay? So, walang plantilla for them. But then, depende pa rin sa political will. Sabi ko nga rin, depende pa rin sa politicians sitting in that municipality or city kung talagang they really wanted to. Kasi from experience again, we were able to talk to a mayor, lawyer pa siya, ang sagot niya sa amin, sa tagal na ng batas na yan, hindi pa na-i-implement mula noon, ngayon pa kaya. So sometimes it's very frustrating to face these people, but then wala tayong magawa. They are the people in power. But then with our perseverance, siguro mapapa-implement din natin pauunti-unti ang 7920 until such time na may darating ulit na batas, and I think the new law that would be approved for the electrical practitioners hindi rin naman kalayuan. So anong gusto nating mangyari, because our main objective in having this law is for the protection of lives and properties. Yun lang naman. Okay? Other way of having an ordinance from the city, pwede rin naman tulad, ito example ng ordinance ng San Pablo. They were able to have that since 2004 po. Nag-okay na ng January 3, 2005. Kaya lang yung ordinance na approved ng 2004. Okay? So aside from the ordinance, pwede rin pong gayahin ang ginawa ni Makati City. Okay? So ito po sa San Pablo. Ang ginawa ni Makati City po, they issued a memorandum to all building owners and building management and administrators that they have to comply with Section 33 of RA 7920. Ibig sabihin, for our colleagues to have a job at the same time to man these buildings para rin po naman mag-promote palagi ng safety ng properties and lives. It's not just having a job as engineers, as electricians, but we have the responsibility to take care of our community by ensuring yung safety ng bawat isa sa atin. So dito sa Makati City, they were able to do that. May memorandum. So we know na lahat ng establishment sa Makati City is being manned by a licensed electrical practitioner. So na-ensure tayo na safe mag-ikot sa Makati at pumasok sa mga building sa Makati. Kasi meron tayong kabaro doon na isang lisensyado na nagmaman doon sa building nila. Okay? So, again, sa Section 39, enforcement of the act by officers of the law. It shall be the duty of all constituted officers of the law of the national government, provincial, city, or municipal government, or any political subdivision thereof to prosecute any person violating the provisions of this act. The Secretary of Justice or his assistant shall act as the legal advisor of the board and render such legal assistance as may be necessary in carrying out the provisions of this act. Okay? So, ito po, nakalagay nga lang dyan, enforcement of the act. Ang pwedeng magreklamo po lahat ng nasa government. Okay? Kung sino yung nag-violate sa provisions of this act. Para hindi lang nagkatugma yung title niya dun sa loob na nakasulat. What's written there, yung nag-violate, any government officials, pwede po silang mag-prosecute o parang i-demanda yung mga nag-violate ng act na to. Okay? So parang sinasabi dyan, it has to be enforced or else these people can prosecute any person violating this 7920. Okay? So sa Section 40, since sabi ko nga, ang tagal-tagal na ng batas natin, alam nating lahat na ang tagal-tagal na niya, ang penalty lang po talaga is 10,000 and not more than 50,000. So for any non-compliance ng ating mga kababayan, it would be easy for them to pay for the penalty. Kasi napakababa lang ng penalty. So it's really about time for us na magkaroon ng panibagong batas para at least naman with the call of time natin, alam na natin kung ano yung dapat na pwedeng ipa-implement na mas grave ang magiging punishment sa mga hindi nagko-comply sa mga batas. But then, ganun talaga ang buhay. Okay? So this is the group of the RCAM na tinatawag namin. And I am the officer, the advisor of the group. Okay? So again, thank you very much for listening. And if you have any other questions or whatsoever, you may direct to the chairman kung sino yung in charge nitong moderator natin and maybe we could answer. Andyan naman si Sir Jules na tutulong sa akin. So thank you very much.
Okay, you're welcome and thank you very much, Engineer Collado. So it is really true, no, that 7920 has been there, but yet I will just try to do our best. Every year we have different chapter presidents and chapter officers, also with the national officers. But yet, there are lots of initiative in each chapter na successful sila sa pag-i-implement ng RA 7920. Hopefully, ma-duplicate natin yung mga initiatives nila. And we also pray, no, that yung mga politiko natin will support this electrical law natin as Republic Act 7920 because it is the objective for this is really to protect or to have public safety. So, yes yan. Merong isang question siguro pwede ma-entertain ni speaker natin.
Yes, sir. Yes.
Yes, Gubchi. This is Brian po, ma'am.
Hi, Sir Brian.
So we
yes,
have-
my
Yes.
partner in 7920.
Katuwang po, ma'am. Okay.
Yes.
Here's a question po, ma'am, from Engineer Alex Tabasa. Paano pag ang electrical engineer sa isang company ay may nakita na mali sa electrical system tapos ang top management ay walang action dahil nasa mababa lang ang posisyon ng electrical engineer? Ano daw ang dapat gawin po?
And then you have to document it, sir. Kasi we don't have to be blind kapag meron tayong nakitang pagkakamali. Kasi hindi rin naman tayo makakatulog sa gabi if everything happens to that establishment and we didn't do anything. Then may yung guilty conscience natin, ano. So I suggest pag mga ganyan kasi kahit sino, kahit anong pagkakamali, we have to call the attention and we have to gather data. We have to document it and elevate it to the higher ups. Doon po papasok ang PRC ngayon. Kasi hindi po tayo pwedeng magsabi sa PRC na puro salita lang. We should have proof kung ano yung mga violations na nagawa ng isang establishment or ng isang practitioner. There must be attached documents to prove that violation. Then you could raise it to the PRC. Marami pong, alam ko po, maraming letters na nakakarating sa PRC. Naging aware ako doon. And naa-actionan naman po nila. They are writing to the establishments kapag nakikita nila na based doon sa attached documents or proof, may violation, then our board can write such establishment po.
Tama po. Documentation talaga ang kailangan. This will protect the engineer and at the same time the company and the profession. Kasi kung hindi na document yun tapos merong disgrasya, ganun pa rin. Siya pa rin mananagot tapos siya pa rin ang malalagot.
Yeah, that's why kailangan talagang i-document natin lahat kasi it's not for us also. Kasi kapag may nangyaring accident, yes, we will be answerable because we are the practitioner manning that establishment. But kung walang ginawa ang ating may-ari, kasi syempre karamihan ng mga may-ari, business yan, kita, ayaw mawalan ng anong tawag doon, ng profit. But then, if I were the electrical practitioner, I can elevate this to the PRC.
Okay, so noted
kung
yun.
professional po
Hopefully,
yung pinag-uusapan, yung professional natin nakasama doon. Kasi it would be his license which at stake po eh. Pero bakit kaya nagkakaroon ng violation, sir? Meron naman pong inspection ang OBO. Nagkakandak naman po ng inspection.
Totoo, pero hindi makakover ng OBO. As experience namin dito sa Cebu, hindi talaga makakover. But at least kung merong awareness, no, sa yung practitioner natin at saka yung management sana, so sana makakomply sila. Yun lang ang talagang importante. Kasi diplomasya lang talaga ang gagawin natin para makapag-implement tayo dito sa
Wala po tayong police powers kasi eh. Yeah, diplomasya talaga. Kaya nga importante po yung information dissemination kasi palaging sinasabi ng majority of the establishments, they are not aware of the existence of RA 7920. That's why hinihiling ko sa mga kasamahan natin, mga colleagues natin, kailangan po talaga ng information campaign para at least maging aware ang bawat isa sa atin, may karoon ng responsibility kasi mahirap po yan magtuturoan at the end kapag may aksidente nang nangyari. Konsensya na natin ang makakalaban natin.
Instead of CDO, cease and desist order, this is a police power, maybe ang gawin natin ICE, information, education, and communication. So ito ang dapat initiative sa ating chapter. So salamat po talaga, Madam or Engineer Collado, for sharing with us this important law for electrical law for all the practitioners. So at this juncture, wala nang question and answer. Yung ibang may question and answer, you can put that in our question and answer box. Yeah.
You could just message me na lang. May time naman
Tama.
ako sumagot. Yan. Or you could
Okay,
direct
sige.
it to Sir Brian. And Sir Brian is a member of the RA 7920 committee. So we could discuss this po.
Okay po. So at this juncture, we will award this certificate of appreciation to our technical resource speaker on the topic Republic Act 7920, Awareness and Implementation. And this in the 20th Eastern Central Visayas Virtual Regional Conference via Zoom, given this 18th day of September 2021, signed by IIE Cebu Chapter President Mario Tabanyag, Regional Governor Felipe Niliama, VP Technical Affairs Lowell Ratilia, Technical Consultant and Advisor Brian Pasilan. The certificate of appreciation is awarded to or presented to Engineer Esperanza Il Agarao Collado. A round of applause and thank you very much, ma'am.
Thank you very much for the
Okay.
invitation, Cebu chapter. Congratulations on your very successful conference. And thank you. Hi, everyone. God bless. Stay safe.
You're welcome and likewise. So let's proceed. Ito, maganda na ito kasi another gold sponsor natin. Technical sponsored presentation. So 3M.
Yan. Good afternoon, sir.
Okay, good afternoon. So,
Yan. Bilisan na natin
sir.
to. Mag-share lang
sige.
ako ng try natin, sir.
Para marami pa rin bibili sa atin, sir. Sige, go. You can take the floor. Okay. You may proceed.
Nakita na ba yung kwan ko, sir? Yung slides ko? Medium voltage power cable accessories.
Yes, sir. Kita.
Sige, by the way,
2020 yan, sir.
2020. 2021 ako, sir. Anyway, itong slides namin has been used since 2018, no? When we campaigned for the medium voltage splicings and termination. Tamang-tama 'yon, medyo nakakatakot yung ang ganda ng sequence, ano? Yung Republic Act ni Govche. And then ito is one of the sabihin natin na iwanan ng industry na pansinin. Ngayon lang to papansinin nyo dahil kay Harmonix. Okay? So we will run through this one, a quick one. No? For those who are interested for more details of this training, we can do this also for the chapters for free. No? We have a platform for MS Team wherein we try to support the IIE through this platform. Kaya minsan kasi busy ang Zoom natin. So, sino ba si 3M? Yan. Nang nasa kabataan pa tayo, no? Madalas maririnig 3M. Yan, matandang mayaman. Pero hindi po yun. No? So, nandiyan ang picture namin. It's a very old, a century-old company from Minnesota. So, it's a mining company and manufacturing. So mahaba-haba na rin ang history niya, and then sa Pilipinas 5 decades na po kami dito. So mga the 3M is ang pinaka-core talaga ng group namin is more into material science. Okay, sa lower left ninyo nakikita nyo yung first team namin sa Manila, ang first office niya Manila Hotel. O black and white pa yan, sir. Ha? Mga lolo pa siguro nato ng naadya, no? So, 3M, as a worldwide company, is having a sales. 30% of our sales is coming in from the technology or innovation that was developed for the last 5 years. So, mga bago pala yon. So, if and only if, no? if we are going to invite you, sabi nga kanina ng isang speaker natin, employer. Si Sir Baggy pala yun. Word is Sir Baggy, employer. So yung, if you have children o sa mga member na inclination is into science, research, and development, we highly recommend 3M. Kita mo naman, investment namin is billions of dollars, no? Ganun sa kalalim ang science ng 3M. So, paano ba namin ginagawa yon? So, normally we have a lot of patented, no, materials and process. Dalawa, material and the processing. So, around 100,000 of that, no? And then, of course, ano gagawin ng patent mo kung hindi mo naman gagamitin? And this comes in yung mga qualified natin na mga scientists. Yan, mga engineers, marami kami doon. And that is to address the applications. On the business side, ito po yung nangyayari, yung technologies namin, platform, and then we look for the insights, ano bang kailangan ng current na customers natin. For example, doon sa adhesive, nabigat masyado yung eroplano, so we reduce the weight. So yung wings niya ngayon, nilalagyan na lang natin ng double-sided. So pag nagbukas na ngayon yung natin, yung pandemic natin, pwede na tayong mag-travel. So silip-silipin natin. Bakit nawala yung mga rivets doon sa pakpak ng eroplano? So those are the science behind. Of course, the people and the culture that we have in 3M. So ganun na si 3M. We divided the group into 4. We have the safety and industrial where we belong. Yan. Si N95, nandito din yon. Okay, kung minsan nasa mga safety officers natin, yung mga practitioner professionals, maririnig natin sa TV, they cannot differentiate what is the mask and a respirator. Sabi nila N95. So kung gusto yung mga ganung topic, we have that team, dedicated team for that safety. But we as electrical, we belong also to the safety and industrial. Sa transportation, ito sikat to sa mga young guns natin, lalo na yung mahilig sa tint, no? Yan. We are the innovator of that tint. Okay? Sa healthcare naman, ano bang meron si 3M na madali kong ma-relate? Ito, relate natin to, no? Lalo na yun sa mga leaders natin, kasi makikita ko may isa tayong mga leader, dahil hindi lang isa, maraming leaders ng mga doctor, nurses na yung anak nila. Yung stethoscope, no? We are the innovator for that. Litman ang brand namin. So sigurado ako pag bumili ka niyan at binigay mo sa anak mo o sa mga mahal mo sa buhay, masayang-masaya sila. So that belongs to our group. Okay? And then the consumer group. Ano bang meron kami doon na maalala mo si 3M? Ito mga post-it. So meron nga kang kasabihan sa 3M na hindi ka lalayo ng 3 metro from us. Lagi mo kaming kasama. Biro mo yung 3 meters, no? So paano kayo nangyari yon? So example, cellphone. Yan. So we have 28 product lines ginamit sa cellphone mo. Not unless wala tayong cellphone, ano? Kaya 3 meters yun, no? So that is 3M. So when we concentrate on the electrical, okay, so what are the innovations? We try to do away with the word of inventions. We try to use the word innovations. We are the innovator, okay? We are the innovator of electrical vinyl tape. Yan. Minsan kasi nagsusurvey kami dito lalo na sa mga electrical natin. Ilang electrical tape ba yung kaya ng mga professional natin i-identify? Unfortunately, hindi malalagpas yun ng 3. So ngayon, hopefully, after a session natin, maalala natin yung generic na 5 electrical tapes. Take note, 5 electrical tapes na it is a must, lalo na sa maintenance repair operation, lalo na yung in charge sa 24/7 na establishment, laging handa. Kung ang doctor, nurses, we have the emergency kit, those electrical tape, 5 yon must be present always. Okay? So mamaya papasadahan natin yun. So when you talk about 3M, marami kami sa distributor, the business model of 3M is going through at partners. But if you would like to talk directly to the 3M, these are the people na madali mong mahagilap. So Mark Ang is my leader, me, Jericho, and then si Engineer Glenn Cambre. Nandiyan siya sa audience Supposedly siya yung magde-deliver ngayon. Kaya lang, as a terminations, as a specialist, on call, laging tinatawag. So biglang napapaluwas. So he is now covering the Asia. So hindi siya nakontento sa Pilipinas. Binigyan siya ng responsibility sa Southeast Asia. And then today, buong Asia na siya. Pero dugong Pilipino, kaya handang tumulong sa atin. Okay? So, teka, bakit ganon? So, medium voltage, sandali sir, mukhang papalitan ko lang yung pointer ko. Okay. So, medium voltage network. When you say about network, okay, this cannot be done without the terminations and joint. In relation to the regulations that we have, sabi nga, medyo matagalan yung mga politician natin gumawa. Dito sa Pilipinas, the job for terminations and splicing is hindi regulated. Wow, sad story. Sabi nga ni Sir Jun Lopez dati nang gumawa kami sa Bicol, bakit? Ganun talaga sir, nabutan natin na ganun yan. So kung we are going to work on for the lobby of regulation of this job, medyo mahaba-haba pa. So yun sa mga RME natin na balak magpapalaot sa ganitong skills, pag pumunta ka sa abroad, pumunta ka sa US, Middle East o sa Southeast Asia, you have to take a special license. Special license, special skill. Siyempre, ang rate natin doon, special din. Ganun siya ka-importante. Kasi yung network mo, the weakest link of the network, okay? We know the network from generation side, tinapon natin sa media o tinatawag natin transmission, and then from transmission, ibibigay natin sa DU, which is the distribution utility, hanggang maibibigay na natin sa customer. Sabi ng kanta ng IIEE, usable energy. Yan. So magagamit ng residential. Pag medyo malaki-laki yung customer, they are the commercial. Pag nagtumpok-tumpok yung mga commercial na yan, tinatawag natin na Central Business District. Ito yung IT, kung tawagin natin, IT Park, kung tawagin natin sa Cebu. O Ayala. Those are the example of Central Business District. So pagkikita mo yan, ang haba-haba pa lang na network na yon. And the weakest link is the termination and join. It is, and it is a must, supposedly, that this job will be regulated. But current, ito na ngayon eh. Kaya si IIEE, we work with the IIEE just to educate so that matutulungan natin yung industry natin to understand the weakest point of the network. Okay? So ito ngayon. So there are several standards, IEEE, CENELEC, IEC, VD, and so on and so forth. So depende kung anong gusto mong standard, but this is the standard that is being used in terminations and splicing. So kung hindi ka na kontento doon sa mga sikat, meron pa tayong iba. Okay? So the beauty of that, pwede natin silang cross-reference. Diba? So 15 years ago when I have my early training sa Southeast Asia, so mayroon akong trainer na isang Briton, hindi pala, US, no? Taga-US. So he talks, lalaki, he talks about IEEE. So yung audience namin is Southeast Asia. So mangingilan-ngilan lang ang makarelate. Okay? Because sa Southeast Asia, IEC ang lagi nilang pinapractice. So good for us, mga Filipino, this is one of the strength ng mga Pilipino. Hindi lang sa electrical, but sa field ng engineering. Kaya nating ihalo-halo. Para siyang halo-halo. Masarap pa rin ang resulta. Diba? So, ganun yon. Dito ka lang makikita sa Pilipinas, ang dulo ng kable mo, IEEE, dinugtungan ng IEC, nagtatapos sa GIS. The system is working well. Yun ang skills ng Pilipino. That is the advantage. Kung magiging ASEAN engineer na rin kayo. Okay? So, cross-references, alam na natin yan. So, according to the study, with the underground system, the failure, straight joint contribute around 52%. And then the next is yung terminations natin. Ang laki niya, no? So, ang root cause niyan, ito nakakatakot. Kasi yung risk management dito, mahirap to siya, no? Mahirap i-manage. So, doon ka na lang mag-root cost analysis tayo para doon natin ma-manage. So, ano yung manageable dito? So, makikita mo dito, workmanship. That is 40% of the contribution. So, ibig sabihin, kung mayroon kang termination job, 40% of that mag-fail because of workmanship. So, those are the things now we can addressable. Kasi, pag na-improve natin efficiency doon, may mga computation, si Sir Alan kahapon yata nun, nakakagulat. Simpleng engineer, kaya palang mag-contribute ng savings at 1.49 million. So, how much more kung hindi lang? Diba? Hindi lang ang motor ang na-address mo in terms of efficiency, but rather the whole system. Kasi isang failure nito, can you imagine, buong mall o buong hospital, walang ilaw. Kasi medium voltage pinag-usapan natin, di ba? So ganun yun, kalaki ang responsibilidad natin dito. Okay, so this is still the analytics when it comes to the underground system. So insulation, no, 57%. Ang laki ng risk na yan. So knowing the basic foundations of splicing and termination, we can address the risk. Ito yung sinusupervise natin kasi kung minsan ayaw natin humawak nito eh. Pag mag-engineer ka na, ayaw mo nang humawak ng mga termination. So ang gagawin mo na lang, supervision. Or kaya, you have to manage the project. Question is, sabi ko naman, sino bang minamanage mo? In leadership kasi, hindi natin minamanage ang tao. We are managing the result. And paano mo i-manage ang result kung hindi mo naman pala alam ang foundation noon? So here is the venue kung saan we are going to share the foundations of the terminations and splice. Okay? Yan, nangyayari after pumasa siya, no? Ang kwento nito, pumasa siya sa testing. After 2 years, bumigay si kuya. So after 2 years, siguro kung may condominium kang pinatayo, that is 80% occupant. What if mga 100, di ba? 100 condominium yun. 80 doon, walang ilaw. What if ang isa doon, isang engineer, nakakaintindi kung bakit nag-fail yung system mo. And sa post-mortem analysis, no? Sa post-mortem analysis kasi, bubuksan natin yan isa-isa at titingnan natin kung saan ang probable cause ng failure. What if napatunayan na yung job na yon is nag-fail because of workmanship? Tanungin si engineer, engineer, bakit mali ang sukat na to? Nako, marami yan. May case ako dyan sa Cebu, 2019, dyan sa Danao. Yan. Huwag nating banggitin yun kasi ayaw kasi makinig ni Kuya. At least, nang naputukan, nakinig na siya. Okay? So those are mga real thing. Kasi, minsan kasi yung terminations and splice, they are classified as the cable accessories. Siguro dati, ang naalaman lang natin, when it comes to connector, we know the crimping, no? Mga crimping connector. So mga pressure. But today, we have now the screw or mechanical connector. So nag-advance din ang technology. So let's talk about terminations. Termination, to have a connections on the medium voltage, papunta ng transformer. Madali lang yan. Kasi kung tinamaan na ng partial discharge, nagdi-discolor. Okay? Switchgear. Okay? Mahirap. Diba? Mahirap magluhod during PMS para silipin si switchgear. Okay? Para I personally advise kung may PMS kayo at makikita nyo, masisilip nyo yung termination sa ilalim ng switchgear kasi mahirap to silipin, silipin nyo na yan. Kasi tinatamaan yan lagi ng harmonics. Bakit? Si harmonics, pakialamero. Yan. Okay lang kung current harmonics, okay lang siya. Walang epekto yan. No? Hindi siya tatamaan. Pero pag voltage harmonics, nako, destructive yan. Sisilip-silipin mo na yan, ano? May mga discoloration yan. Dati sa routine yan, okay lang. Pero ngayon, it is a must na masisilip yan to maintain. So when you are now the supervisor of this job, o kaya gusto ko akong designer o kung may-ari, so ano yung ine-expect ko? So according to the standard, this is the job that you need to address. Electrical stress control, yung tracking, at saka yung seal. Tatlo lang po yan, no? So this is the stress control, yung tracking, at saka seal. No matter what the technology you are going to use. Ito po yung laging hahanapin ninyo. Paano ginagawa yon? Okay? Bakit electrical stress control? Ano ba talaga yung electrical stress control? So at 2.5, nagkakaroon na ng air breakdown. So kung hindi pala ito na-address, hindi ka lalagpas ng 2.5 kasi nasusunog mo na yung air, no? How much more kung 5 kV ka? Di walang mangyari. So you have to address that portion, yung electrical stress na yon. So saan na-locate yan? Kung saan pinaghihiwalay mo yung semicon at saka yung insulative material. Hopefully, we still recall yung component ng power cable natin. Okay? So may video yan. For those who would like to see the video, kinat ko ng video in the interest of time. Meron tayong virtual booth. No? Tingnan nyo doon, bisitahin nyo po kami doon. Marami tayong mga sponsor doon. Nag-aabang ng pagbibisita nyo. We allocated a numbers of t-shirt just to visit our booth and be registered. Yan. Pindot-pindot na lang, ano? May nandun si Nubem nag-aabang doon. So, kasali na rin yon ang iba nating mga sponsor na may virtual booth doon. Marami kami doon. Nag-aabang ng bisita nyo. Okay? So, this is the breakdown of the air kung saan naghihiwalay. Yan, namumuti na yan. And then, so ma-imagine mo sa loob ng kable mo nangyayari yan para ka may kidlat. So, to address that, meron kang choice. Pipili ka ba ng geometric, yung pinapaugbok mo yung portion na yon, o a-address ka lang ng refractive. So dalawa lang yon, pipili ka na at your discretion yon kung saan ka masaya. Okay? So tracking. Tapos na tayo doon, no? Sa stress control, pipili ka lang ng dalawa. Isa lang pipiliin mo. Sa tracking, ano ba yung tracking? Simple na nasisira na yung insulative material na nilagay mo. Okay? Bakit? Contamination, moisture, and voltage. So at the presence of that, nasisira to. So kailangan, ang gagawin kong insulative material is tinatawag natin na track resistance. Okay? Bakit? Ano nangyayari dyan? Ito kasi nangyayari sa taas live. So sa baba, zero. Inherent. Diba? Inherent sa electrical energy na gumagapang siya. Diba? Mahilig ba manggapang yan? Kuya, okay. So gagapang siya papunta sa zero. So habang gumagapang siya, ang ginagawa natin para matagal siya makarating doon, we increase the distance, no? The creepage distance. So marami tayong design. One of the design is lalagyan ko ng skirt. So at this portion, hindi na siya didiretso. Hindi siya maiksi ang biyahe. Aakyat, bababa siya. So na-increase natin. Okay? So those are the portion, mga design kung saan pwede natin magagamit para yung tracking natin, ma-minimize natin. Okay? So in science, ganito yung nangyayari niyan. Okay? Current, papasok, lalabas sa kwan. Pag yung material mo is hindi hydrophobic o hydrophobic siya. Sa hydrophobic, alam natin, ayaw natin ng tubig. Ayaw na ng tubig. No? Para kang first year college, ang bango-bango mo. Second year college, bango mo. Pag fifth year mo na, mahirap na maligo. Pag nagre-review ko na, ayaw na maligo. Panay aral. So iniwasan ng tubig. So iniiwasan natin yung tubig. Ganun din sa insulation material natin. Bakit? Pag dumiretso yung current mo, disgrasya tayo. Okay? So yung dry band, wet band, kanina na gagawa doon, so napuputol natin yung continuity ng pagtatrack ng item natin. So ganito na nangyayari yan, no? So tracking. So ito, live, papasok si diretso. Kung wala siyang skirt, diretso. So ang distance niya from the live papunta ng zero, ang bilis. Nilagyan mo ng creepage distance na may increase mo by using the skirt. Kung umulan, this is the wet band, and dry band. So meron tayong mga preventive, no? Mga design just to increase yung risk natin management dito sa live papunta doon sa zero. So this is the detail, no? May marami tayong material na tinatawag natin na track resistant. Nung una, sikat na sikat yung porcelana. Ngayon, silicone ang ginagamit natin. The third things that you have to manage during the terminations or splicing man is paglalagay mo ng silyo. Okay? Para hindi papasukin ng tubig. Siyempre, ito nakakabit sa taas and then ang moisture, kung umulan, papasok doon. So una, very common lang siya, yung dye, yung ipin, pangkagat natin. Okay, pangkagat natin ng mga lugs natin. Kung 20, 20 yung conductor mo, 20 din yung pangkagat mo. Huwag mong ipakagat ng mas maluwang. Sa field, anong ginagawa? Pag maluwang, okay, alam na, sir, nilalagyan namin ng pako kasi sabi ni engineer, mortal sin. Okay? Para masisilyo natin doon, you have to proper use the tools. Sa baba naman, dito ng termination natin, lalagyan din natin ng seal. No? Sisilyuhan din natin para hindi makapasok ang moisture. Okay? Bakit, sir? Pag umulan, galing sa baba, aakyat yan. Okay? Pag umakyat yung moisture na yun, papasok sa ilalim ng skirt, basa sa ilalim skirt, mangyayari at mangyayari. May mangyayari doon. Iwasan yan. Lagyan mo ng silyo. Sir naman, mapagbiro, umaakyat ba talaga yung ulan? Opo, dong. Sabi ng science teacher natin nung high school, due to the capillary effects which dictate that the moisture stands to travel doon sa surface tension natin, temperature change, ulan, init, energize, on, off, biyahe ang moisture. Dahan-dahan, gumagapang si kuya papunta sa ilalim ng skirt. So, you have to address that one by sealing the bottom of your terminations. Okay? So tatlo lang pala, no? Madali lang. So let's talk about mga present technology. Okay, sir, heat shrink yan. Meron bang 3M? Of course, meron kaming ganyan. Okay, we have a plant in India. But this is an old technology. Sa Pilipinas, we try to shy away from this one. Okay, heat shrink. Tatlong hahanapin natin. Ito yung component natin. Ano yung hinahanap natin? Una, nilagyan niya ng stress control. Anong ginamit niya? High K kasi diretso, hindi maugbok. Okay? Nag-apply siya ng apoy. Kailangan ba niya ng apoy? Hindi. Hindi niya kailangan ng apoy. Ang kailangan niya, ang init ng apoy para mag-shrink ang technology. So heat shrink, apply ka ng heat para mag-shrink. So kung wala siyang torch, di maghanap ka ng manghiram ka ng blower sa misis mo o ka na heat gun. Diba? Kung wala, sir, huwag ka mangontrata. Wala ka palang tools. Yun. Diba? Stress control. Go. Done. Seal. Nilagyan ko ng seal sa taas, sir. I have supervised that one. Check na rin yung seal sa baba. Anong purpose ng baba? Capillary effect, no? Na-address ko na. And then, I have used an insulator to address the tracking. So, done deal. So, okay? So, heat shrink technology. Yun lang po yun, tatlo lang. When you are trying to supervise terminations and splicing, take note of those three. Cold shrink, na absent, di ba? Na absent siya kasi hindi siya present. So in the absence of bumalik. In the absence of the heat, okay? Sa kawalan ng heat, tinawag siya na cold, ang lamig niya. So hihilain lang yung core na to, yung kulay puti na yun, para sa spring, and then nag-i-shrink na siya. So yung tatlo nandoon din sa loob. Ano yung tatlo na yun? Hahanapin natin mamaya. Kung ang cold shrink ba saka heat shrink ba, same management and technology that we are looking for. Okay? Bakit silicone? Hydrophobic. Okay. Maganda siya. Ayaw yung tubig. Wow. Best friend ko pala siya, no? Hydrophobic siya. And then, silicone is maganda sa UV. Okay? Okay? See, this is research shows, no? So, porcelana. Pag ang insulator ko is porcelana, nung una, hydrophobic siya. But through the abrasions, na-abrade na yung kintab niya, nawala ng kintab, nawala ng ningning, nagiging hydrophilic siya. Uy, naging balimbing. So tayo, ayaw natin mga balimbing, no? Gusto natin, kahit anong mangyari, lagi siyang hydrophobic. The silicone, this shows na ang silicone, kahit 40 years old na siya, it retains the hydrophobic characteristic of the material. Okay? I'm not talking about brand. I'm talking about materials. Take note of that. So, yun kaya pala pasikat ng pasikat yung mga rubber insulator na silicone. So, hydrophobic. And then, doon sa heat shrink natin, most of the heat shrink, if not all, is using the material, we call it plastic. Ito yung mga XLPE natin, ito yung EVA natin. So, pag tinatamaan yon, okay, nagka-carbonize because this is a carbon-based material. So, carbon to carbon, tinamaan mo ng UV, and then naghihiwalay. So para siyang naaagnas. So pag hinahawakan mo to, kasi akala mo nilinis mo siya, actually nagka-carbonize na. So imagine doon sa taas, slide, papunta ng 0. Habang gumagapang ang energy mo, nagkaroon siya ng ayuda ng carbon. O disgrasya ang terminations. So ayaw natin nun. So cold shrink termination, QT2, this is generation 2. Meron tayong mga skirted, meron tayong mga walang skirt. Okay? So same principle ang nangyayari. So cold shrink termination, ano yung mga component? Nakikita mo, hanapin natin yung stress control, insulator for tracking, ay yung mastic naman for silyo. Ito lang. So here it is. Cold shrink termination, installation, cable preparation, if and only if meron ka talagang pinagbabantayan. Ito yung portion. Nagki-cable preparation ka. Okay? Unfortunately, kung minsan nasa training tayo, physically present, pero absent pala siya. May taga-Baguio tayong kasamahan, no? And then, bumili siya ng terminations, but ang kinopya na cutback, yung sukat kasi nito, may mga sukat yan. Very specific for a brand, very specific doon sa model. Wala siyang one for all for one. Walang ganon. So very specific yon. So sinundan niya yung minimemorize ni Terminator kasi 20 years na daw siyang Terminator. O din lumuwang, tumawag. Sabi niya, Sir Marlo, ano gagawin ko? Sabi ko, o-on mo. Sir, pasasabog to. Di wag mo i-on, sasabog pala eh. So ngayon nag-uusap kami, ayun. Iba palang sinundan niya. So take note of that. Kung bago mo isara to for documentation, ISO 4.22 yan. Doon sa nagpa-practice ng documentation natin, itabi mo yung roller para may documentation ka. Bago mo ilalagay yung body. So in this case, we're using the cold shrink. Nilagay niya, hinila niya, and then nilagay niya ng silicone tape. So silicone tape, ang nilagay mo para masilyuhan ang taas. 2 procedures lang, no? Mukhang may kulang, sir. Anong kulang? The heart and soul of the terminations. Ano yun? Stress control. Bakit walang dyan? Bakit hindi nakita? Kasi kuya, this is now the generation 2. Paglagay mo pang body nito, yung pang tracking purposes mo, automatic. Nandoon na sa loob yung pang stress control mo. Wow, 2-in-1. Di mabilis pala, sir. Of course, mabilis lang. Pag nagsa-sideline ka dyan, sandali lang. Meron ka ng 30,000 in 30 minutes. Ganun sa kabilis, no? So, ilalagay mo na lang, body, and then silyo. So, generation 2, QT2. Okay? So, ang video, sa sinasabi ko, dalaw na lang kayo doon sa virtual booth namin. Okay? So, ang QT3 naman, the generation of QT3, there are only at least 3 companies in the Philippines na gumagamit ng generations. Matatalino sila doon ng mga engineers natin. So, they adapted to the new one because they are studying the risk management, RISK, risk. Kung tawagin ni Alan, efficiency. Efficiency means profit. Okay? Ano yan? QT3. Ang QT3, yung 3 kanina, cable preparation, unwind the core, and then ready. Anong ready? Maniningil ka na po. Ba, isang bagay lang, no? Pagpasok mo ng core na to, okay, pagpasok mo siya, automatic, nandoon na yung stress control, which is the heart and soul, and then may silyo na yan. May silyo sa taas, may silyo sa baba for capillary. Nako, napakabilis pala na trabaho. Yes, ganun yan, kabilis kuya. So mas mabilis ang trabaho natin, mas mababa ang risk. Hindi ka kaabutan ng ambon, hindi ka kaabutan ng ulan. So mas mababa ang risk, no? So one of the management ng natin, pag naka-prepare ng cable natin, imagine mo lang, nakahubad na, exposed na lahat, sir. So dapat protektahan mo yan na hindi siya matalsikan ng laway. Okay? Pati ba yun? Of course, no? Yan ang yun. Famous questions. Sir, gaano ba katagal yan? Question is, anong technology ang ginamit mo? At sino yung terminator na ginamit mo? Okay? Pag qualified siya, no, lagi siya nag-aattend ng IIE, may knowledge siya at pinapractice niya yung knowledge, repetition, nagiging skills niya, and then meron siyang proper tools, malamang kaya niya 30 to 40 years. Okay? Kasi yun ang ini-estimate natin sa kabuhay ng kable natin, 30 to 40 years. Sir, nasa maintenance repair operation, sir, ako eh. Pwede ko ba singilin si contractor, sir? 10 years old pa lang yung termination ko. Pwede. Yan. Unfortunately, hindi nga regulated dito sa atin. Ano? So, singilin mo na lang yung si Mr. Signed and Seal. Pa-explain mo sa kanya bakit nag-fail yung termination na yon at nag-loss ka ng 2 million per day. Okay, that is the minimum according to the study, that is the medium business, no? Pag nawalan niya ng kuryente, outage cost 2 million minimum. Okay, mahirap pala. Okay, mahirap 'yon. That is the reason we are here also to share the science behind ng termination. Okay? Cold shrink QT3. cold string termination. Of course, mas bago, mas efficient siya. Yan, mas efficient, mas makasave tayo, and then mas maganda ang kita. So these are the properties, no? Hindi na natin i-discuss maigi. So technically speaking, yung QT2 versus QT3, much better yung QT3. So I hope maa-adapt natin to, no? Maa-adapt natin na QT3 na tayo. Iwanan natin si QT2. Currently, sa buong Pilipinas, we are still using the quick connect, quick termination generation 2. Okay? So video ulit. Okay. Question. Ito na naman pinakamadali, no? One of the highlight of the slides. Paano ko pipiliin yung kit? Ang sa amin kasi sa 3M, advertise na ko. Okay, by the way, 3M. Nilagay na namin lahat na component doon. Kinumpleto na namin yung electrical tapes. Kasi alam namin, yung electrical tapes to, hindi mo mabibili to sa regular na tindahan ni Aling Susing. So mga specialty tapes yan for termination, medium voltage. So kinumpleto na namin. Kompleto ngayon, pero nalilito ka naman. For example, meron akong 15 kV, 200. Tapos yung insulation diameter niya is 20 mm. So sa slides natin, pwede ako gumamit ng 5633, 5635. So to be exact na kung ano ba talaga ang kit mo, the final determining point, ito naman, naka-bold naman, no, is the insulation diameter. Okay. May malaking question dito eh. Kasi majority, every time na hinihingi namin ang insulation diameter, ang binibigay sa amin is the cable outer diameter. Okay. Pag XLPE, yan, yung kandila, huwag mo nang isali yung itim at huwag mo nang isali yung jacket niya. Yung insulation diameter lang po ang hinihingi natin to judge kung anong gagamitin kong kit. So, for the designer, hindi naman ako kwanmar eh. Designer ako. Yeah, okay, designer. To be fair, no? To be fair with the industry, ang isusulat mo lang dong itong IEEE and then this is the class 1 termination. Meron tong class 2, meron tong class 3. Huwag mo nang pansin yung class 2 at class 3. Mag-class 1 ka na. Parang binata ko yan. Pag class 1, gusto ko, ayaw ko ng class 2. Class 1, termination. So anong hanapin niya? Yung tinuro natin na tatlong ima-manage mo. Stress control, yung silyo, yung pang-tracking. Yan lang doon. So, according to the study, normally we do away sa geometric, yung maugbok, no? We are now trying to use the high K. Mas maganda daw yan, according to the study. Okay? And then, here are the other accessories. Ang i-highlights lang natin dito when we are presenting. Kasi ito one of the malaking negligence, no? It is a negligence. Kasi pag nag-terminate sila, pag ang lugs niya is maluwang, nilalagyan nila ng palaman. Ngayon, kung masikip naman, binabawasan nila yung strand. Di ba? Yon, mortal sin, improper practice yan. Okay. Paano pag ireklamo ka? Saan ako dadulo? Sa that is the topic, no? Topic yan ng Engineer Lona during the conventions of Gov. Aris doon sa Jensen. No? Topic yon. May tutulong sa iyo kung pahabulin si engineer na nagtatrabaho ng hindi tugma. Okay, here are some highlights. Most of us, yung mini-maintain natin na crimping die is for copper. Okay? Magkaiba yon. Okay? Magkaiba. Okay? Yung copper at saka aluminum. So pag ang kinikrimp mo is aluminum, maghanap ka ng crimping die for aluminum. Gumamit ka ng lugs na pang aluminum. Yun lang po ang message. Siguro mga 70% sa industry natin is using the die for the copper. Okay? We are trying to campaign this one, this tier, to try to educate na hindi yun pareho, sir. Definitely hindi pareho. So, pinagtabi na natin, di ba? Copper, aluminum. Di ba? Magkaiba yan. Yan. Okay? So, mag-invest na kayo dito sa copper or aluminum dies. Magkaiba yung sets na yan. So for the questions of the termination, please put it in the chat box. Nandiyan naman si Glenmar. Yan. One of the few people who ini-specialize to, di ba? By passion. So nandiyan yan, sasagutin ni Glenn yan. Alam ko nandoon siya eh. So let's jump to the sa splicing. Splicing, pag European community ang kausap mo, and then joint. Pag American, European plus splicing, American is jointing. Pag Tagalog, dugtong. Ya? Pag Cebuano, isumpay. Pag Hiligaynon, isugpon muna na sa to. Isumpay natin ang kable. Dito, ang kailangan mo lang naman i-memorize forever. Kung ang learning is forever, itong 5 lang. Dapat alam mo yung conductor, primary insulation, take note of this. Ito yung hinahanap natin lagi. Huwag mong ipapalit yung jacket mo at saka insulation. Although itong jacket mo may insulative material, pero pag sinasabi naman primary insulation, ito pong hinahabol natin. Semiconductive screen, take note of that, memorize mo yan. Kasi kung ikaw ang doktor, hindi mo naman pwedeng idugtong yung laman at saka yung balat, magkaiba yon. So same thing, no? Pag yun, nagkakamali ka, gumagamit ka ng electrical tape to do that, may mangyayari na hindi maganda. Okay? So, doon sa component na yon, may electrical functions and then meron din siyang physical functions. This is more for the service life na 30 to 40 years. No? So, yun ang sagot. So, same thing, ang principle natin, pag nagdudugtong tayo, kung ano yung material na dinudugtong mo, please use the same material. Okay? Ina-address mo rin yung stress control. Bahala ka kung ano gamitin mo, geometric ba o high K. Okay? So, yan. Ito na mga model na rin. So, the theory behind sa stress control, we just trying to use the refractive index ng high K natin, no? So mahimas natin para hindi sila tapok-tapok kung sa Bisaya pa, no? Magtapok ganin na sila, walang social distancing, iinit yan, sasabog yan. Okay? This is the colorful representations of the potential difference. Yan. So this is the field, no? Kung saan ito ng reality. So binabalik-balik ko to siya kasi binabalik-balik namin kasi majority ng mistake. Hindi naman mistake, no? A point for improvement, yung primary insulation mo is yung XLPE. Anyway, majority of this XLPE naman. Meron bang iba, sir? Meron. Meron bang rubber and so on and so forth. Okay? So XLPE. So what are the technologies present today sa industry natin? Meron tayong tape method, meron tayong heat shrink, may push-on, saka meron tayong cold shrink. If and only if nasa maintenance repair operation ako, tanungin mo si manager. Sir, sabi ni Sir Marlo, kailangan meron akong electrical tape. Yung 5, parang basketball lang. First 5 lang, sir. Kailangan 24/7 nandyan sa toolbox ko. Ano yon? This is the semicon tape. Okay? Splicing tape, metallic shielding tape, at saka yung jacketing tape. Yung rubber at saka PVC. Higit sa lahat, laging-lagi meron kang semi-conducting tape doon sa toolbox mo. Kasi ikotin mo lahat ng mall o ikotin mo lahat ng mga tindahan dyan, hindi mo basta-basta mahanap yan. Okay? In fact, one of the reason malalaman namin na maraming gumagamit ng competitor namin is because they are buying a lot doon sa semicon tape namin. That is the semi-conducting tape. Okay? Ano yan? Pag ginamit mo na insulative tape yan, energize ka, magta-transform siya into a conducting tape. So ma-imagine mo, extension cord, gumamit ka ng semicon tape. Pag nag-energize yan, pati yung humawak, ma-energize. No? May nangyari yan dito sa amin, dito sa Batangas. Okay. Sad story. Heat shrink, same message. Kung ano material yan, puro tube yan, then make it sure na alam mo yung material na yan, although magkapareho ng kulay. You apply the heat, and then palabas, gitna, palabas. Okay? So minsan parehas lang itim. Okay? Take note, yung properties noon magkakaiba. And then, for the cold shrink. Dito sa cold shrink, ang technology natin, para di siyang kape, yung number 1 component, number 2, number 3, and number 4. So except for the number 1, the number 3, number 2, number 3, ang number 4 component ng kable mo, pinag-isa niya. So pag hinila mo, automatic, nandoon na kaagad. O, di ang bilis ng trabaho. Paano ginagawa? Ito, conductor, ano babantayan mo? Crimping die mo, sir. And then, lalagay mo ng body. Hihilain mo, nag-shrink na siya. So 3-in-1 na yon. Nandoon na yung mga properties ng pinagdudugtong-dugtong mo. Okay? Metallic shield. So anong purpose yan? Bakit metallic shield? Bakit ikot-ikot? In order for you to maintain the equidistance of the potential difference. Okay? Kaya nga minsan sabi natin, pag naduling yung kable natin, hindi tugma yon. Okay? So make it sure na iikot-ikot yan para to maintain the equipotential, no? Co-centricity of the energy. And then you put a jacket. Hilain mo lang, madali lang yan, kahit babae pwede. Kita mo naman sa kamay ni Kuya, no? Nakapilantik. Okay, and then the splice is done. So QS3, video, please visit the booth namin. Ang kit natin, provided na lahat yan, we try to make it sure na madali mo siyang gamitin. But in instances na for whatever reason, nawala yung pan mo, silicone grease mo. Sino kayang nag-uwi noon na pangpadulas yun o ano ba yung ginamit niya? So you can buy, okay? You can buy component to component. Okay? So this is the message. Still, we have cross-sectional, no? Cross-references of different standard. And then the splice. Okay? Iba-iba yung connector natin. Point is, pag may transition splice ka, gumamit ka ng shear bolt. Ang shear bolt na sinasabi natin, ito yung gitna natin, pwede sa copper, pwede aluminum, pwede mataba, pwede payat. So transition ang tawag natin doon. So walang compression type. Okay? I don't know kung may compression type na connector na kaya mag-address ng transition. If and only if meron man, then swerte tayo. So look for that. But in most cases, ito yung available na technology, shareable. Okay? So gentlemen and ladies, I hope we have imparted our knowledge for the medium voltage, for the power cable and accessories. Disclaimer, sorry. Glenn, ginamit pa pala natin to sa Metro South, no? So stay safe to all. Adelante. Yan, alma mater. So this is your contact persons for electrical team namin. Nandiyan kami sa virtual booth namin. I hope you can visit us. Sir, dagang king salamat. Dirin na lang tayo.
Sige.
440.
Thank you. May pangutana, mayroong tanong.
Sir,
Ang 3M ba meron ang 3M ba merong mark? Wala, no?
3M.
Meron. Kasi si Mark ang apelyido. Diba? Tapos, question sir, another question. Palagi mo binabanggit yung skirt. Sabi ni Saya yan, Saya. Babae
Saya.
ba si 3M?
Saya.
Oh, skirt. Ha? Babae ba? Sige. Pag may question and answer, salamat, Mark, no?
Si Sir, kuha na lang, sa chat box na lang ta, no?
Sa chat box na lang. At tapos, paki-visit sa, sa virtual booth ng, ng 3M. Kasi maraming skirts doon, no?
Yan ako.
Maraming
T-shirt, sir.
Akala ko skirts. T-shirt pala, T-shirt.
Okay, for those we cannot reach, we will first 50 lang yata ang allotment namin doon. We were going to send it to the Cebu chapter, yung hindi namin ma-reach out. Ha? So, binadgetan talaga namin yan.
So, adelante ha?
Adelante, sir. Adelante, sir.
Okay, sige. Thank you for that, Sir Mark. At this juncture, we will award the Certificate of Appreciation. IIEE Cebu Chapter. Present the Certificate of Appreciation to sponsor, gold sponsor in gratitude and acknowledgement of the invaluable support for this 20th Eastern and Central Visayas Virtual Regional Conference, given this 18th day of September 2021, signed by IIEE Cebu Chapter President Mario Tabanyag, Regional Governor Felipe Niliama, VP Technical Affairs Luel Artilia, and technical consultant and advisor Brian Pasilan. Ladies and gentlemen, the certificate of appreciation is presented to 3M. So maraming salamat po, sir. 3M.
Dagang salamat, sir. Dagang salamat.
Okay. So, ang ang ato asang MC karon doon na sa ni siya M. Kaya ang pangalan niya Bobby, niya M ay ang apelido. So, Marino. Okay. So, let's proceed to the next speaker. Atong next speaker is a power speaker, no? Because he came from a power company. And he's a former IIE Cebu chapter president, former Regional 7 governor, former national officer, former national president, and presently consultant of very big companies here in the Philippines and abroad. So his topic will be about the potential impacts of high penetration and variable renewable energy sources on the electric network. So without much ado, ladies and gentlemen, please help me welcome Engineer Jules Alcantara. Sir Jules?
Hi, Bobby. Hi.
Okay, so loud and clear,
Can you hear
sir.
me? Can you
Yes,
How about
loud and clear, and
how about
your
the screen? How about the screen?
ang screen is 2020, sir. Dili 7920, 2020 yun.
Oh.
Very visible.
Oh. The year of the pandemic.
Okay, sir.
started.
Okay.
Okay. Okay. Good afternoon, everyone. I see some of my friends. Salubre is there. I worked with Mr. Salubre, Pero Salubre for maybe 6 years. Brian Pasilan, the son of my mentor, Oscar, the late Oscar Pasilan. I see Roland Vasquez and Gil Losares, the former governor in 2012. I see the president of BECOL, Raul Lucero, my colleague Mark Kindika, and my former student, Ruel Militar. Good afternoon, everyone. Now, this is a topic about specifically for variable renewable energy. And we will talk about having a high penetration in the electric network. So the objective here is to know about the potential impacts from solar and wind power, power flow impacts, voltage impacts, protection impacts. And during the conference, we have heard of presentation on the DIS, or the Distribution Impact Study. We have heard that power flow or load flow analysis is done, short circuit, protection analysis, transients, and faults. We have presentations about faults, about protection, and several presentations about solar PV. Now, my interest in renewable energy started when I was in Africa as a part of the team of Meralco. And Africa has a lot of large rivers, small rivers, natural gas, oil, and especially sunshine. And so solar farms are being proposed. And as an engineer, the first thing you ask is, what is the impact of these solar farms on the distribution system or in the transmission system? So the traditional power system is shown in the left. Generation goes to transmission, distribution, and customers. However, with the change towards renewable energy to mitigate climate change, We have large BRE connected directly to transmission. We have customers who have solar PV on rooftop with net metering, and we have distributed or embedded generation directly supplying energy to the distribution system. In another way, the past to present system is that the generation goes to transmission, the step-down transformer to distribution, and to the customers. From now, from present to future, there will be a change. You will notice that this is now bidirectional. The transformer is subjected to bidirectional power flow. The distribution has like a function of a transmission because it has generation from wind, solar. Then there is charging for electric vehicles. There was a discussion actually of motors, Tesla motors in electric cars. We have the introduction of battery energy storage systems, and we have the smart loads. Let me I can't move the screen. Okay. The power system is slowly transformed from level 1. We have a penetration of variable renewable energy of less than 10%. The Philippines is still in this level. And as penetration of BRE is increased, just like in the US, California, for example, and in Europe, there will be some minor to moderate impact on the power system. So we will be discussing about somewhere about the level 2 and the level 3. What are the impacts of high penetration of variable renewable energy? The Philippines is blessed with solar power. There's a map here. Cebu has a lot of irradiance from the sun, but if we take out the land use exclusion and slope, northern Cebu and western Cebu, and even here in Metro Cebu has some potential for solar. For the wind power, the one shaded in green or blue, you will notice that Samar has a very big potential for wind, including Panay and Negros Island, and southern Luzon and the coastal areas facing the West Philippine Sea. Let me define what is variable renewable energy. Defined in the Philippine Distribution Code, the production is renewable, cannot be stored, but actually you can store it as in the form of electricity in the battery storage system. It is intermittent, includes wind farms, PVs, and run of the river. What are the characteristics of BRE? It's free fuel. However, there's a problem with uncertainty, variability. And the interface is usually inverters, which are source of harmonics. Physically, in the power system jargon, we need inertia, but inverters have no inertia. And it's very dependent on location. Let us define a penetration level. An example here is the PV capacity penetration level. You add all the kilowatt capacity of the embedded PV divided by the peak annual kilowatt load. In some countries, capacity penetration is in terms of energy. In some countries like the UK, it is in terms of the number of houses with rooftop PV over the total number of houses. There's a term here, stiffness factor. It is a factor that tells about how strong the power system is. It depends on the fault current level at the point of common coupling or the point of connection, divided by the embedded generation that is being proposed. So in the jargon of power system engineers, if the stiffness factor is 100, that only means that the power system is very strong, that the added embedded generator can hardly impact the power system. So stiffness factor is an indicator of how strong or how we can assume as an infinite bus the grid or the power system to which the generator is to be connected to. So we will be interchanging the terms DG or distributed generation or EG or embedded generation. Now, theoretically, the output of PV is from, let's say, 7 a.m. to 6 p.m. And if there is a tracking, as mentioned by Engineer Losares, you can get more energy if the modules will track the sun. These are the real-world output of the PV. You will notice that it's not the curve is not smooth. There are many variations. That is why this is called variable renewable energy. It varies a lot. Now, it depends on what is called cloud-induced variation. So the clouds can influence the output of the PV. Some days it's sunshine all throughout the day, or in some days it's very cloudy. Now let's talk about wind. So wind power has been utilized by humankind for many hundreds of years already, from windmills to sailboats and wind farms. And even I see that Amazon is selling wind turbines for homes, costing $1,350 they can deliver by November 2. Now, the most common wind generator is what is called doubly fed induction generator, and DFIG. This is an induction generator. There's also an inverter. So the power output is a mix of power from the induction generator and from the inverter. Another one is full electronics. The output of the generator, synchronous generator in AC, is converted first to DC and then converted back to AC, which is compatible with the grid frequency and voltage level. Again, wind is variable. For every second, it varies very quickly. And that's why there's a wind farm. A wind farm that is dispersed geographically can have a more smooth output because wind velocity is not the same all throughout the wide area. So if your wind farm is concentrated on a small area, you have greater variability. Now let's look at the fault currents. Synchronous and induction generators have this kind of waveform for faults, depending on the subsynchronous reactance of the generator. There is also a DC component. However, for rectifiers, there is just a very short blip of fault current, and then it goes back to normal current, and because of anti-islanding provision, it goes to zero. So in most studies, without the information from the manufacturer, we can safely assume that the fault current of the PV system can range from 110% to 120% of the rated current. Now, for transmission engineers, inertia is very important because inertia makes the system more stable. And in the introduction of medium to large generators, stability analysis has to be done. And inertia is one of the biggest component or parameters that is inputted in the model. Let's see for a power system that has high inertia, meaning there are many coal plants, many hydro plants, large hydro plants, and the inertia is large. When there is a disturbance, like tripping of a large power plant, the frequency can dip slowly, and the rate of change of frequency is not that big. So it can quickly move on towards normal frequency. However, for a power system that has low frequency, meaning there are a mix already of inverters, a low inertia, the frequency can quickly drop. But if it is still stable, it will go back to the frequency of 60 Hertz. However, if it is unstable, the frequency will drop towards a blackout situation. Now, let's talk about total harmonic distortion, because total harmonic distortions are being introduced. This is just an exaggerated level of harmonics. This is the harmonics with third harmonics with 180 Hertz frequency. This is the fifth harmonics with 300 Hertz frequency. If we add all the fundamental, the third, and the fifth, you will have a distorted waveform. In real life, in real world, total harmonic distortion with a lower level could be smooth. But however, if the total harmonic distortion is large, then the waveform is not that close to a pure sine wave. Now, let's talk about distribution system. Normally, power flow will go from the transmission towards the loads. So it's a one-way flow of electricity. But with the embedded generation or distributed generation connected to the feeders of distribution companies, there will be a change of power flow. Let's look at this blue curve. This is the native load of this feeder. Then there is a production of electricity from the PB, this orange. So the net will be this curve there. And Engineer Luzares mentioned about a duck curve. This is what he is referring to. It looks like a duck when there are many curves superimposed. This is the tail, this is the body of the duck, and this is the head of the duck. Now, the duck curve is important, especially in high penetration. Like in California, it's 40%. There is a time wherein the operator, the transmission operator, has to ramp up the power generation because the PB plants are ramping down, moving towards the nighttime. So there is an issue about how the power system responds to this duck curve. So when analyzing the power system, particularly on the distribution system, you have to know the time. You have to have analysis using time variations. So there's also a time when there is a possibility of a reverse power here. Supposing this load trips, then there is a possibility that the power from the embedded generation goes back to the interconnect transformer. So a reverse power is possible. So the possibility of reverse power can even go towards the other feeders or to the transmission system if this PB plant is quite large. It is estimated that at 30% penetration, it is very possible that power flow will reverse towards other feeders or towards the interconnect transformer. Now, talking about reverse, is it okay for the transformer which is designed for one-way flow from transmission to distribution, or in the distribution from higher to lower? Could the transformer operate? What do you think? Will the reverse power impact the performance of the transformer? Or do you need a special transformer to accommodate reverse power? The answer is yes, the transformer can operate on reverse power. Second, is the performance the same? No, it will impact the performance. There is some sort of higher magnetizing or hysteresis loss in the transformer for reverse power. Now let's quickly analyze why. Why is there performance loss when your transformer is subjected to reverse power? So this is equivalent circuit of the transformer referred to the primary. The total impedance is the primary R plus JX1, and the secondary is R2 JX2. For simplicity of analysis, we can assume that there is negligible magnetizing current. For forward flow, this is the vector diagram. B2 plus the voltage rise towards the source of R and X. R is in line with the current. X is 90 degrees in reference to the current, plus the primary R1, X1. So this is the terminal voltage of the grid. For the same terminal voltage of the grid, here, working back with using reverse power, a reverse flow of the current, you will see that in the vector diagram, E2 or the magnetizing voltage is higher compared to that of the forward flow. So in effect, you have increased magnetizing flux in the core because E2 on reverse is higher than E2 for the magnetizing voltage on the forward flow. So in effect, there's some impact. So to analyze the power flow, you can actually have this quadrant, positive flow for both active power and reactive power, a negative flow for active, a negative flow for both active and reactive, and positive flow for active and reverse for reactive power. And analyzing the quadrant 3, which is the worst case, you might have a loss of life for the transformer, but the transformer can accommodate reverse power. So the maximum excitation occurs in the reverse power during the quadrant 3, when both active power is in reverse and the active power is in reverse. So in this case, it is the secondary already providing magnetizing current for the transformer. Let's talk about on-load tap changers in the distribution. There's an effect, there's an impact also of reverse power. Normally, the OLTC here, or the voltage regulator, will raise the voltage here so that the peak and off-peak voltage are within the limits. So this is the internal of on-load tap changer. What is the effect on the on-load tap changer of reverse power? There is also an effect. This is the diagram, electrical diagram of the tap changer. There is the transition terminal. There is the main terminal of the moving terminal of the tap changer. These are the fixed terminal of the one tap of the transformer. the sequence is this: the transition tap will move first towards the next tap, this one, and then before the main tap will move. So the main tap will move. In the process, there is a circulating current. There is a resistance provided by the manufacturer. So in effect, there is also a possible effect on the on-load tap changer for reverse power. The study made in UK is that delta primary connected transformers are better in reverse power flow. Big transformers have usually high circulating currents, so there is a derating effect for large transformers. For small transformers, they can have good capacity still for reverse power. So, but there is a concern for transformers with vector connection of YY0 because of high circulating currents. So the worst case for reverse flow is when there is a reverse flow with a unity power factor, meaning there is a zero reactive power flowing in the reverse. So these are the impacts of reverse flow because of embedded generation and loss of load in the distribution system. Another impact are voltage variations. This is real life. There is a 30 megawatt power photovoltaic power plant. Every time there is a variation of the output in these two areas, there is also a variation of voltage. So because of the high power of the PV, high power output, voltage or output of the node is also affected. So it is expected that for high penetration of embedded generation, variable renewable energy, there is also a variation of voltages. So this is the voltage profile. Normally, as you move away from the substation, the voltage will drop. With capacitors, it will improve. With some PV plants, it will be further improved. And the worst case scenario is the PV plant is located at the end here. Why? There is an analytical approach here. This is the sending voltage, receiving voltage. This is the variation of voltage. This is the standard equation. The sending end voltage is equal to the receiving end plus the current, which is the power over voltage, and the resistance plus reactance. At the end, after the derivation, at the end, the worst voltage situation occurs when there is a high resistance of the feeder. And the highest resistance occurs if the generator is located at the end. And especially if the generator has a very large active power output. The voltage can be regulated in a smaller way or a lesser way by capacitors and reverse the use of reactive power from the use of motors, for example. In the real world, this is an example of a feeder, distribution feeder, normally without PV. So with the color code here, the red is higher voltage, the blue is lower voltage. So the high voltage occurs here. The rest are low voltages. But with the introduction of PV plants here, and there's another one. There is an improvement of voltage from green here to red. From green here becomes red. The blue here becomes yellow, meaning higher voltage. The blue here becomes red because it's close to the PV plant. You will notice that the current, which is indicated by the thickness of the line, the current has also reduced from here, and it becomes thinner to this one because there is now a contribution from the PV plants at the distribution system. There is also a problem in voltage regulation. A typical voltage regulator will regulate V3 to the desired voltage. However, if there's a reverse power flow, the voltage regulator will try to regulate V2 or the primary, but it cannot do so because probably this is very strong. The stiffness factor of the system is strong, so there is a possibility that the regulator will run away condition, will go to the runaway condition. It's either at the top or the lower top. Some utilities just set it to neutral, meaning it doesn't change in a way. So in real world, there are this is the number of operations of the voltage regulator, phase A, phase B, and phase C. Probably there is an unbalanced loading of the three phases. So initially, without the PV, there is less tap change on A, but more tap changes in phase C. With the introduction of PV, there are now more tap change occurrences here, here, and here. So with the introduction of embedded generation, variable renewable energy, there is a change in the behavior of voltage regulators. There was a mention about islanding. So let's talk about unintentional islanding. So islanding occurs when, in this example, the whole distribution system, there's a recloser here, the trips. Now, the island now is consisting of loads supplied by the generator, which could be a PV. Now, this is dangerous because the voltage can go up or down, the frequency can go up or down, especially personal safety, because the lineman here might assume that there is no voltage, but actually there is power supplied by the embedded generation. So we will analyze this. This is a system, simplified system. The PV is here, the grid is here, the load is here. Now, for this island to be self-excited, the grid current must be zero. The load, both power, active power, and reactive power must be the same output of the PV. So if the PV output is equal to the local demand, we call it the island is self-excited. It can sustain for seconds or minutes. But in the real world, the probability that they are equal is not there. So the PV output is not the same as the load. So what happens? There must be a disconnection. There must be an anti-islanding scheme or protection so that the PV plant is disconnected from the distribution system. The Philippine Distribution Code mandates also anti-islanding protection requirement. It mandates that the anti-islanding should not be more than 2 seconds. So the best practice is it must be much lower than the 2 seconds requirement. What are the anti-islanding methods? These are specified by the manufacturer of the inverter. So some manufacturers use active methods, passive methods, and communication-based. What is an active method? It detects the changes in the parameters like frequency, rate of change of frequency, the change in voltage of the system, the change in current. So whatever change is in the system is detected. Oh, that is, that is the passive method, the change in the parameter of the system. But what is active method? Active method means the inverter does something. If the frequency is going down, the inverter will simulate to bring down the frequency. If the frequency goes down, then the conclusion of the inverter is that there is no active power coming from the grid. Or it can change the voltage also. So in the active mode, in the active methods, the inverter is intelligent enough to push the parameters so that it will detect whether there is an islanding that is occurring or has occurred. On communication based, this is based on SCADA. So direct trip. If the breaker in the substation trips, then the PB plant also trips. It could be through PLC or power line carrier, or through distribution automation. So this is more advanced. This is the cheapest, the passive method, and the more intelligent one, the active method. What is the impact on protection? This is an example. It might impact the fuse. In this case, normally the grid will supply, for example, 7.8 kiloamps. The 5 megawatt PV plant can supply 240 amps. Where does that come from? MVA, the megawatt divided by square root of 3 divided by the voltage, you have 218 amperes. Now, assuming that the fault is 100% of the rated current, the current becomes 240. This is a current source. So whatever happens, the PV plant provides 240 amps. And it might exceed the interrupting capacity of the fuse. Another way is that there's a fault on another feeder that 240 amps will also supply the current as a current source towards the fault, plus the fault current from the grid. Then you trip the breaker for this fault. So you might have higher current than the interrupting capacity of the breaker. Another impact is that you might not, that this relay in the substation might be blinded. Why? There's a plant here. It gives the fault current of 110 to 120%. The voltage here will rise compared to a system in which there is no PV. And so because the voltage here is higher than what is supposed to be, there is a reduction of fault current from the grid. And empirically, the reduction is from this equation. For example, the voltage to ground is 7.6 kV. The current from the PV plant is 200 amps. The branch impedance is 0.5 ohms. Then there is a reduction of about 2% from the grid. So these are just small, but if the embedded generation here is high or big, then it is very possible that this relay hill will not sense that there's a fault on this branch. Another impact could be about recloser unsynchronized closure. So there's a fault here. The recloser will open fast in the fast curve, but then this PB might not have had disconnection from anti-islanding. So the recloser may be closing maybe in 0.15 seconds, then it closes to the fault and to a different voltage and frequency. So there is an unsynchronized reclosing of the recloser. Another is fuse nuisance blowing. So there's a momentary fault. The recloser is supposed to open so that it will save the fuse. So the closer opens on the fast curve to save the fuse. Okay. This is now open, yet there is a fault current or current from the PB at 110%. So what will happen? The arc is never extinguished, so the fuse might blow before the DG or the PB is taken out due to anti-landing. So there is a possibility of nuisance fuse blowing. So a transient fault might become a permanent fault. Sympathetic tripping. This is a word which we all know. Sympathy. The other feeder sympathizes with the other feeders. There's a fault here. So this breaker is supposed to open. The overcurrent relay is supposed to trigger the operation of the breaker. There is a contribution of fault current from the PB. There is also contribution from the grid. However, breaker 2 and breaker 1 trips at the same time. Why? This is what is called sympathetic tripping. This breaker is supposed to trip, yet the other breaker trips. There could be other reasons, of course, like miswiring or miscoordination of relays, or this relay is not directional overcurrent. It doesn't sense what is the direction of the fault. So there could be other reasons. So this is sympathetic tripping already with the introduction of PB plant on the other feeder. Eventually, the DG trips due to anti-landing. Another is transient overvoltage, especially if you have a delta connection here. So there's a fault, a line to ground fault. This is the three-phase vector, A, B, and C. The neutral is on the ground here. However, if there's a fault on phase C, what will happen? There's a shift, the entire vector upward. So the phase C, instead of having voltage from the neutral or from Earth, it now have zero voltage to neutral or Earth. But the other phases, A and B, will experience over voltages by maybe 70% over what is normal. So this is a transient over voltage, and still this will be analyzed in the DIS. Again, this is reclosing out of synchronism. So the breaker recloses, but doesn't check whether there is a voltage from the other side. So modern reclosers have voltage transformers to check whether reclosure is possible. There is also an effect on sectionalizers. There is a sectionalizer here. What is the purpose of the sectionalizer? If there is most faults in the distribution system are momentary. Maybe a twig has fallen in the line, or a lightning, or a bird that has wide wings that has short-circuited two phases. So the recloser will open on the first opening. The sectionalizer will just count how many on and off the recloser has operated. So it will just detect what are the times or how many times there is no voltage. However, the sectionalizer cannot count correctly the number of operation of the recloser because power is supplied from another plant, PB. So it will miscount. So in effect, the sectionalizer will say, oh, there's no opening of the circuit. So it will never operate. So this time, this will become a permanent fault. The recloser or the breaker eventually opens the circuit. And PB will separate through anti-islanding operation. Here, the momentary fault, there is contribution from the substation and from the inverter. The recloser operates. However, there is not enough loss of voltage for the sectionalizer to count because there is power coming from the PV plant. Lastly, there is also an effect on voltage flickers. What the flicker is a result of rapid change of voltage. It could be annoying to the customers. And for modern power systems, except for the load variations, PV and wind power are the leading cause. The large PV and the large wind power are the leading cause for flickers. Now, this is what is called a GA flicker curve. An example here is that the blue curve is the point of irritation, and the cayenne line is the point of being visible. The flicker is visible to the human eye. An example here is here. This point, there's a flicker drop of 3 or 2.8% or 3% one time. So the human eye can actually see it. However, the more problematic one is the irritation. So even a small change of voltage, let's say 0.7 here, for 5 times per second, can be irritating. So again, flicker are caused by changes in voltage in the generation or load, especially coming from large, high penetrating wind and solar power. So that's the end. I hope you have learned something that the effect of large BREs plant on the power system. The Philippines is still far away from that. Maybe in 5 to 10 years time, there will be a high penetration of BRE, and these impacts are in your head, and you will somehow remember that again, BRE have impacts on the power system. Thank you. Bobby?
Yes, thank you, Sir Jules. That was a very informative topic, and which is also very related to other speakers and all topics being discussed. So thank you for that, Sir Jules. And we hope with that we can see the future of the renewable energy sources here in our country to be more efficient and effective. At this juncture, so question and answers again will be answered during in the chat box. So just write your question and answer in the chat box, and it will be answered accordingly. So at this juncture, we would like to award the certificate of appreciation for our technical resource speaker. Let me read the certificate of appreciation. IIA Cebu chapter presented certificate of appreciation presented to the technical resource speaker on the topic potential impacts of high penetration of variable renewable energy sources on the electric network. Given this 2020 Eastern and Central Visayas Virtual Regional Conference via Zoom, given this 18th day of September 2021, signed by Cebu's Chapter President Mario Tabanyag, Regional Governor Felipe Niliama, VP Technical Affairs Lowell Ratilia, Technical Consultant and Advisor Brian Pasilan. Ladies and gentlemen, let's award the certificate of appreciation to Engineer Jules Alcantara. So, thank you very much. Okay, so we'll proceed to the next speaker so that we can, yeah, this will be the last so that we can have a closing ceremony. So it's quite a long day, but I'm sure lots of you have got many informations, many learnings. So the next speaker, his topic will be the types, characteristic and application of electrical bus conductor. Kung sa transportation pa ni, ang bus conductor nila lain pod, no? But this is an electrical bus conductor. The speaker is is a former president of Cebu chapter. He is a gold president because during his term he was awarded gold exemplary chapter president during his time. He was also my former boss, no, when I was in the project of a 13.5 megawatt diesel generator in Cagayan de Oro under the company of GBR Electromechanical Company. GBR Electromechanical Services. Soon to be the governor of Region 7. Ladies and gentlemen, please help me welcome Engineer Brian Pasilan, PEE.
Okay, so good afternoon to everyone and almost good evening. So I'll just have to expedite much faster this last lecture. I know that it's been a very, very long day, very long conference, but with the caliber of speakers that we have these past days, so I presume that we are very full of new knowledge and insights. So is my audio clear? No? Very clear? Okay, so we'll start sharing. No? I'd like to acknowledge, by the way, all the national officers headed by our National President Alan Alvarez, and to all the Board of Governors and Regional Governors who are here right now. So we'll be starting our closing ceremonies after this lecture. Okay. So oops. Yeah. Anyway, this was my last lecture last year, no? So I'll be talking about the types, characteristics, and application of electrical bus conductors. So this is a very different topic, unique topic from our previous speakers, no? As we all know, we've talked about all power systems and motors, equipment. So I've choose this topic, no, just to have a measure of difference, no, among our other topics that we have discussed, no. So This will be the outline. No, we'll be discussing about the objectives of this lecture, and have a little introduction to our discussion. Then we'll be talking about how to select bus conductor materials and bus conductor design considerations, capacities, temperature conditions and operating conditions, altitude conditions affecting these bus conductors, the skin effect and its effects, proximity effect, and the short circuit stresses that will also severely affect, or how to address the impacts of during short circuit conditions, and how to properly support and brace these bus bars. And as well as, if we have the time, the methods of making connections. Okay. So after this lecture, we may be able to have a comprehensive understanding on the types and characteristics of electrical bus conductors. As we all know, this is now very common, no? The bus duct system, the technology, especially for high-rise buildings and very large systems. So we're usually using this right now. So we have to understand the technology to be able to determine the specific applications of these various types of bus conductors, and to understand the design considerations. No, so we will be able to know how to properly evaluate, no, and how to assess, no, the bus conductors with respect to their application. Okay, so first and foremost, we'll have to talk about what are electrical bus conductors. So from the Latin word omnibus, no, this is the etymology of the term bus, no, gives the idea of a universal system of conveyance or transport or delivery, no. So in this case, for electrical systems, we are delivering currents, no. We are delivering currents from one point to another. So that's the term bus, no. So we are actually delivering large amounts or quantities of currents. So in electrical point of view, it is the junction of circuits or connecting these circuits, no? And it may have in the form of a number of inputs and many outputs, no? Just like in this figure, there's a delay. Oops. I think my internet connection is, slide is not moving, no? Some technical problems. Naunay ko sa kuang gi-set up. Okay, so it is 5:30 na, so we are having connection problems right now. Okay, so this is what we call a simple setup, no, of what a bus conductor looks like. So it may have a few inputs and so many outputs, no, or the other way around. So this is just to simplify or to picture out what a bus system looks like, no. So, but the bus conductor is just another means of delivering large currents at a very few components. Okay, so yes, my connection is down. I have to transfer this file to the server. If you may, no, just wait for a little while. This is very hard. The speaker as well as the technical guy. Kailan ko connection dyan? Kailan? So we just try to maintain this connection here. Okay, so just a few seconds now, no? And I'm rejoining. Okay. Okay. So back to where we left off, no? So bus conductors usually takes a lot of forms. These are the following, no? They be either be in bus bars, rectangular bus bars. They may be in round or square tubes. So that's like what we see usually in substations, no? And they might be in the form of power cables or a cable bus, what we term as cable bus system, no? So they take in many shapes and forms depending on the type of application or where they are appropriately being used, no? So we'll explain this later on, when to use rectangular bus bars and when to use round or square tubes, no? There's a rationale for that, no? Okay. So bus bars, no, are usually used in power generating stations, from generator to power transformers to unit auxiliary transformers. So when you are in the power plants, so you usually see these bus bars, no, delivering power from the generator to this equipment. Okay. So yes, large capacity generators up to 1,000 megawatts. So transmission of such large bulk of power is through overhead transmission lines, no, and in substations are carried through bus tubes. So this typical single line diagram of where to use these bus bars. When you see the symbol here, no, oops, sorry. So typical symbol of a bus bar, this one, no, as you can see from the transformer, main transformer to unit transformers to generators, and so on and so forth. Okay, so just to illustrate which sections of the station they are usually being used. So for a distribution system with a nominal voltages such as in the Philippines, 2.4 kV, 4.16, etc., no, they are also being used, no, for medium voltage systems depending on the quantities of currents or power being delivered. Okay, so just a blow-up view of our single line diagram a while ago, no? So this is what we call the bus system, no? From the grid to the incoming breaker, medium voltage breaker, to the transformers, then to the low voltage circuit breakers, no, to the switch gears. So this is where we usually find the bus bar systems. But now in high-rise buildings, we now also see them, no, in the bus riser systems, no, because of the very high demands of high-rise buildings. Okay? So typically, for moderate ratings, no, from 600 to 800 amperes, we usually use cables, no, because of economics and practicality, no. However, when we arrive at the 1,000 amp range and above, it is then recommended, no, to use solid conductors or bus bars, as we say, no. So, but sometimes, even in 1,000 amperes, we also see there are some using still cables or cable system. So it really depends on the engineer in charge or the designer on the practicality of such systems, especially if we go for higher voltages like 480 volt systems, no, So it may still be practical to use cables, but for low voltage such as 230 volt systems, at these current ranges, so cables may no longer be practical, no? So that's the value of also of having used higher voltages, no? Because we'll be reducing the economic impacts in the system. Okay, so we're still in the introduction. I would just have to skip some of this, no? Anyway, I'll be giving these slides. So the main point lang is there are two main conductor materials that we are talking about here, the copper and the aluminum, and we'll be comparing these both materials as to their value of when to use, because this is also a very hot topic. Aluminum is also now increasing or picking up their demand. So just some things that we need to consider before we decide which is to be used on such conditions, no? So as we all know, no, electrical energy also comes with it the heat loss, no? So heat may impair the performance of the system, no, if not controlled in safe limits. So the basic formula of the heat loss or energy loss is I squared R, no? I in RMS times the effective resistance, no, of the conductors, no? So low resistance translates to low energy loss. So that's what we are aiming for. So we have to find the material or the system that gives us the lowest resistance as possible in order for us to control the energy loss or the line loss of the system. So we are getting that out of the way. We are establishing that that's our main objective, no? How to lower the energy loss in the system. Okay. So presently, our facilities like industrial plants, commercial buildings like high-rise are now growing in demand, no? So they give rise to very large forces. So conducting materials such as power cables must be able to withstand the said forces without damages. Okay? So in selecting the materials being used, we have to consider the best possible mechanical properties, no, available. And they have to be designed to operate within the temperature limits. So this is the main point, no? Mechanical properties and the operating temperatures are specified in our standards like IEC, ANSI, etc., etc. So now we go to the selection of bus conductor material. Okay, so this is also quite hot topic: copper or aluminum. So there are many school of thoughts on this one. Okay. So as we all know, wiring cost is really a very significant impact, no? A very significant impact in how we design or how we implement the system, no? But there are some basic characteristics that we have to understand, no, to be able to come up with the best decision as possible. So in this selection, we have to consider, no, that it has to have the high resistance to corrosion. No, is it copper or aluminum? Which is which? No, and it has to have a low electrical and thermal resistance. Okay, so it will have a much better performance in heat dissipation, high resistance to fatigue failure, so mechanical strength in certain conditions, no, and low electrical resistance of surface. So we are talking about contact resistances here, no, when we say about surface resistance, no, between joints, and how to in the ease of fabrication, no. So we have to balance everything, these factors, no, before we come up to the most practical decision which material to be used, copper or aluminum. So we have the common materials. So as we all know, copper has been known to be the best to meet the combination of those previously mentioned properties, no? So this is so far the most popular. But then again, we have the alternative, the aluminum, which is much cheaper and much lighter, no? But we have to again consider some factors before we decide which is which. So conductors have come in various sizes and shapes, no? Depending on the application where it is to be used. So they come in rectangular bus, in tubular round tubes, as we see in power stations, no? So we will now understand, no, why they are being used in such conditions. Okay, so we'll get that out of the way. I've already mentioned that, sound engineering. So the actual current carried by the bus depends on its ability to dissipate heat losses, no? That was one of the main factors, no? Heat dissipation. So especially for indoor installation, we need to be more considerate on how we address that issue, no? So then it comes in the radiation, heat radiation, convection. But for outdoor installations, no, we will have to take care about wind exposure to the elements, to the sun. Okay. So advantages of copper. Okay. So especially hard-drawn copper, the widely used material, it has a low electrical resistance and consequently low losses. As we all know, no, the formula is I squared R. So the lower the resistance, the lower the heat loss. Okay? And has a lower rate of corrosion and high thermal conductivity. We all know that, no, copper is 99% has 99% conductivity compared to aluminum, and a good mechanical strength, no. 98%, I stand corrected, no, for annealed and hard drawn. Anyway, these are just the materials, no, contained in copper alloys. We need to have a copper alloy in order for it to have a mechanical strength, no. So it can be combined with phosphorus, aluminum, iron, tin, zinc, cadmium. Okay. So as shown below, this is just some of the examples, no, as per IACS. No, the IACS states that the percent of copper present in a alloy does not indicate, no, its conductivity. So meaning to say, however much however less the percentage of copper is still the same conductivity. So when we look at Everdure, it is 95% copper and the rest is alloy. Conductivity is 7% as per IACS reference. And then we look at Monel metal, it's only 30% copper and the rest is alloy. The difference of conductivity is just a little, no, 4%. But the difference of the copper is from 95% to 30%, so it has reduced by much. But look at the conductivity, just a 3%, no, difference. And the last example is Durobronze, 97% copper and the rest is alloy. Conductivity is 13%, no? So not much of a difference. So we don't have to take care, no, how much copper it is inside the alloy. As long as it has a copper inside, no, the conductivity percent is not much of a difference. So this is just a reference, no, of different alloys. So how much conductivity it has, no, just a table. So we'll not dwell so much on this. Just to emphasize a point. Now we go to aluminum. Okay. Its advantages and disadvantages. So in terms of current capacity for its given weight, it has much greater capacity, no? For a given weight, it's much lighter, no? Even though it's it requires much bigger cross-sectional area, but it's still much lighter than copper for the same current capacity. However, the disadvantages would be it has lower conductivity than copper, no? And it's much corrosive than copper. It erodes faster than copper, and its conductivity is just around 63%, no? So that's why sometimes when we use aluminum, we size it up 2 sizes higher, no, compared to copper, no? So in effect, in return, we need to size up also our conduits, no, to be used. So we just have to have the balance engineering, which really is more practical, because when we use larger conduits, we'll be using larger trench, especially if it's in underground trench. So civil works now come in. So it's not really automatic that aluminum is cheaper all the time, no? So we have some situations, no, in specific installations as smelter units, no. As we all know, they have very large currents at very low voltages, no. So, meaning to say, we have very many conductors, no, that we be using, no. So mutual induction between conductors now comes into the picture, between conductors and enclosure. Meaning to say, induction heating will now be prevalent in these setups. So as much as possible, we need to limit the number of conductors that we need to install in a limited area. So that's the rationale why we use higher voltages, no, so that lower currents will be delivered, no, or necessary to be delivered. Okay. So then a careful study must be undertaken to properly size the aluminum or copper section. And the bus enclosure also affects, no? We need to derate, because bus enclosure now impacts the heat dissipation of our conductors inside. So in a way, we have to apply derating factors, so to maintain the temperature maximum of these conductors. Okay? So we go now to the bus design considerations. So these are the major design considerations before we design our bus, whether aluminum or copper. So we have to determine first the opacity, or the current carrying capacity, the short circuit stresses. So we still have to conduct fault calculation, no? We cannot get away with that. And the third one would be the methods of making connections. Is it going to be a jointed, spliced, welded? So it matters also, no? So first, the opacity of bus conductors. Okay. So as we all know, every time there's current, there's heat, no? So as there is heat, temperature rise is experienced, but we have to know the permitted maximum temperature rise, so that our equipment will be safely operated, no? Especially on the joints and terminals. That's where our failure is usually, no, mga loose connections, etc. So we have to take care of the maximum temperature. Now, we have to consider the type of material used. Is it going to be copper or aluminum? As well as the size and shape. Is it going to be rectangular or round tubular? And the surface area. Is it going to be a shining material or black? So it also matters, no? The conductivity. Then we have the skin effect, no? So we'll discuss later on the skin effect, especially for AC currents. For DC, there is no skin effect because there's no frequency. But for AC, it's prevalent. It's there, no? And the proximity effect. Proximity effect talks about when we parallel bus, no? The spacing between those bus. So there's an impact also on the current distribution of currents. And the conductor reactance. And also the thickness of the bar, no? The thickness of the bar will also impact the skin effect, no? We will discuss later on. And the type of insulation, no? And the heating, no? The heat dissipation, especially when in enclosed sections, no? So now we talk about current density. So this is the amount of current per square inch of a bus, no? We all know that, no? The bigger the cross-sectional area, the larger the current it can carry for a certain temperature rise. So it's in terms of amperes per square inch. No? So AC and DC buses may vary from these values. So we have the type of bus, which we call heavy current buses. They have a range of 600 to 700 amperes per square inch. Then for light buses under favorable conditions, 1,200 and 1,400 amperes per square inch. So under favorable conditions, no? So we cannot, we have to determine what conditions are these. Then for aluminum, it is 75% of those values. So those values are for copper. So when we say aluminum, we have to reduce 75%. So 75% of 600 and 75% of 1,200. That is the current density of aluminum. Okay, so traditionally, copper is being used because of its rigidity, high conductivity. But now, aluminum is preferred wherever possible because it is more available, especially now if copper prices are rising, no? So, and we all know, economically viable, no? Cheaper. But then again, we have to take into consideration some conditions, no? So aluminum can be used where the metal has to simply carry power, such as for transmission and distribution. So that is why we all notice, no? For distribution transmission lines, they use the ACSR. So there's no other issues on that, no? Aluminum is widely used in those systems, no? Main current conductor for power distribution control equipment, no? They can also be used to feed high current at low voltages to an induction or smelting furnaces and rectifier plants. However, when we talk about switching, fuses, contactors, and relays, copper is still being preferred, no? When we talk about contacts na, no? Switching, because arcing is there. And we all know that aluminum is more corrosive than copper. So that is why for those devices, copper is still preferred, no? And it's still the harder material or the metal, no? And is suitable for maintaining and balancing contacts. So copper is also recommended in more humid conditions and chemically aggressive areas or installations, no? That could easily erode aluminum. So that is the first consideration, no? We have now established which areas that copper or aluminum is at a advantage. Aluminum is not advisable in the following areas: highly oxidizing, because it is a very susceptible metal to those environments, and loose connections is very possible, no? In those conditions. Now, that is for those conditions, no? We have now established what conditions are copper and aluminum are suitable to use. Now we talk about temperatures, ambient temperatures, okay? So for aluminum, its safe end temperature is 85 to 90 degrees centigrade, depending on type of temperature specified in the aluminum, no? So at this temperature, the aluminum does not deteriorate or oxidize as long as it is within these temperatures, no? Does not change its properties, no? For longer periods of operation. So we need to factor out these conditions, no? When we use aluminum for longer hours of continuous operation, like 24 hours, 7 days a week. So we have to look for signs of oxidation, and we have to check its mechanical strength if it does not compromise its mechanical strength, no? Then we talk about high ambient temperatures, no? The ampacities of the bus conductor should be suitably reduced. So we have to derate, no? To maintain the same end temperature, meaning to say, if the aluminum conductor carries 300 amperes at 90 degrees, when it is above 90 degrees, we have to reduce its capacity to below 300 amperes. so that it will maintain its mechanical strength, no? For that temperature. So we cannot carry it anymore to 300 amperes. That's what this is referred to, no? So for reference, we have these derating factors, no? For operating temperature of a specific material for aluminum at 85 degrees, no? So say our ambient temperature is 30 degrees, then we are allowed up to 55 degrees. Beyond that, no, we will apply the derating factor of 1.05. So divide that by 1.05. However, for higher operating temperature of aluminum, no, we are allowed beyond what is 35, so up to 90 degrees before we apply the rating factor of 1.05. So this is just a guide, no? So we have to know our operating temperature of our conductor before we apply the proper derating, and what is the ambient temperature of that area. Okay. So this is just a graph, no, showing what is the effect, no, of our temperature with regard to its derating factor, no. So this one, no. So we have to apply. We have to multiply the derating factor. So the higher the temperature, no, we see we have to multiply by 0.8. We have to reduce by 80%, no, up to this temperature, and then for 90 degrees, no, this column is here. So this is just a guide how to where's those values were derived, no, at this table. Okay. So what are the effects of higher maximum or beyond 90 degrees, as we say, no? So beyond those temperature limits, rapid increase now of oxidation occurs, no? And excessive local heating of joints and contacts, so loose connections na. And corrosion now is very, very increasing, no? Rapidly increasing. So we have to maintain the temperature limit, especially for aluminum. We can be generous with copper, but for aluminum we have to be strict with the temperature limit because aluminum corrodes faster than copper. Okay. So at 90 degrees, aluminum now starts to oxidize. No? So oxides of aluminum and copper now is maybe poor conductors of electricity and may adversely affect the joints, no? And reduces their ampacity over time. So it means it leads to overheating and causes failure. Okay. So recommended practice is to limit the operating or the temperature rise of bus conductors up to 85 to 90 degrees for all ratings, no? At least in the medium loading up to 3,200 amperes, no? So this is a general guideline, okay? So we have to be mindful of these limits, no? Now we talk about silver oxide, no? It's not a common conductor, but it is usually used for welding joints and conceal the inside surfaces from the atmosphere. So it's a good conductor. We see this in plants, no? Kanang mga sulfuric plants, they use sulfur oxide contacts, no? So prevents contact surface from oxidation. The only setback of silver is much costlier than copper, but it has specific applications, no? Okay, so much for that. So okay, so for mechanical strength, aluminum conductors can be operated up to 125 degrees before it starts to weaken, no? So it has, for mechanical strength, it has much higher temperature, but then again, we have to consider the oxidation, no? But for mechanical, it is much higher. So this is just some of the illustration, no, of disadvantages of operating at high temperatures, okay? So we can increase, no, the operating temperatures of our bus system aluminum or copper when we apply silver plated on welding joints, no? So we can operate it up to 105 degrees centigrade, no? So, and the temperature limit of bus system enclosure that at locations that are safe and accessible can be allowed to operate up to 110 degrees centigrade. Meaning to say, in enclosures that cannot be accessed by human intervention, no, our material is safe at these temperatures, no? Okay, so just a guide, no? So maximum temperature limit, no? For plain connection joints, 70 degrees. But when we apply silver plating, we can increase up to 105 degrees, no? So for enclosures like bus ducts, no? Bus panels, for sections that can be accessed by humans, allowed temperature limit is 80 degrees. But for areas that cannot be accessed by humans, it is allowed to operate at 110 degrees, is still safe, no? So then again, for sound check, okay. So for connections that are plain, 70 degrees, and applied with silver coating, it's 85. That is inside enclosures, huh? Don't be confused with the value above. So the 105 degrees is on the outdoor, no? Not inside the enclosure, but when you put it inside the enclosure, we reduce the operating temperature by 85 degrees. So this is just a graph, no? What is the effect of temperature at longer periods of time to its mechanical stress? Okay, so at 200 degrees centigrade at 10,000 hours, so we now see that it has reduced its mechanical strength by this much, no? Compared to the 65 degrees, no? So taas-taas, mas taas pa yung mechanical strength niya doon. Okay? Now we talk about altitude limitations, no? Where we put our bus conductors from the sea level, no? This is the electric strength that we talk about for these insulators. So for low voltage systems up to 2,000 meters, no? It can maintain its dielectric strength, no? For low voltage, but for medium voltage, we reduce it by to 1,000 meters before its dielectric strength is compromised already, no? So beyond those altitudes, we now have to adjust our dielectric strength. How? By increasing, no? The clearance and creepage distance to ground, no? So what are the clearance and creepage distance that we are talking about here? Okay. So when we increase, no, beyond 1,000 meters or beyond those limits, so we increase the creepage and clearance distance by 1% for every 100 meters rise in altitude. So when we increase by 2,100 meters, then we have to increase these distances by this much, 1%, no? Okay? So, creepage distance, what is this? Okay. Creepage distance is the shortest distance along the surface of a insulating material. So, as you can see, this is terminal A and terminal B. Where is the creepage distance? The insulator is here, no? So, this is the distance between two conducting materials and the insulator in between. That's the creepage. The clearance is the shortest distance of the air distance between these two terminals, no? So that's the difference between those distances, no? The creepage is the insulation distance between, or the solid insulation between two terminals, and the clearance is the air distance between. So we need to increase these distances by 1% for every 100-meter rise beyond 2,000 and 1,000 meters for low voltage and medium voltage. Okay? That is per IIC 61439-1. Okay. So other examples of creepage and clearance for more clarity, no? So that is what is how to address when we increase altitudes, no? To maintain the same dielectric strength, no? So this is just a table, no? For enclosed bus bars, no? With a certain voltage, no? So minimum clearance to ground in air is 16, no? 16 mm. Then between phases is 19 mm, and to other voltages, so on and so forth. So we can use this table, no? To check, especially if we order fabricated bus enclosures, we have to check with our manufacturer if they have followed these standards. No, that is one way of checking. Okay, we now have means, so we don't have to accept immediately, no, what they are being offered to us. We have to check. So that's why we require shop drawings, so we can check on these distances. Okay. So just another tables, no? Okay, additional resource materials, no? So creepage, the other one was clearance, this one is for creepage. Okay? Now we talk about skin effect. No? What is skin effect, by the way? And why do we have to be concerned with skin effect? So for DC systems, no, the current is uniformly distributed, no, in all of the sections of the conductor, no. So we all see that the current is evenly distributed. But for AC, this is what happens, no. The interior portion of the conductor has no or lesser currents. Only the outside filaments of the conductor are present with currents. Actually, this is the principle of the round tubular conductors. Hollow, the inside is hollow, no? Because we don't need the interior portion of the conductor anymore, no? The only problem with that is rigidity, no? If we put it a hollow, we need to have a thicker round tubular, no? But in principle, the interior cross section is useless na, no? So that is the problem with skin effect, especially for AC systems, no? And the higher the temperature, the higher the non-uniformity of currents. Okay. So much for that, no? This is because of frequency, no? DC has no frequency, so no skin effect. Okay. So just visualization, no? Okay, some examples, no? So lower frequency, we see this one. At higher frequency, the current is now outside portion of the conductor. Okay. So what affects, or what are the impacts of skin effect? So inductive reactance, no, affects. That's why we have the skin effect ratio, no. So conducting more current, AC current, no, at the outside na. So overcrowding now of the surface skin of circular to the edges of the flat strip. Okay. So it reduces the effective cross-sectional area. So in a sense, for a DC conductor, if we carry 100 amperes for this square area, in AC, it's no longer 100 amperes. It's already around 80 or 70 amperes na. That's the problem with skin effect, no? Okay. It increases resistance, essentially, no? And more heat loss. So that is the problem with skin effect. Okay. So when we talk about AC and DC resistance, we have to mention the skin effect ratio, no? So the skin effect ratio is the ratio between the AC effective resistance between the DC resistance of the conductor, no? So when we talk about how much effective resistance, we have to deal with skin effect ratio. And usually its value is more than 1, no? Above 1. Okay. So I mentioned a while ago that as frequency increases, the more the non-uniform is the current distribution of the conductors, okay? And skin effect is even significant at 50 hertz, no? So it affects not only single conductor but the group of conductors, no? So that's a demonstration what's the impact of skin effect in increasing frequency. So at 60 hertz, this is distribution of current. At 100 hertz, the current is here now outside. And at much higher frequency, this is now the current, no? So in a sense, if we want to carry this much current, we have to increase the cross-sectional area in order for us to carry this amount of currents at these frequencies, no? That's the impact of skin effect of the frequency, no, to the conductors. No, it's much costlier na. Okay. So I mentioned that, no? I will not go back na. So if we maintain the same cross-sectional area, then heating increases. So that's why we have to either derate the capacity or we have to use much bigger cross-sectional area. So just the impact, no, the heat loss, it's I squared R. So the resistance that we have to use is the effective resistance, not the DC resistance, okay? So when we want to determine how much current is being reduced, we can compute, no? So we have this relationship between the heat loss of the AC and the heat loss of DC, no? So with this formula, we can now compute how much AC is reduced, no, because of the skin effect. So it's current DC, the square root of DC resistance over AC resistance. So we can now determine how much current is reduced. So just to take note, no, as conductor temperature increases, skin effect decreases, no? So in a way, if the conductor temperature increases, the resistance decreases, no? So that's the nature of our conductor copper material, no? So as temperature rises, the resistance reduces. Okay. We cannot notice that difference, no, in smaller systems, but for bigger systems, we can definitely see, no, the impact of temperature. Okay. Now we talk about the shapes of bus conductors. We already discussed the temperature, the type of material being used, in what conditions, and now we talk about the shapes, no? So flat bar conductors, where are they? What are its characteristics? Okay. So skin effect in bus bars, flat bus bars, no, is concentrated at the edges of the bars, no? So with the larger size of conductors for given cross-sectional area, skin effect in thin flat bar strip is usually less than that of a circular rod for a greater thin tube. So in a way, it is recommended to use thinner bus bars with smaller widths compared to thicker bus bars and larger widths. We will see that now. What's the impact of skin effect, no? So the skin effect is dependent on the ratio of the thickness and the width, no? Or the width and the thickness. So as the bus bar increases or the thickness increases, okay, or the skin effect increases as the bus bar thickness increases, no? So that is why it is recommended to use thin conductor strip instead of thicker conductor strip for these reasons, no? So when we design, as much as possible, we select conductor strips thinner and much less wider compared to bigger and thicker bus bars, no? We can see that in our skin effect impact, no? And it has much greater surface area for cooling and more uniform current density. Okay. So the use of bus bars, no, up to 4 sections is recommended, no? For systems 2,500 to 3,200 amperes, no? It's fairly common, no? But for higher current ratings, the use of more than 4 bars in parallel is not advisable na. No? It's not practical na. So what should we do? We increase the voltage system, operating voltage system, so that we will maintain the 2,500 and 3,200 amperes. Okay? So please tell me how much time do I have na? So, I will have to expedite much faster my slides, no? So this is just a guide, no? 2 hours and 15 minutes. Okay, so pardon for us for the time, no? I'm just making these slides. I hope clear lang akong pag-explain. Okay. So that is what we discussed, no, a while ago. The A is the width and the B is the thickness, no? So this is the ratio. So we can say if the ratio is 1, no, this is the skin effect, no, skin effect ratio, no. But if the ratio is 2, thicker na and much wider, or depending, no, so the skin effect is much higher, no. So on and so forth. So we have to use thinner and much lesser wider, or much lesser width of bus bars. Okay. Okay. So I will not discuss now on direct current buses. It has its own advantages na, no? Okay. So direct current buses has no problems with skin effect. We all know that. But when we talk about AC buses, no, capacity problems are now complicated, no? A single bar is the most efficient, no? But when we parallel with first and close spacing, no, it doesn't mean to say that the capacity increases with the same cross-sectional area, no? So when we say single bus bar carries 300 amperes, when we parallel the second bus bar, it's not automatic 600 amperes, no. There is the derating because of the skin effect. So it may reduce now by 80% na lang. So instead of 600 amperes, it will only carry now 500 or less. Yes, that's a problem when we parallel. So that's why we need to be concerned every time our manufacturer parallels bus bars on switch gears. So we cannot say that if this cross-sectional of bus bar carries 600, when we put in the second bus bar, it's not automatic 600 amperes. There is the derating there, no, because of skin effect. It's again pinto sa skin effect group. Atong ikiha, okay. So this is the explanation, no. So all the conductors together may be considered as forming a large conductor for the purpose of analyzing. Now the bulk of the current will be shared by the end conductors and only partly by the middle conductors. As we all know, the explanation kanina, no, that the inside portion of the conductors has no current na, or lesser current than the outside. So this still holds true when we parallel bus conductors, no. The currents are now flowing outside of these bus bars, and the inside portion has lesser or no currents. So this is the nature of bus bars. Okay? So figure 8, no? I will just give you the figure 8, so the approximate sharing. So this is a figure. So for one bus bar, they have 100% sharing. You see this letter A? So this is the current sharing of the 3 phases. So when we use one bus bar for each phase, the current distribution is 100% among these 3. But when we start paralleling now, no? So the current distribution is reduced, no, only by 50%, no? Or I think they're still equal, no, almost equal. But when we use more than 2 na, as we can see, the current sharing is not equal. This one, the outer layer, has 36% of the total currents sharing. The middle one is only 28%. And the outer one, the right side, is 36. So it is now not evenly distributed among the phases or among the group of conductors. same as with this one. And when we put in the fourth conductor, no, we can see this one is 30%. This one at the middle is 20, and the adjacent one is 20, and the outside one is 30. So this demonstrates the current sharing, the uneven current sharing when we parallel bus conductors. So that explains sometimes in our switch gears, we will see that we experience that abnormal heating, but the load is just by this much, no? So this is probably one of the reasons why that happens, no? So we have to be prudent with our derating of our bus bars. So now we have a way to check our manufacturers, have they considered this one, the skin effect, no? Because as we can see, when we specify 2000 amperes, so they give us this current density of 1000 per square inch, no? So they just give us two parallel bus bars, but it's not automatic 2000 amperes na, no? It just be 1800, no? So we have to size up properly, okay, when we parallel. Okay. So this is just a table, no, for current capacity of bus bars when we parallel. Now I just give you this one as a resource. You can use this one for your design or for evaluating our manufacturers if they follow these standards. Okay. For aluminum bars, the previous one was for copper. Okay. Now we go to round tubular conductors. We always see this one in substations of our distribution utilities. No, why they use this one and not the flat bars? Okay. For round tubular conductors, they have a better current distribution than any other shape. This is the reason why. No, they are not so prone to skin effect. So this is the reason why. No. So at 60 hertz, no, the AC to DC resistance ratio is small for round tube, no, for less than 0.25 inch thick, and even more for 0.55, no. But beyond that, no, the AC resistance now increases until it reaches a thickness of 1 inch. So that's what we have to consider lang, no. What is the thickness of our round tube bus bars? But generally, they have a much better current distribution compared to flat bus bars. So that's why they are being used for substations. So this is just some of the examples, no, of round tubular conductors. Okay. But the problem is they have a relatively small surface area for dissipating heat loss. That's its drawback lang, no. So we have to size it up properly if we want to take care for heat dissipation. Okay. But doesn't mean that it cancels out its advantage. We have to properly design lang. Okay. So this is just a table of skin effect for round tubes. No, this is just your guide. No, the ratio is RAC to DC. So we have now the table if you want to solve for effective resistance. Okay. So this column here is the skin effect ratio. No. And this one here is the rate, no, or the frequency. Okay. So round tables. Okay. And skin effect ratio of varying wall thickness. So if we change the thickness, we have the corresponding skin effect ratio for different thickness of tubular bars. Okay. So other advantages of tubes, they have large cross-sectional area, no, in minimum spaces and maximum structural strength for the same cross-sectional area. So they can permit to be installed in longer spaces between supports. So that is the reason why they are being used for transmission and or for substation, no. So they don't require so many supports because of its structural strength. Okay. So in outdoor substation spans of up to 40 and 50 feet, no, copper or aluminum tubes up to 6 inches in diameter is recommended, no. So when we reach this span of 40 and 50 feet, we have to select 6-inch diameter of round tubes, no, because the tendency of the design is to use long spans to reduce the number of insulator posts for economic reasons, no. So other advantages is less skin effect resistance than compared to flat bus bars, naturally, no? And most efficient, no, with regard to skin effect. Okay, so just to demonstrate, no, the skin effect reduces as the diameter increases for a constant wall thickness, no? So it will be constant until it reaches to the ratio of about 20. So the ratio that we are talking about is this one, no? Diameter versus the thickness, no? So this one, okay? So it reduces as the diameter increases, no? So maintaining this thickness here and increasing the diameter will reduce the skin effect. That's one of the strategies, okay? So calculation of skin effect, I'll just give you this one, no? You can follow this calculation lang. So we need these datas, no? So we have the table, so we can use the table instead of computing. Now proximity effect. So I have 5 minutes na lang, no? So I still have 60 slides more to go. Sige lang. I'll just give you this material, no? So lang, this one na lang, proximity effect. This one is different from the skin effect, no? So the nature of this one is the magnetic field around each conductors overlaps the fields of the others, no? So it may not be clear, but I'll give you a picture of this one. So for conductors of the same circuit, the currents are in opposite direction. So the same also with the field. So we all know that when they counter each other, no, they will repel each other because of their opposite directions, just like in unlike poles, no. Okay, so this one is what we are talking about, no. So we have RYB conductors, no, inside a conduit. Now, the current flowing from the R conductor is clockwise, no. The current flowing also in Y is, or the field is Y, no. And for B is clockwise. Now we can see now the relationship here. When the field reaches at this point of the conductor Y, the field is, what is the flow? Opposing. So it's opposing, no? Same as with the other side, it's opposing. No? So what happens? It now affects the effective resistance of this, of the conductor at the middle. No? So the conductor at the middle now has higher resistance compared to this other two. No? So current distribution is now also uniform. So it aggravates further the condition of the non-uniformity of current distribution. Okay? So the net result, displacement of their magnetic centers as far apart as possible. So unbalanced na yung current distribution natin, no? In a sense, no? I just have to simplify na lang. Okay. So main point is the current density will now be greater on the side nearest the adjacent conductor, the R and the B conductor, no? Most of the currents are now there, no? Okay. And least at the new magnetic center. So this causes further increase in AC resistance. So we all know that heat also is in effect. So that is the problem with proximity effect ratio. So the difference, we now see the difference between skin effect. Skin effect is within the conductor itself, no? Proximity effect is the effect between among the conductors because of its opposing magnetic fields. Okay. So this is a picture of what happens, no? So we have this conductor here, opposing fields. So current distribution is hollow, and the other one, the outside now is on the other side is have the much larger current distribution. Okay, so it aggravates further the situation of the skin effect and proximity effect. Okay. So in certain types of circuits such as low voltage, okay, we have to be considerate with the spacing. So we cannot space as close as possible, no? So there is no table for proximity effect. We have to calculate. We have to calculate, no? Because of varying degrees of combinations. Okay. So we have a formula, no? In the relationship lang, we have to talk that it is directly proportional to the current magnitude and inversely proportional to the spacing between conductors. So the longer the spacing or the wider the spacing, the lesser the proximity effect. So that's why when we parallel bus bars, you have to put space in between bus bars. No? We cannot parallel bus bars directly in contact with each other. You have to put spacers. So when a manufacturer gives us a panel board or a switchgear with very close proximity among parallel bus bars, we have to return to sender the panel. No? It's not conforming to standards. Okay? So another impact is voltage unbalance. Okay? So I've mentioned that already, no? The cumulative effects of the fields. Okay. We can skip this. So this is the formula. So if you have the time, you can trace this formula. I think we all know how to compute the GMR and the GMD, no? Over conductors, the PEs. As aspirants, you have this one, no? So if you get the GMD and GMR, you can now compute for the skin effect or the proximity factor, no? Okay. So this is RO, which is DC resistance, R over RO plus the factor for proximity effect. So we can just play with this equation. We can get the proximity effect factor. Okay. So this is just of the impacts. Okay. So there's one way of addressing proximity effect transposition. 1 minute na lang. Okay. So transposition, especially for longer lines, we see that in transmission lines, no? They transpose the RYB. So we start with RYB. Then for certain distance, we transpose Y and X, no? Then we transpose again to the other section. So that's one way of reducing proximity effect. The other way is usually for 50 meters and above, no, 2000 amperes, we do transposition. Or we introduce reactor core on the conductor that is having a much current distribution, no? So we can insert this reactor here, no? So we can reduce the current distribution depending on which group is having the imbalance. No, that is one way of if especially if the voltage unbalance is very significant, then we can put in a reactor among this group. No? Okay. So arrange it in a trefoil. No, it can reduce. No, trefoil arrangement of the conductor. So that's what we usually do in cable trays. We arrange it in trefoil configuration. Okay. So I think for enclosures na lang, we have to deal with temperature, no, dissipation, no. So I'll just give you this one. Okay. And we have to talk about short circuit stresses. What are the impacts of short circuits? So it can deform. So every time there's a short circuit, this is what happens to our conductors, no? So we have to compute. So I just have to give you na lang the relationship of the maximum, this one, no? The force, magnetomotive force, no? Experience in pounds per foot, no? So I'll just give you this one. But the important thing is we compute we do fault calculations, no? In order for us to determine this one. Okay? So I think time is up for me. And thank you everyone for, I'll just give you these slides, no? Just for your reference, and just play along with this slide, because when I gave this lecture, it was for about 2 hours or more. So I've just condensed this one, okay? So thank you very much, and good evening.
Okay, thank you, Engineer Brian. So, let me award this certificate of appreciation. Sir, IAE Cebu Chapter Certificate of Appreciation is presented to the technical resource speaker on the topic types, characteristic, and application of electrical bus conductors. The certificate is given to Engineer Brian A. Pasilan. So, a warm of applause. Okay. So, we are now in the closing ceremony. So, we have to move fast because the skin effect can now be seen. There are two skin effects: skin effect of a pork lechon and skin effect of a pork chicharon. Oh, so, no? Kainan na yata, kaya yun ang nasa na makita ko. So to introduce the keynote speaker, he is the chairman of Electrical Engineering University of San Jose Recoletos, a former IIE Cebu chapter president. So without much ado, ladies and gentlemen, please help me welcome Engineer Ruel Militar, PEE.
Thank you, Bob. Our keynote speaker for this closing ceremony was an British scholar who finished 8th place in October 1990 Electrical Engineering Board examination. He is the President and Chief Operating Officers of the Officer of Visayan Electric Company in Cebu City. A professional electrical engineer and registered electronics engineer, he is an alumnus of the Don Bosco Technical High School and the University of San Jose Recoletos. He joined British Power in November 1990 through Davao-based utility, Davao Light and Power Company. He obtained his master's in management degree from the ASEAN Institute of Management. He was the Vice President for Engineering of the British Power Distribution Utilities before taking on a new assignment in Visayan Electric Company. Ladies and gentlemen, please help me welcome our keynote speaker, Engineer Raul C. Lucero.
Okay, so good evening, everyone, my fellow electrical engineers, master electrician, and our students. I think we are 1 hour behind schedule, so I think that schedule is worth it. No, we have exceeded. So I can see familiar names in the panelists. Our colleagues in the power industry. And I think we have a fruitful and lots of learning. First, let me congratulate all the officers, all the various IIE chapters, the organizers, and the speakers of this IIE regional conference for a very successful and well-attended conference. Before we end our virtual 20th Eastern and Central Visayas Regional Conference, I would like to revisit our theme, that is transcending the challenges in the new normal by embracing resiliency and complementarity. The COVID-19 pandemic has changed and transformed our lives. We can see it. It has posed a lot of challenges to industries, organization, our businesses, our profession, and most especially our families. 2020 and 2021 has been unprecedented years. It has forced all of us to lower our expectations from living out our dream to simply surviving, coping, and thriving the challenges of the times. It disrupted our daily activities. How do we now operate our businesses with all these limitations and fear around us? How will we travel? How do we do our work? How do we support and protect our families? Or how do we learn? These are some of the challenges we face. During the last 2 years, we have proven to ourselves that we can overcome these challenges, overcome our fears of the virus, and have adjusted. And we have become resilient to the situation we are in today. The COVID-19 crisis offered us a chance to adapt and evolve as we try to conform to a new lifestyle. This crisis is boosting innovations with the emergence of many new brilliant ideas. Working from home is one of the significant innovations to come out of this pandemic. The adoption of remote work has proven that people can work or be still productive without being physically in the office or in the workplace or without their supervisors looking over their shoulders. Virtual meetings, conferences, and interfaces like what we did during these last 3 days are among the innovations we have seen. Online education has become the new way of learning. We call it learning. These methods may not be as effective and efficient with face-to-face meetings, but this has addressed the concern of the need to meet each other. We have bounced back. We, the electrical engineers, have developed this we can do attitude. We have become resilient. Now, we have this other word in our theme, complementarity. If you look at Google, complementarity means this is a theory, this is social psychology that proposes that we seek traits and qualities in social relationships that fill gaps in ourselves. So, for example, my work requires me to determine the fault level in a certain application. But I already forgot how to do fault calculation. This is the gap in me. So what do I do now? I will go out and find where or who can teach me how to do fault calculation. Earlier, you've heard our lecturers. So one of the venues to learn this is to attend the IIEA Regional Conference and listen attentively to the lecture of Engineer Luna around fault. If we look at the various topics presented and discussed during these last 3 days, we can see that we have a lot of experts within IIEA with various fields of specialization of practice of electrical engineering. So the concept of complementarity simply suggests that we learn from other people, from the experiences from other engineers, like what we are doing today. So we ourselves become knowledgeable and skillful. In closing, I really hope this 20th Eastern and Central Visayas Regional Conference strengthened our determination to be resilient amidst the challenges we face with this new normal in our society. and continue to learn and share our experiences with each other. May IIEE, as an organization, continue to foster complementarity among all of us, electrical engineers and electricians. So thank you and good evening, everyone.
Thank you, Engineer Raul Lucero. Before we let you go, we will do the awarding of plaque of appreciation. May I request, before I'll do this, I will read the contents of the certificate of appreciation. IIE Cebu chapter present the certificate of appreciation to the keynote speaker of this 20th Eastern and Central Visayas Virtual Regional Conference via Zoom, held on September 16 to 19, with the program accreditation number Oscar Echo Echo 2020-007-308, with approved 25 CPD points given this 18th day of September 2021. Signed, President of Cebu Chapter, Engineer Mario Tabanyag, Regional Governor, Engineer Felipe Neliama, VP Technical Affairs, Engineer Ruel Ratilia, and Technical Consultant and Advisor, Brian A. Pasilan. So may I pass this to the President and the Governor. So congratulations and thank you for being our keynote speaker, Engineer Raul Lucero. A warm applause.
Thank you, boss, and to all the officers of IIE Cebu. Thank you very much.
You're welcome. Okay, so we'll now turn over this the microphone to the official closing of the 20th IIE Eastern and Central Visayas Regional Conference. But before that, I would like to inform the participants and the delegates that there will be raffles. And tomorrow, there will be an we have an activities, a virtual plant tours. So there will be 1, 2, 3, 4, 5, about 5 plants, but it's good that it's a virtual. So I will now turn over this floor to the Regional Governor, Engineer Felipe Neliama. A round of applause, please.
Good evening to all. Before I close this regional conference, I would like to thank all the men and women who made this activity successful. First, we would like to ask in behalf of IIEE Cebu chapter, which is the host chapter, to all the sponsors, major sponsors, and also the participants, the delegates who participated this remarkable activity of IIEE, Eastern and Central Visayas region. And lastly, to all the IIEE Cebu Chapter Board of Directors, headed by their President Mario Tabanyag. And also special thanks to Engineer Brian Pasilan, who made night into day, no, to have this activity very successful. Sir Bry, thank you very much for the support. And now, by the virtue vested in me by the Constitution and bylaws of the Institute of Integrated Electrical Engineers of the Philippines Incorporated,
as the Regional Governor of Eastern and Central Visayas Region, I hereby declare that the virtual IIEE 20th Eastern and Central Visayas Regional Conference officially closed.
Congrats, Go and Team Cebu.
Thank you, NAPRES. Thank you also for the support.
Congratulations, Cebu.
Congratulations, Go. Good job, Cebu. Congratulations.
Congrats sa lahat.
Congrats.
PNC.
Congratulations. See you tomorrow.
Thank you. Thank you. Thank you. Kain na tayo ng skin effect. Okay, kantahan na. Fellowship again.
Fellowship night. Also, I would like to thank also our national president, President Alan Alvarez, for helping us the whole duration of our 4-day activity, the regional conference. Also to Miss Anne Golien of Marketing, IIE Marketing National, for helping us for the sponsor for the event hub. To Mr. Silverio Gregorio, who made our IT here, Link, National, IIE National, and our Cebu IT. And all to the Board of Governors who helped this activity also possible. Again, thank you very much and good evening. Keep safe to all. Mabuhay IIE.
Okay, wala pang nanalo sa Mobile Legends, so tuloy-tuloy pa rin yung tournament. Mobile Legends, tuloy-tuloy pa rin yung tournament, so so we will announce that who will be the champion of the Mobile Legends, first, second, and third. So, okay. Okay, well, like to acknowledge again the Evergreen Virtual Exhibitors, Landlight Philippines Corporation Power Equipment and Supplies, Emerald Vinyl Corporation, Himax Electronics Corporation, Pacific Power Incorporated, Epitax Claro, Philippines Incorporated, Control Gear Electric Corporation, IMAX Energy Solutions Corporation, Sipang Automation Philippines Corporation, Silin Electric Corporation, Philippine Representative, Himmel Delexi Electric Limited. We have Dong Ai Enterprise and Dong Ai Panel Board Fabrication, Dutch Energy Philippines Incorporated, Prisma Electrical Controls, Panasonic, 3M Philippines, Losares Solar, and Brills Huawei, Exponent Controls and Electrical Corporation, Nodal Electric Trade and Services, United Electrical Specialists Incorporated, and all other sponsors. Can we play the souvenir program, Sir Brian? Would like also to thank the souvenir program sponsors.